Okay, please be seated. Coming up. Yeah. Should we start? Okay. Good morning, everyone. It's another very happy day. I didn't introduce myself yesterday properly. I even didn't say my name. So today, I think I'll take an opportunity to introduce myself. I'm In-hee Kim, Associate Professor, Graduate School of Jochon-sik Graduate School of Mobility at KAIST. Welcome all of you guys again, and also welcome from the YouTube, all people from all around the world. If you guys are watching the YouTube, please subscribe our department channel. We had a wonderful 10 talks yesterday, and also we're going to have another 10 fantastic talks today. Before it starts today's session, I'd like to introduce my friend Gite, a director of KAIST Mobility Institute, professor at the same department. Please welcome Gite-chan.
Good morning, everyone. I'm here this morning because our friends Milad and In-hee told me we need someone to start the day. So they put me in the very early in the morning after the very exciting night yesterday. This was a really challenging task for me to prepare for all this speech. It's a very great pleasure to see many of you return for today's session. I also see the new faces, and I hope you all found yesterday's discussions insightful and very intriguing. As we gather for day 2, we are reminded that collaboration in tackling the challenges of crowd safety are very important. The conversations and ideas shared yesterday were amazing and deliver meaningful progress. And let's keep this momentum going today as well. This summit, held in Itaewon, a community known for its diverse and dynamic public events. This offers us the perfect setting to explore the complexities of crowd management in real-world environments. I think this was one of the factors for Itaewon tragic events. Such events should not happen anywhere in the world. So all of us here are committed to public safety and innovative solutions to prevent such tragedy again. I'm excited to be a part of the discussion about the very principle of crowd safety itself and all the preventive measures here. Today, we will continue our discussion to dive deeper into the latest research, best practices, and cutting-edge technologies shaping the future of crowd safety. We will hear from experts in the field, exchange ideas, and explore new strategies for improving safety in all events. I encourage you to take full advantage of the sessions today, connect with the fellow participants, and share your expertise as we work together to build safer, more resilient crowd management practices worldwide. I look forward to another productive and inspiring day at the Crowd Safety Summit 2025. Thank you very much.
Yeah, I don't believe Gite speak a very short speech. It's rather long. Now I'd like to welcome Milad to lead these sessions today. Milad, please.
Thank you very much, In-hee, and thank you very much, Gite, for your warm welcome and for everything that you have done to make this wonderful event happen. This is really owing to your great efforts behind the scene and organizing this beautiful venue and every arrangement that we needed to make in order to have this productive event. What a wonderful and productive day we had yesterday. Thanks to the insights that our keynote speakers shared with us, and I'm looking forward to the speeches from our other keynote speakers today. We have 10 more speeches scheduled for today, and we are looking forward to having a fruitful discussion during the Q&A panel discussion sessions. As I mentioned previously, we are going to monitor the questions online as well. So if you're joining us via YouTube, please make sure that you participate in the panel discussions and share with us your ideas and questions, and I will be happy to convey your questions to the panel members. And exciting news, at the conclusion of the event today, we are going to announce where the next Crowd Safety Summit is going to be held. So please bear with us, and at the end, we will make that announcement. Excellent. So let's go ahead and start our first session. We're going to have a lineup of fantastic keynote speakers today, and I'm personally looking forward to enjoying the insights that they are going to share with us. Our first speaker is Professor Nan Li, who has kindly joined us and traveled for this event from China. I'm very grateful that you're here, Nan. Professor Nan Li is the Dean at the Department of Construction Management, School of Civil Engineering, Tsinghua University. His research focuses on understanding and improving the resilience of built environments, including buildings, infrastructure systems, and humans whose needs they serve by extensive applications of advanced computational approaches. Please make him feel welcome. Thank you very much.
Thank you very much, Milad, and good morning, everyone. It's a great pleasure and honor to be here, and thank you very much to the organizers and the hosts of this great event. It was a pity that I had to miss the presentations yesterday. I had to teach yesterday, and I just arrived last night. But hopefully, what I'm going to share today could provide a little bit of enlightenment to begin the second day of this great event. So what I'm going to talk about today is some of the latest and ongoing work in my group at Tsinghua that looks into the effects of a social relationship on the pedestrian evacuation behaviors. So I believe that everyone in this room and those who are watching the YouTube stream, the YouTube channel, knows very well that building fires continue to be one of the major threats to the safety of building occupants. And I believe that everyone also knows very well that human behaviors during evacuation are quite complex, and such complexity has a great impact on their evacuation performance and the outcomes of the evacuation. Therefore, has a lot of implications for their overall safety. But what we do know is that such complexity of the evacuation behavior is rooted and impacted by a wide range of factors, among which one that plays a major role but is relatively unexplored is the social relationship between the pedestrians or evacuees. It's very common that the evacuees, they have some sort of pre-existing relationships among them, being friends, the family members, classmates, etc. And such social relationship have a lot of impacts on their interactions and their collective behaviors through norms, emotions, visual cues, communications, and many other influence paths. And ultimately has a lot to say in terms of how they move, how they make decisions, how they help each other, etc. during the event of a crisis, such as fire emergencies. A number of prior studies have already found that social relationship could significantly affect the evacuation at multiple levels of the humans' navigation decision-making, including the operational, tactical, and strategic levels. And many real-world fire incidents have also demonstrated repeatedly and sadly that social relationship could have a great impact on what people pursue, how they behave, and what routes they choose, etc., during building fire emergencies. And in some extreme cases, such relationship could have a very fatal impacts on the evacuation outcomes, causing blocks of casualties in in number of reported fire cases. So it cannot be understated that it's the importance to better understand the effects of social relationship on evacuation behavior. So to investigate this issue, we have made several efforts. Firstly, we observed that in the existing literature, most of the prior studies have considered a social relationship as a categorical or binary variable. They investigate whether the social relationship exists or not and what impact it would have. However, drawing on a lot of studies on social relationship in both normal and emergency conditions in sociology, including some of the seminal work by John Jory, we believe that social relationship can be formed and they could help people forge small social groups, not only among those who have pre-existing social relationships, but also among strangers who may find themselves to share a common sense of a fate, particularly during crisis. That being said, it means the social relationship could exist among those who don't know each other when they evacuate together, faced with the same emergency situations. So it's treating a social relationship as a categorical variable may oversimplify the influence that this variable could have on the evacuation behavior and would prevent us from understanding some nuanced complexities here. So again, also joined upon research in sociology. So we have introduced trust as a proxy to help us to quantify the strength of a social relationship. And this would help us operationalize this variable and treat it as not only as a categorical variable, but also as a continuous variable when necessary. And that would allow us to better understand how people with different levels of strength of a social relationship would interact with each other and what differences we could observe during their interactions. So what we did in an experimental study, the overall idea was simple. So we create, observe, and measure the level of trust among people who have different types of and different levels of a social relationship during emergency evacuation scenario, and then try to capture and compare their psychological responses to the emergencies and how they coordinate with each other and how they make decisions collectively during the evacuation events, and try to understand what role the social relationship plays here in shaping their behaviors and their decision making, etc. So we adopted an experimental approach. So it's nowadays it's quite common to use virtual reality to study human evacuation behavior, particularly because of its advantage in presenting the crisis situations and induce the stress among the study participants. But we actually started doing this about 10 years ago. So we were among the first few groups doing this in the area. But now when we are considering of doing the studies around social groups and the social relationship, one limitation that we observed in the literature is that until the paper that we published last year in Transportation Part C, until then, there were very few studies that actually allowed multi-participants to interact in real time in a shared virtual environment. Even for those studies that simulated interactions between participants and other people, those other people were mostly, in most cases, you'll see they were NPCs with pre-coded behavior rules. So such, the mandated behavior rule would prevent us from really understanding the nuanced interactions among the real human participants. So what we did, firstly, we developed a new multi-participant VR evacuation experimental platform that would allow multiple participants to be immersed in the same virtual reality environment while they are physically situated in the same room, like in the laboratory environment. So we could measure their actual interactions in the virtual world, and using the behavioral data that we could collect in such experiments to understand their interactions. So this is so we allowed a pair of participants to evacuate together. You can see and hear
看到你了，我跟着你呢。
they could verbally exchange information and coordinate, and they could see each other and follow each other's path if they deem that necessary, etc. So, and this is the layout of the metro station, modeled after a real metro station in Beijing. So, as you can see, that's starting at a platform, the pair of participants, they could choose among 5 different routes. Some of them are longer than others. And so we ranked different routes based on the distance that they have to travel. The shorter, the better. But the participants didn't know anything about the exact layout. What they could observe is that they will find themselves in a platform where a burning metro train is approaching. So they could hear the broadcast asking them to evacuate. They could see each other. They could communicate to each other. And they were instructed to find the nearest exit that they could find before the experiment ends. So we strategically recruited participants in different two types. So some participants, they came with some sort of a pre-existing social relationships, such as classmates and friends and etc. And the other participants, they came without any pre-existing relationships. So we placed them in 2 groups, what we define as a low trust group, meaning those who didn't know each other but could form some temporary social relationship under crisis, and those who had some pre-existing relationships, and therefore we believe that the social relation ties were stronger. We used 2 scales from sociology to measure the level of trust in both real-world and virtual reality environments. This would allow us to quantify the level of social strength and use it as a continuous variable if necessary. We found that, there was a clear statistical significant differences between the level of trust between those low trust groups and high trust groups. We also found that the level of trust in the real world and that in the virtual world aligned pretty well, meaning that the social relationship, or at least its strength, could be projected from the real world to the virtual world. That was an interesting finding. For dependent variables in this experiment, we measured several things, including their stress levels and the spatial distance among the participants, how close they stayed stayed to each other during the whole evacuation process, and their overall evacuation performances, including the routes they choose, the time and the distance during the evacuation, etc. So this experimental procedure, I'm going to skip this. So we recruited 32 pairs of participants, total of 64 participants. So, and these are the metrics of their evacuation performances. What it tells us is that, firstly, those with a higher trust, they spend less time on evacuation and traveled a shorter distance and had a less detour to find the right path, meaning that overall speaking, those with a higher trust had much better evacuation performances. We also found that evacuation time had a positive linear relationship with the average trust value, meaning that those who had a higher level of trust had to spend a longer time before they started evacuation. That was because they had to spend extra time to talk to each other, exchange the information about what they observe, and coordinated their decisions, whether to start to travel towards the left or right. And we also observed that the higher trusted group of participants perceived less stress, meaning that they felt safer and less mentally affected during the evacuation process when they were close to someone that they feel to share a strong social tie. And the high trusted group also, stayed much closer to each other during the evacuation. And this could be contributed to two possible reasons. One is that they were more likely to choose the same route. And secondly, when they choose the same route, they tend to stay physically closer to each other as well. And we observed that for those who have a higher trust levels, so they not only choose. They not only were more likely to choose the same route, meaning that they had a higher level of coordination, but also their route choice concentrated more among the best two routes, those two routes with the shortest distance, meaning that they showed a higher level of collective intelligence in making the route choice decision. So to quickly sum up in this study, what we found highlights the importance of managing social group as a critical basic units of the crowds during evacuation. And what we find would call for effective instruction and guidance to diversify participants' route choices, particularly when social group comprise a significant portion of the crowd, because in that case, the groups and the crowds were more likely to choose the same route, and the risk of congestion is likely to be higher. And also, what we find here could inform the development of better evacuation simulation models by considering the influence of social relationship strength on emotion, spatial distance, and decision making. So, taking this research to the next level, what we considered is that the social interactions exist not only within a small group of within small social groups of two or three people, which is a typical size of a single social group, but also exist among different social groups, which altogether form the crowds. So we try to understand that if we scale this up, how can we understand the crowd behavior under the influence of the existence of the different size and different types of social groups. Again, we try to study this in a virtual reality environment because, again, it could help us create the simulated crisis environment. But the challenge is also obvious. Firstly, as a very common challenge in doing VR-based experimental studies, the the bias of the population, participant population, is a major obstacle, right? In most studies, the participants, they are recruited from campus. Mostly they are university students. So their characteristics will present a major bias compared to the general population. And in this particular study of crowds behavior, it's a very another major challenge is that it's very difficult to recruit a large number of participants in the same laboratory environments and ask them to interact with each other, because for reason one, it's difficult to have so many sets of VR equipment. Well, it's not that affordable to most labs in universities. And the lab space is another challenge, right? And the transportation logistics is another challenge. And also technically, the VR experimental platform, including the one that I just presented, could not be easily scaled up to host the dozens, even hundreds of participants to interact seamlessly in real time in the virtual environments. So this means that we have to sort of revolutionize the experimental approach that would allow us to produce the dynamics of real-time interactions among evacuees in the virtual world. So to pursue this goal, what we did recently is to develop this crowdsourced virtual reality experimental approach, or CVR approach. This approach moves the traditional lab-based VR evacuation studies to an online environment, and use an open call to recruit participants from anywhere in the world who own their own VR headsets and who are interested in participating in some VR serious games. So in this way, we are able to outsource the task of data collection and create a virtual immersive online environment that would allow us to access participants with a much higher diversity in terms of geography, gender, educational backgrounds, etc., etc. So this CVR experimental approach includes two critical components. The first component is a process model for doing the experiment, because when we go online, we lose the supervision of the participants. So that presents a number of extra challenges compared to the traditional lab environment. So we developed this CVR experimental process model and explained stage by stage that what we should do, what challenges we may have, and the suggestions, recommendations to overcome those challenges starting from experimental planning to crowdsourced participant recruitment, to remote training and remote experiment, and lastly for crowdsourced data collection. So due to time constraint, I'm going to skip some of the details here. And the second critical component of this experimental approach is a digital platform called crowdsourced virtual reality research, or CrowdVR. We developed this platform following the classic design science methodology, from analysis to design and implementation and evaluation. And this is the overall computational architecture and the modules of CrowdVR. So I have a short video that shows this platform.
Welcome to CrowdVR, a cutting-edge platform designed to enable researchers to run immersive, interactive VR experiments online. Built on the open-source Mozilla Hubs framework, CrowdVR provides a powerful tool for exploring human behavior in innovative ways. Moving beyond traditional methods, it creates dynamic, real-world simulations of social interactions. Whether studying crowd motion, group dynamics, social movement, or behavioral contagion, CrowdVR offers a scalable, efficient solution for researchers. CrowdVR is packed with various functionalities to help researchers explore complex social dynamics. First, CrowdVR offers the flexibility to create a wide range of virtual environments, everything from small rooms to large-scale spaces like factories, cities, or entirely imagined worlds. Using the scene editor, researchers can quickly design environments by dragging and dropping components like walls, floors, and objects, or by importing 3D models in GLTF format from any 3D software. It also has a particle system to simulate dynamic elements like water, fire, or smoke, ideal for high-stakes emergency simulations. Second, CrowdVR allows researchers to assign specific social roles to participants. By using avatars, small virtual societies can be created where participants take on roles such as opinion leaders, followers, or outsiders. Third, CrowdVR offers various interaction ways. For example, collisions occur when participants get too close to one another. The radius at which the collision occurs is adjustable, which can also be used to simulate disease contagion. Participants can engage in chat, texting, and drawing for collaboration and problem solving. These features are critical for examining group decision-making, consensus formation, and collaboration. The instant transfer feature allows participants to be moved between different virtual spaces or social groups, providing researchers with tools to manipulate social network structures based on proximity. Fourth, for data collection, modern VR tracks 6 degrees of freedom motion with high spatial and temporal precision. CrowdVR can record head and controller movements, capturing detailed participant behavior. Each participant is assigned a unique ID, allowing for individualized data analysis. Additionally, newer devices such as Quest Pro with embedded eye tracking make it possible to capture attention and focus. Researchers also have full control over the experimental environment, including the ability to invite, mute, remove, or manage participant interactions to ensure the quality of the data collected. Most importantly, CrowdVR is open source, meaning it can be continuously expanded to meet the evolving needs of social behavioral research. Its flexibility allows researchers to develop custom features, such as generating network structures or introducing novel methods of social interaction. CrowdVR is not only powerful but also cost-effective. With the growing VR market, it enables researchers to recruit participants who own their own VR headsets, tapping into a global pool through platforms like Amazon Turk and Prolific. Participants don't need any technical skills. They can join the experiment with just a click of the URL. Plus, CrowdVR is not limited to VR. It works seamlessly on PC and mobile devices. In conclusion, CrowdVR offers a novel approach for conducting online behavioral experiments in an immersive environment. With high-quality data, low cost, and flexibility, it is a promising tool that can advance the field of behavioral science.
Okay, so this short video provides a quick overview of the experimental platform that we developed.
Welcome to Crowd.
Before we take this CVR approach to actual crowd behavior studies, we did something extra in order to validate this experimental approach. And the idea is to try to understand whether we could conduct online virtual reality experiments to reproduce some of the classic observations that have been reported in the literature. So what we did as a validation effort is to conduct or reproduce two field experiments that have been reported and well cited in the literature, and try to understand if we could reproduce and capture some of the behavioral patterns at the operational, tactical, and strategical levels, so that it would give us a confidence that we could trust whatever data that we will collect from these online experiments in the future. So to achieve this goal, we conducted two experiments. First is the bottleneck experiment, which is a very classic one. And the goal is to validate our experimental approach at the operational level. And we also reproduced an accident choice experiment and following a field experiment that did and published by Milad a few years ago. And the goal is to see if at the technical and strategical level, whether we can produce some of the important findings from Milad's study. So first of all, the bottleneck experiment, right? So we simulated this simple architectural environment where the crowds of participants had to go through a bottleneck. We changed the length, the width of the bottleneck between 0.8 meters to 1.8 meters. And repeated this passing through process to collect a sufficient amount of the behavioral data in the process. So the results showed that we observed the classical lane formation and the zipper effects during this process, and which matched very well with what were reported in the existing literature. And the number of lanes could also increase when we continuously increased the width of the bottleneck. And if we plot the velocity, density, and the flow of the crowds in the bottleneck area, we could observe that the patterns were also highly comparable with those reported in the field experiments. And also we observed a linear relationship between the flow and the bottleneck width. And it matches particularly well with what was reported in the SFPE handbook. So those findings give us a confidence that the CVR-based bottleneck experiment successfully replicated qualitative and quantitative results at the operational or locomotion level. And then for the exit choice experiment, we recruited 24 participants. And in different settings, those participants, they could either they were either instructed to be acting individually, or they were assigned to groups of 2 or 3 and were instructed to act collectively. And for those who need to act in a group, they were instructed to stay close to each other, and they should leave the exit as a group, the same exit as a group. So basically the same instructions that Milad provided to his participants in the experiment. So, and this video is a burst view of how the participants in groups acted during the evacuation processes. And this is a first-person view of one of the trial. You can see that the participants, well, they didn't know each other before the experiment because they were recruited online from anywhere in the world, but they could recognize their group members based on the appearances. And this is a plots of their trajectories. As you can see that they follow the instructions, the same group of members, they basically followed, stayed close to each other and chose the same exits. And we analyzed their performance metrics. And so we found that, for those who are under normal conditions, they would spend more time on movement and movement compared to emergency situation. And also for those who are instructed to act as groups, in social groups, so they had to spend a longer time during pre-movement stage because they had time to coordinate, and also longer movement time during the evacuation process because sometimes they had to stop and watch, look for group members and to wait for them, etc. So this coordination takes time. So these patterns all matched pretty well with the literature, showing that this exit experiment also successfully replicated the influence of stress and the social group at the strategical and the technical levels. Beyond this, reproduction of the previously reported phenomena, Due to the fine-grained trajectory data that we could capture in such experiments and a more diverse types of data that were yielded in such a virtual environments, we could also gain some new insights. For instance, in this experiment, we observed that the emergency condition decreased the time on coordination behaviors, such as waiting and turning back once we plotted the fine-grained trajectories of the participants. And we also observed that the emergency condition increased the proximity of group members, meaning that while they had to stop and wait and look for the group members, in this process, they maintained a relatively closer distance to the group members. And that also, motivated them to act as a collective group. And in addition to the behavioral analysis, we also did some interesting descriptive analysis of the participants, their backgrounds. So as we can see here, the 81 participants that we recruited for the 2 experiments were from 21 different provinces in China. So it presents a very good distribution, geographical distribution of the participants. They didn't know each other before the experiment, but they interacted and contributed collectively to our experiment. So the diversity in age, in educational background was also very good. Much better than what we could achieve in a traditional lab environment. What was also very interesting is that we observed a much lower level of motion sickness among the participants compared to the lab environment. The reason that we believe is that most of these participants who volunteered to participate, they are all VR owners, VR equipment owners. So they use the VR equipment for gaming, for other purposes in their daily life. So they are much better used to an immersive environment and less likely to experience motion sickness. So their behavior in this sense is much less likely to be skewed by such a motion sickness factor. So in conclusion, this approach allows us to access diverse participants in shared immersive virtual scenarios across or beyond the typical sample barriers, such as the age, geography, culture, social identity, and so on, and would yield high-quality behavioral data for better supporting our PED research. So this is a very early stage of research. So we have only recently validated our platform. So there is other ongoing work in our group trying to maximize the potential of this CVR experimental approach that would allow us to, for example, recruit participants from different cultural backgrounds across the borders to interact and understand the dynamics and explore the many unknown territories in PED research. So I'll stop here, and again, thank you very much for having me here. It's a great pleasure. Thank you.
What can I say, Nan? That was terrific. Really, I have lots to say, but leave it for the panel discussion. But I'm really glad you're pushing the boundaries of VR applications in crowd research. This is truly fascinating. The platform that, sometimes you see a paper or a development and you think, oh, I wish I had done that. This is the same feeling. A couple of years ago, I had the thought to develop a platform for VR applications, such as what you did. And when you presented it, I was like, I'm glad somebody finally did it. And I got notified of your wonderful work in that space a couple of days ago by a spike in citations. When your 2 papers, part 1 and 2, got published, I saw a spike in citations, and I thought, what is it? And then I realized that your 2 wonderful papers have been published. Congratulations on that. I'm sure there are going to be many questions. I got messages from Australia and overseas complimenting on your research and saying that was very interesting. The text messages that I got, I just thought I'd share it with you. Thank you. To introduce the next speaker, I introduced her once by mistake, but I'm happy to introduce you again. She has traveled to us from Beijing. Thank you very much for accepting our invitation, Xiaolu. Our next speaker is Dr. Xiaolu Jia. She's a lecturer at Beijing University of Technology, China. She completed her PhD at the University of Tokyo in 2020, and then worked as a project assistant professor at Tokyo. Her research focuses on pedestrian dynamics in transportation systems, including simulation, data analysis, and behavioral modeling. I'm looking forward to your speech, Xiaolu, and again, thank you very much for accepting our invitation. Please.
So thanks for inviting me. Finally, this is the right person at the right position. So my topic today is actually about the obstacle. So actually yesterday I heard several of you mention about obstacles. So this makes me believe that I am at the right place to give this research, and I am very happy that I can talk with you about the topic of obstacle. So about the topic, I will introduce from 3 aspects. First, I want to introduce some of the previous research on the influence of obstacle. And then I want to introduce my experiments to explain or try to explore the underlying mechanism. And then I think for the first time that we want to use obstacle in real train stations to get some results. So first, about the backgrounds. I think many of you know many about obstacles. So actually there are many previous research. And why it becomes popular, it is because in like 2,000 years, there are many famous researches. There are these 2 researches. The first one is the Nature paper, and second one is also very famous. They say that if you place an obstacle in front of the exit, actually the efficiency can be improved. So this is different from our intuition because obstacle is considered to obstruct, but they say that they can improve. But there are some conditions they mentioned, that is, it is applied in some clogging or highly physical pressure conditions. And also you need to like shift a bit from the center of the exit. But from this research, many people think that if it is super crowded, if we apply an obstacle, then the efficiency maybe can be improved. But actually simulations are kind of different from real life. So if it comes to experimental results, things becomes very different. So there are many researches about obstacles, so I introduce them in the sequence of whether they are extremely pushy or not. So first, they are like evacuation case or extremely pushy cases. So apparently it is not allowed to do these experiments in human because humans are we are humans, right? So they do experiments for animals like sheep and also grains. And they find that they have positive results if we use obstacle. But actually there are some kind of different conclusions. So this is another research on pedestrians. It is Spanish soldiers. It's the most crowded experiments using obstacle that I know. But in their experiments, although you can even observe the crowd surge, actually the obstacle cannot improve the efficiency. So it becomes a problem. And then there are other experiments that are less crowded, but actually participants are required to rush to the exit. So it is kind of pushy. And also this experiment is performed by Daichi. He's my PhD supervisor. And then there are other research, like they give running cases and also normal walking cases. So they reproduce positive and negative results. And also in other experiments, they were not told to rush. They're just required to walk normally. In this case, they acquire negative results and also normal non-influence results. So now you can see that if we see all the research in the sequence of pushing degrees, actually it is not a clear results. So here it's still a question. It is, okay, physical pushing might not be a very appropriate indicator. So I want to know that whether there are other candidates. And the second one is, if we really apply obstacle in real life, what will it be? So it'll be the following 2 sections of this presentation. So the first is the experimental findings. We find that maybe the self-organization can be the answer. So before that, I want to introduce the experiments. The experiments is like held in a corridor-like room. We apply an obstacle in front of the exit. So there are like two parameters. The first one is the width, the size of the obstacle. We increase from very small size to a very large size. And the second one is the distance from the obstacle to the exit. And we have two distances. The first is, you can see this figure, it is very near to the exit. And the second one is, it is a bit far from the exit. And please pay attention that we have like 49 pedestrians, but these pedestrians are highly heterogeneous. They are like aged from 18 to 78. And also we want to make a balance of gender, so half male and half females. Okay, here's the experiments, and we want to know the results. So the most apparent result is about the efficiency. So we observe like two different trends of the obstacle's influence. The important key parameter is the distance from the obstacle to the exit. So if the distance from the obstacle to the exit is far, actually we see that if we increase the size of the obstacle, the time will also be prolonged. It means that the larger obstacle, the less the efficiency will be. But actually, if we place the obstacle just in front of the exit, you see here, even if we increase the size of the obstacle, actually the time will keep steady. And even you can observe a very slight decreasing trend. So this means that the distance from the exit to the obstacle makes sense. And then we, by observation, find that the lane information can be the key to this phenomenon. Because when the obstacle is like near to the exit, we can observe very clear lanes before the exit. But when it is far from the exit, we can believe that we observe that it kind of mess. But now you know that it's observation. Everyone can observe. So our next job is to make some quantification of this lane information. So actually, there are some previous research on the quantification of lane information. The first one is like the order parameter, is like discretize the space and see the ratio of each line to say their directions. And second one, there's like the two steps DB scan method. It's based on the directions and also the walking directions. So I'm not going to show the details of these methods, but I'm going to tell you that there are shortcomings. So this is like in our experiments, like nearly parallel conditions pedestrians are walking, it is difficult for them to recognize these lanes. So we think that we need some new methods to distinguish the nearly parallel lanes. So here, it is our like two-layer k-means clustering method. So k-means is very typical method, so we believe this method is very easy for you to use. So the basic data is the trajectory data, and we have the first layer is to decide how many lanes do we have. So we apply the first layer k-means and see that, okay, the performance is best when there are 4 lanes. So now the next layer is we want to distinguish the lane changing behavior from the lanes because not all pedestrians keep the same lane. So we need to distinguish how or when pedestrians change their lanes. So this is the second layer. So the second layer's work is we have some, because we are bipedal walking, we have some oscillation. So it is kind of important to distinguish the bipedal oscillation from the change of walking direction. And by the second layer, we make it. We see that pedestrian first belong to the lower lane, and then he changed his lane, and then go up to the upper lane. So by this clustering method, we want to get 2 kinds of results. The first is the quantification of lane information, how good the lane information is. And the second one is how frequent pedestrians change their lanes. So about the first one, we decide that the deviation from the pedestrian to his initial lane as the lane deviation D. So this is the quantification of lane information. And the second one is we check the frequency of lane changing. We find that, okay, about 72% pedestrians didn't change their lanes. So some of them will change their lanes, but most of them will keep their lanes. And there are also several people who will like change for multiple times. but never mind. So about these two results, let's see how it is related to the efficiency. So first, we can see that actually the lane information status is highly related to the efficiency. If you observe this figure, the horizontal axis is how good the lane information is, and the vertical axis is the efficiency. So we can see that if the lane information is worse, actually the time will be prolonged. But I'm not going to say that lane information leads to the efficiency. It is just kind of highly related. It's kind of different. And also, if we explore the parameter D, the lane information status, into two parts, as you know that we have two types of pedestrians, one who have changed their lanes, the second one who have not changed their lanes. So after further analysis, we find that the lane deviation by pedestrians who change their lanes are highly related to efficiency. And those who are not going to change their lanes are not so related to the efficiency. So now we want to say that pedestrians who change their lanes might lead to the worsen of lane information. So also I think these results can give some hints to pedestrians, because if pedestrians, they can organize their lanes perfectly, actually we don't have to organize them. But in conditions where pedestrians cannot form very clear lanes or they cannot organize themselves, maybe it's the time for us to put an obstacle. So by this know-how, we want to apply this to a real station. So the station is like the Shinjuku station in Japan. So any one of you have visited Shinjuku station? Please raise your hand. Okay, I see many of you have visited Shinjuku station. So actually, it is the busiest railway station by Guinness World Record, because it's for every day, it will be 2.7 million people. And the next crowded station will be 0.6 million people in Paris. So it's very different. And also, this experiment is not only by me, because I myself, if I go to the station and say I want to do experiments, I will apparently be refused. So actually, this work is conducted by a very famous professor, Nishinari, who was my boss. He did this experiment. And also, the origin of this experiment is from 2020, actually. So the station came to his place and say, "Sensei, please help us. We have congestion." And then here's the start of this project. So before we know the question, we need to collect some data, because we want to know where exactly the problem is and how much this problem is. So first, we need to collect some data. So the data is collected by a Denso company, a company that they use LiDAR sensors, which is light-based sensors, and Claudio maybe will introduce tomorrow. And they install these sensors into 11 places in this concourse of the second floor at JR Shinjuku Station. And the station, the area is like kind of large, because it's 125 times 40 meters, which is kind of large. So they need like 11 sensors to cover the whole space. And this is the trajectories or the results. So now we have the locations. We want to see how accurate the sensing data is. So we find two problems, or one good or bad news. The good news is actually the positioning of the data is quite accurate, because if we see the south ticket gate, the ticket gates have like doors, and if we observe the positions of pedestrians, all of them falls between the ticket gates, which means that the positioning is quite accurate. But actually, there are also some other problems, like the tracking problem. As you can see in this figure, some trajectories look very good because they from the ticket gate to another like stairs. But there are also other trajectories that they miss some part, or there should be two pedestrians, but they combine them into one pedestrian. But this is, we need to handle the results from the right information and ignore the bad information. So we want to use some macro evaluation index. So first index we use is like the density, which is the most typical one, is the number of pedestrians per square meter. And the second one is the congestion number developed by Claudio and also Nishinari and also Francesco. So they have different conditions for these two indicators. One typical example, if you see that this queue or these pedestrians are walking in the same direction, As you can see, if they walk in the same direction, actually the density is very high. But actually, because they walk in the same directions, there are very few collisions. So the congestion number fits this condition. This condition is kind of high density, but low congestion number. So the congestion number, to lower this number, is also the objective of this experiment. And we compare the heat map of density and congestion number. We find the two interesting spots. The first one is on the higher corridor. We can see that the density here is extremely high. But actually, although the density is very high, because pedestrians walk in clear directions, the congestion number is not so high, which means that they do not collide so much. But interestingly, if you look in this spot, actually the density is not so high, but actually the collisions are very serious. So we think that the true problem, maybe the high density can be a problem, but in this research, we focus on the multi-directional collisions. We want to resolve the multi-directional collisions by our experiments. So we want to explain or compare different plans. As you can see that this is the area of multi-directional collisions, and we want to solve. But it is very difficult to place some new obstacles in the station. So we plan to use the obstacles they already have, which is the elevator. You can see there is an elevator in this station, and pedestrians leave from this platform to the concourse, and also pedestrians get into the platform from this. So there can be an obstacle, and the congestion number around this obstacle is quite high. So we have two plans or simulations. We want to first do simulations to see what we can do before we do experiments. So the first one is, okay, how about we just remove the obstacle? Because if we have no obstacle, the obstruction can be relieved, maybe. And the second one is, okay, because pedestrians, they are kind of mass around the obstacle. So maybe if we organize pedestrians around the obstacle, they can be better. So there are two simulation plans. So now we can see the results. So the horizontal is three densities of the three conditions. And the vertical part is the three conditions. So by default, we can observe that both the density and the congestion number around the elevator is kind of high compared with other regions. And then if we do the no obstacle simulation, actually it's kind of interesting because even we move the obstacle, actually the density will also not be lower. And more importantly, the congestion number will be higher. Well, it is kind of easy to understand because when there's no obstacle, actually the collisions becomes more serious because we have 6 directions pedestrians. It's very hard for them to control themselves, especially in simulation. So if we have no obstacles, actually it will become worse. But it also tells us that obstacles are not always bad, especially in this case, it can be good. And to improve the performance of the obstacle, we actually propose a plan of the roundabout walking. It's to let pedestrians walk counterclockwise around the obstacle. And then, surprisingly, we find that even the density will not change so much. Well, anyway, we are not going to reduce the pedestrians, so the density keeps the same. But surprisingly, if we check the congestion number, we find that the congestion or the conflicts around the elevator is largely decreased. So this is related to the know-how we know from the obstacle experiments. It is the organization of pedestrians will lead to the efficiency. So if we organize pedestrians, then it is possible to improve the efficiency. It's just like this experiment. We improve the conflict conditions of this area. Okay, so then we, by simulation, find that the roundabout plan to make pedestrians walk roundabout can work. And then it comes to the real experiments. But for experiments, it's different from simulation because by simulation, you can tell pedestrians the agents are just 100% follow the guidance. But when it comes to the experiments, there's another question is how you guide them to follow your instruction. So here we have 3 types of instructions. The first type of instruction is we give like paste the sheets on the floor. We give the arrows to the pedestrians on different directions. So let me explain the details. Is pedestrians walk from the ticket gates into this exit. So if pedestrians, by normal cases, by natural cases, there will be serious bidirectional collisions in these areas. So pedestrians walk here and there, will collide here. But if we place like floor sheet, pedestrians from this ticket gate will like take a detour. So this is kind of roundabout walking. So this is our plan. And the second is the signage. As you can see, we add a monitor in this area to tell pedestrians to the direction they should walk. This is the second guidance. And the third one is we also have some staff announcement, which is the most original or typical method. We let staff to tell them, please detour. So this is like 3 layers or 3 types of guidance. And also this is the actual photos of our guidance, the floor sheet and the signage and stuff. And about the signage, we have like actually like 4 types of information. By like countered by some taking videos and detect the number of pedestrians from the videos. And we set some thresholds to decide which kind of images we display on this monitor. So when there is no pedestrians, we have like empty. And then as the increase of pedestrians, when they cross some thresholds, we can guide them that, okay, there's kind of congested or totally congestion, and then you need to walk by this direction. So this is the signage, and also the stuff is the strongest. They will just tell you, please detour. So now, after introducing the guidance, we are going to check the data. So actually, the experiments were held for 3 weeks. But you know that collecting data can be more expensive, so we can only get 4 days of data. So we decide to get the final day of each condition. So this is like non-guidance, and also first like floor sheets, and second we add signage, and then we add stuff. And 3 LiDAR sensors were installed to collect the trajectories of this area. And now first, let's check about the data. So actually, this is a video I make based by the data. So before the guidance, you can see that there is kind of serious bidirectional flow in this area, especially around the elevator. But after the experiments, we can see that pedestrians, some are guided to detour. So this is before and after the experiments. You can see the pedestrians take detour, make this roundabout happens a bit. But still you can observe that some are not obeying this. So the first question is, how many people obey our guidance? And second is, how good does our guidance works? So first, let's solve the first problem. How many people follow our guidance? So to quantify this, we decide one indicator, it is compliance ratio, alpha. So how to decide this is the ratio of pedestrians who walk counterclockwise. So just very simple mathematical counting. And also the data we use is the pedestrian number that crosses each sections, the section A and section B around the elevator. And also we want to assure that the data is correct because we know that there are some noises in the data. And then we take comparison between the sensing data and the ticket IC card data. And then we find that if we take a certain section, actually the number of pedestrians passing can be accurate. So this makes us believe that the pedestrians crossing each section can be accurate or very near to real life. And then let's check how the compliance ratio alpha changes under different conditions. So first, let me check about the whole value of alpha. So in the non-guidance conditions from 7 to 10 o'clock in the morning, we find that almost all the times the ratio is like more than 50%, which means that more than half of pedestrians choose to walk counterclockwise even there's no guidance. So this is also the reason why we choose the counterclockwise direction, because it fits or like suits pedestrians' walking habits. And then we have the second sheet floor guidance and signage and stuff. we find that in the sheet floor, actually the guidance is not so apparent, especially under like morning rush hours. Well, this is kind of easy to understand because in the morning rush, people are stepping on the floor. So it is kind of not easy to observe floor sheets in this time duration. But when it comes to signage and stuff, we can see an apparent increase in the, not so apparent maybe, but an increase in the compliance ratio. And then to get a more detailed analysis, we draw the relationship between pedestrian number and the alpha, the value of the alpha. And then we find that with the increase of pedestrian number, actually there is a slight trend that the more crowded, the higher percentage pedestrians follow the counterclockwise. And also, if it is street, okay, the trend is not so apparent. But when it comes to the signage and also the staff announcement, actually the trend becomes more apparent. It means that when people is more crowded, actually our guidance works. But I also don't want to say that it works very well because you can see the increase is like from 5% to 10%. So we only achieved like 5% to 10% change, but actually it is very difficult to like change the typical day of pedestrians. But still, we want to see that how this from 5% to 10% change will change the congestion conditions of pedestrians. So here is the second question. So is the congestion relieved by our guidance? So to solve this problem, we divide the whole region into 3 sections to check the local areas. So the first region we check is around the elevator. And the second one is the other multi-directional areas. And also the time we choose is the most crowded time, which is like from 8:10 to 8:40, because it's the highest, if it is the most congested part, then we have the value to solve the congestion. So here is the result. So actually depends on the 2 areas, the performances can change. So for this area, because it is kind of small region, so the collisions around can be more serious. But in this case, if we apply signage, okay, the congestion number maybe decrease a bit, and also the density is apparently decreased. And when it comes to staff, it works the best because both congestion number and density are relieved by the staff announcement. And the second one is the other direction. Actually, they have some decrease more or less, but it's not so significant. So this tells us one thing is if we use our like guidance, it can work somehow because we only change like 5 to 10% behavior, but still we can get some improvement of our performances. And also in like more serious multi-directional cases, the small changes of the guidance might not work so well. But learning from our know-how from the obstacle experiment, I think if we put an obstacle in front of this green region, maybe the multi-directional cases can be improved more or less. So here is the conclusion for my talk. The first, based on the discussions about previous work, we find that the lay information can be a candidate to explain the influencing mechanism of the obstacle. And then use this lay information or self-organization mechanism. We do the experiments at Shinjuku Station, the most busiest station in Japan. And we find that the guidance we use is a roundabout walking to decrease or to make pedestrians more organized. And then the guidance method is like the floor sheet, signage, and stuff. And then we find that, okay, the stuff, as we thought, is always the best. But signage can also work to some extent. And also, the floor sheet maybe not work in very congested conditions. But actually, in other cases, like less congested times, actually the floor sheet can work when the density is very low. So the inspirations is like, okay, we might want to discuss the underlying mechanism of obstacle. And I think that obstacle-based pedestrian management is also possible. But actually, if you really want to apply an obstacle into real pedestrian management, it is a bit hard to change the daily behavior of pedestrians. And also the performance will be affected if your compliance ratio is not so high. But still we get some achievements. So I think it's a big step to this research. So thanks for listening. Here's my presentation.
Thank you very much for your presentation. You touched on a controversial topic, the obstacle, and that was very insightful to see your detailed analysis and insight on that. I'm sure there are going to be many questions. It's a very practical question and something we still don't know exact details about. So thank you for sharing this with us. And you have to come back soon to the stage because we are going to have another panel discussion. Unhee had to excuse herself because she had other commitments, so we only need 3 chairs. If I may ask Nan also to join us on the stage, that would be fantastic. And I'm going to make sure to monitor the online chat. So please feel free to ask your questions if you are following us online. So who wants to go first?
Hello. Thank you very much for some great presentations. My question is for Nan. When it comes to simulating in the VR environment those cooperative activities, did you find you needed to gamify that cooperation in the sense of saying to the participants, you'll get a higher score if you work together, or was just instructing them and asking them to work together as part of that process enough?
Okay, so far we haven't really introduced much incentives for them to, try to motivate or try to stimulate a certain type of behaviors. So we try to observe at this stage. The main reason is to try to reproduce and validate. But for your question, yes, it is something that's definitely worth trying, and we do plan to do so in future experiments. And in the process model we have developed, we discussed what type of incentives that we could use. Some are more traditional, but some have to be innovative in such online, less supervised environments.
Thank you. Yeah, I think it could be interesting because getting the urgency of an evacuation in a simulation could be difficult. If there's a competitive incentive, maybe that could be a proxy for that urgency. It'd be very interesting to see future research in that space.
Yeah,
thank you.
Absolutely. Thank you for your question.
Jia?
Thank you for both of you. The very interesting and I'm excited to see the presentations. And I have one question, firstly, for Nan. Since you want to put all the participants in exactly the same scenario, so you have to set a server and which collects all the client information. What I'm concerned is what is the time delay to collect all the information and then distribute the information to all the clients? Does it affect the react of all the other clients? So what is the magnitude of the time delay?
Okay, that's a very good question. The time network performance is an indicator that we monitor very closely in the experiment. So it typically varies between tens and several hundreds of milliseconds. So based on that, we have done a number of pilot studies to make sure that the participants didn't feel any obvious delay and could feel that the interaction was real. And we have implemented several mechanisms to make sure that the network performance is stable. First of all, in the training stage, we monitor the network performance of each individual, whether it's stable, whether it's the delay is low, and we filter those who are exposed to unstable network performance. And we also ask them to make sure that they will be under the same network performance during the formal experiment. And second, it has a lot to do with the cloud server that we use. So right now we use the cloud server from Ali Cloud. We also tested the Amazon Cloud, so both would work. But there are certain different packages of this cloud server that we could use. So depending on the size of the crowd, we can purchase different packages to meet the different needs.
Okay, thank you. So you developed all the data collection and the redistribution program by yourself, or you just use the service provided by the Unity, for example, the Photon. Does you program yourself, or just use the core technology of Unity?
For the lab-based experiment that involves several participants, yes, we will use the Photon for the communication. For the cloud platform, we developed the functionalities ourselves, but we didn't start from zero. We actually built upon a cloud, an open source project called Mozilla Hub, which has now been terminated, but we started 2 years ago when the project was still active, and that provides the basic online gaming environments. But we identified the needs to make it a more controllable lab experimental platform, and then based on those needs, we developed additional modules and functionalities.
Okay, excellent. Thank you very much. And one other question for Xiaolu. I saw you use the radar to detect all the pedestrians, and then you use a simulation to check whether it's good or not to put an obstacle there. In the simulation, you show the congestion number, and what I'm concerned is what is the demand of the pedestrian in that scenario? Have you changed the pedestrian volume and to check what will happen if when the passenger flow is not so high and when the passenger flow volume is goes high? What happens?
Oh,
thank you.
Thanks for your question. So yes, as you say that we collect the data from the LiDAR sensors and we just input the number of pedestrians at each sections or portals to put input into the simulation. And we also do other cases like we have another project to find that if we place the different obstacles inside the area and change the density or other pedestrian information, and then we find that there is kind of no such big influence on the shape of the obstacle, but always have very large influence on the density. And one thing I want to say is I use the simulator named Mass Motion. So actually it is very weak at handling with high density cases. So if the density becomes a bit higher, so the deadlock often happens. So actually we have some different conclusions, but I'm not sure about the high density cases. And in our case, it's not so high density because we don't have deadlocks or blocks. So we believe that to that extent, the conclusions can be right. And also to smaller scale or like a lower density, actually it doesn't have so much differences. So we think that we are finding the right just density cases.
Okay, thank you very much.
Thank you.
I can ask a question from Xiaolu.
Oh, yeah.
I think the matter of the use of obstacle for bottleneck management in front of an exit is somehow different from bidirectional flows and coordination and self-organization of crowds in more complex situations. Going back to the original, where the idea came from, one obstacle in front of the exit. Do you think, based on the experiments you have done and based on the existing evidence in the literature, do you think it's useful? Would you use it yourself if you are a manager of a building that has high occupancy, or do you think that's not have any major impact to justify being used as a crowd efficiency measure?
Thank you for your question. So actually, I think I will consider to use obstacle because, as you can see from my experiments, if you place the obstacle in the middle, it worsens or like prolong the egress time. But this is kind of because we have like heterogeneous pedestrians. And actually, we do the same experiments for like only young students. For their condition, the time does not change. So it means that the heterogeneity of pedestrians will affect the effect of obstacles. So for me, I think that if the pedestrians are like very heterogeneous, they cannot organize themselves. So in this condition, I may place an obstacle like in some right place before the bottleneck to decrease the collisions of the heterogeneous pedestrians themselves. But for like other areas like morning rush, all the people walk very fast. They are kind of like homogeneous. So in this case, I will not homogeneous, but not so heterogeneous. Then I will not place an obstacle because they can organize by themselves. But still, I don't have a clear indicator of when I should place an obstacle or not.
Well, that's the question, because once you put an obstacle, it's going to be a permanent construction in the architecture of the space. So the question would be, should we do it as a permanent thing, or is it context dependent and situation dependent so much so that it cannot be used as a permanent addition to an architecture?
Yes, maybe we can like place some once used or like movable. Only on crowded conditions.
Yep.
Movable, yes.
Probably. Yes, motion. We take that question first and then come back to motion.
Thank you for the three wonderful presentations. My question goes to the third presenter. You put the obstacles in the simulation, and the obstacle forms the counterclockwise movement of the pedestrian. But I think this counterclockwise movement depends on the walking habit. If you walk on the light, then counterclockwise movement is natural. But like in Japan, the people walk on the left. Then clockwise movement is more natural. What do you think about that?
Thanks for your question. So actually, the walking habit is one aspect. But for our condition, we believe that the counterclockwise is the right direction because we have the results for no guidance. We find the percentage of pedestrians walking counterclockwise is higher than the other direction. So this is also the reason why we apply the counterclockwise direction. But still, like in other conditions in Japan, it's very highly reasonable that the clockwise condition is right. But for our experiments, this is like quite to this like layout for the layout of pedestrians, because like for this side, for the right side, they are the objectives. So people will just walk straight. So in this condition, this direction can be right. But in other conditions, it can be different. So it depends on the condition we use. Thank you.
Thank you.
Mohsin?
Question for Xiaolu. It's actually not a question, just a comment. There was this experiment from Miniko.
The roundabout experiment, yes. I know.
And so it doesn't have to be a construction. It could be just put in some plant or something. What she did is like she had an experiment crossing, and then she put something in the middle, and then she saw some positive effects on. And then there was also the same experiment done also in Germany. So in both cases, with or without the obstacle had a very good effect in separating.
Yes.
It makes maybe less sense in a bottleneck situation because everyone is going in the same direction. But then when, like in Shinjuku or in Miniko's experiment, maybe it makes sense to think about putting something and separating people.
Yes. Yes, I think they works because the multi-directional collisions are serious in their experiments. And also, I think one problem in our experiments is like it's real pedestrians. So people are rushing in morning rush. So they are not very willing to change their behavior.
Yes.
So the not very high compliance ratio can be the reason why it works not so good. But if all the pedestrians follow the guidance, maybe it can work as well as good as experiments.
In Shinjuku, people, they are also a little bit trained because they take this road every day and they are very stressed. So
Yes.
maybe they don't have enough time to look at whatever you put on the...
Yes. Yes, the way to guidance.
Just a thought, maybe some sort of like a decorative stuff, like a statue or something, that will create an obstacle, and maybe people will also slow down a little bit, and then will improve the compliance ratio.
Oh, thank you. So it actually exactly happens in our pre-experiments. We put on like robots, like monitors here, and many people come to see the monitor, and also some weird guy in Japan just dance before the monitor. So it can like be advertisements, but the influence is still, we need to check. There are some positive and negative things. Yes, but it's a good way to let more people know about this guidance. Yes.
And if I may just double down on the previous question, and please feel free if you don't agree with me.
Okay.
And I just want to more, bluntly share my view. I think that the use of the obstacle, that's my personal experience, for managing multi-directional flows is well justified to pursue. We have seen effects from your experiment. But as Motion also mentioned, I think for the use in front of an exit for bottleneck situations, I've seen many experiments not producing any results or producing negative results. And that makes me very skeptical about it. In saying so, I think the original idea of the use of obstacle, I think it was a little misconceived and an artifact of the simulation model, whereas we could have used the obstacle in situations where we need self-organization of the crowds and nudging of the directional movement in complex movement scenarios, rather than in front of an exit. I think it could have even adverse effects in front of an exit. I just wanted to put the view out there and see if you guys agree with me, disagree with me, Motion, Claudio, and yourself.
So how do you think the difference between the bottleneck condition and multi-directional conditions? Is it just because like bottleneck, they have like the directions are not so large, so maybe the collision angles are not so large? That's why you think the bottleneck are different from multi-directional? Like,
I think it could naturally have less effect on self-organization in front of an exit, in that it's either too far from the exit, meaning that after the exit the effect will dissipate, or if it's too close to the exit, then the lanes might not necessarily form in a highly packed crowd, like the Spanish experiment. You wouldn't assume that in a crowd as packed as the Spanish experiment, lanes will necessarily form as a result of the obstacle. Am I right about that?
oh yes, it depends on the shape of the obstacle.
Yeah.
So in my experiment, it's like like a wall. So they're kind of
depends on the shape of the obstacle. A round obstacle as small as a column, which was the original idea of the obstacle, would not necessarily create lanes. Is that correct?
Yes, it's very hard to distinguish lanes in that condition. Yes, makes sense. Yeah. And also, I think for the Spanish experiments, also related to my last answer, is the heterogeneity of pedestrians can affect. For Spanish soldiers, they are kind of heterogeneous, not so heterogeneous. So maybe they are kind of organized. So if you have put some, maybe it's legal, but put some children or some old people, maybe it can work.
Or not in that Spanish experiment, because they really push aggressively in that Spanish experiment. I think that experiment is also quite an outlier in the sense that they instruct for aggressive pushing. And I'm rather critical of that experiment in that people in the real world do not have any reason to push from behind of the crowd for the sake of pushing. I don't think that's necessarily a natural element. It's just an instruction that is given during that experiment. So that's quite also an outlier in terms of the behavioral conduct of the crowd. I'm glad you mentioned.
Okay, thank you.
No, thank you. Anton?
Yeah, you started the question again. So it was indeed that, like, for crowd professionals, like you say, academics and people on the field, it's indeed a question you get, like you have an information panel or something, you have exits at a festival, and then it's the question, if you have the space and you can choose where do we place the panel, and might it help the exit, the egress of that? So I was asking, is there a simple, let's say, overview of where should we place the obstacle? How wide should the panel be? And if we can decide on the form or the shape, what would be the academic suggestion to do so? So that's the practical translation to, if you don't have simulations and everything, these kind of questions you get in the field. So, but I don't hear a clear one-off answer, if I'm right.
I'll wait for Xiaolu to share, and then I'll share my views on that.
Okay. So you mean like, are there any suggestions for real standards or design of the?
Yeah, indeed, some guidelines, do's, don'ts. If you have the panel, the size, you can see like, okay, this type of egress is expected. Where do we place it? 20 meters, 40 meters, something to have a look at.
Okay. Maybe you can first answer the question.
Okay.
It's too difficult for
I'll
me.
go. I'll have some relatively strong views on this. In my view, an obstacle should not obstruct an exit, because the obstruction of an exit also means a visual obstruction of an exit, and that comes at a cost. So even if we prove experimentally that obstacle in front of an exit streamlines the flow, we also have to consider that this should be a short obstacle that does not necessarily obstruct the view to the exit. All that said, I don't think necessarily obstacle in front of the exit is necessarily useful, and the use of a panel, in what context do people on the ground consider the use of a panel? Is it for the exits or for the flow of the people? If you could give us some context on how people consider using those panels.
I don't say they're always good, but sometimes you have an exit and you have some information on public transport outside, which is displayed, and they have the ID, we place it there, so people have the information on going out. You don't want to stop the people, of course, so it doesn't really too small so people stop to look at it, but some signage to guide people towards a certain place.
I think it should be placed in a position that provides a line of sight at a distance, first of all. If it's to direct people to a certain direction, because a pedestrian should not get to the location of the panel at a short distance and then have to decide where I should go. Because as a pedestrian, you need to plan your trajectory. You need to navigate the crowd. So it should be offering enough line of sight and enough distance for the pedestrian to adjust movement around it. And I think that's the only way the obstacle could be effective in self-organizing the crowd. If it gets introduced to the crowd all of a sudden during their movement at a short distance, short notice, I don't think that would increase the efficiency of the crowd. That's one criterion for me.
Well, actually, quite related to your answer, when we do experiments, we also consider this question. So for the floor sheet, we do it at a very early stage. For people who just get out of the ticket gates, we begin to guide them to take a detour. But for the signage, we put it kind of a bit near to the obstacle. So we decided not to be so near, but if it is not so near, you can obstruct, because when it is placed far from the elevator, it is a new obstacle. So then it can obstruct more or less. So this is forbidden by the station. So we have to put it near to the elevator. And then it turns out that the effect is not so strong, because there are many people who first go near to the signage and then decide to detour. So this also can be a negative part of the experiment. But this is also the difficulty in applying real obstacles in real life, because there are other ethical problems from the station. So it's still difficult. But maybe you can talk with Nishinari. He's professional in this area.
Yes, please.
Sorry, I have one question for Nan Li. So I was to say I was very skeptical about using VR Then I started to use it myself and also saw your results. So you were able to reproduce the results of the bottleneck. So I think the technology is improving, it's getting much better. And I'm now confident that VR can be used for some experiments. But I also know there has been some research, like people just answering some question on the smartphone, like in some room, or like doing that online in a completely different context. And when people know that they are watched by each other, so when people feel the presence of the other in the room, the results can be different when people are like in a completely different place. So my question is, maybe if you want to like check some like social condition, like trust, or like these kind of things, maybe even in the future there could be some gap. So in 20 years, when the VR technology is going to be very good, very perfect, so what do you think is going to be the gap that is going to remain using VR? And which kind of gap do you think is going to be covered by better technology? So which kind of experiment can be used for in the future, and which kind of experiment, even with the best technology, cannot be used?
Okay. Well, this is a very good question. As you noted, the technology itself has been advancing. We are able to do things that we were not able to 10 years ago when we just started. And personally, I'm optimistic about this direction as well. I think driven by the advancements of technology, there could be several things that we can do better in the future. First is the sense of stress that we can arouse among the participants. Right now, we primarily rely on the visual and audio cues. In the lab experiment, we also experimented with heaters, with scent displayers to simulate a multi-sensory environment. But I think, in an online manner, right now it is difficult to do that. But hopefully in the future, that could be something that we could do. And secondly, the type of data that we could collect. As I noted in the presentation, the embedded eye tracking technology is becoming more available and affordable. So eye tracking data could be one additional new source of data. There could be others. For instance, if it could embed let's say, some sort of biosensors to capture their bio responses, that would be perfect. In one of the experiments that we're currently doing, we purposefully recruited a few participants to join us in the lab off-site so that we could equip them with the biosensors. But hopefully that could also be something that could easily be done in the future. And also network the capabilities is also right now a constraint for us to really scale up to hundreds of people. We're still working on that. We can now experiment with dozens but not hundreds. But I think with the technological advancements, that could also be a major obstacle that we try to conquer.
And again, credit to you, Nan, for doing these fantastic developments. We had discussions around investigating culture-specific differences of crowd behavior. For example, this platform would easily facilitate replicating experiments across cultures, observing those cultural differences if they exist at relatively a small cost that otherwise would have been hard to implement.
Yeah, exactly. I could still recall that we actually did 2 cross-cultural experiments in the past, off-site in the lab environment. That took us a lot of efforts, and not by myself, but also by my collaborators in other countries. But with this CVR approach, actually one of the validation experiment was done when one of my PhD students who was organizing the experiment, she was in New Zealand. She was doing it remotely while the participants were in the culture, or were in China. So it demonstrates that a cross-border experiment is technically feasible.
That's wonderful. It's a major contribution to the field, and I really appreciate it. And thank you for replicating one of my experiments. Feel free to replicate any of my experiments.
It helped us a lot too.
Thank you very much.
I actually have a question for Professor Nan Li. So I think you introduced the open source platform of yours. What do you think I need to prepare if I want to use your platform? Because I saw the VR equipment. Do I also need to prepare them, or?
Well, as a researcher or as a participant?
participants.
Yeah, well, as a participant, yeah, all you need is a VR headset.
So if as an organizer, what should I?
Then, I can provide you with a free experimental account that you will be able to organize your own experiments. We also have the instructional materials that would be happy to share.
So luckily I'm also in Beijing, so it's easy for me.
This is wonderful. Codee, and then we take the question after that from Sarah.
Perfect, thank you. Just back to the conversation about the obstacle modelling. It's fascinating to hear the back and forth, so thank you everyone in the room contributing to that conversation. I wanted to flip it a little bit from putting an obstacle on the inside of the building near an exit, and particularly in the railway environment, thinking about protective security barriers that might be outside exits such as bollards. Transport for London in the UK did some studies around evacuation flows and the positioning of vehicle barriers like bollards in proximity to exits and how they impact pedestrian flow in those situations. So I'd be curious to hear from the panel if there's been further research in that space, if that's something that could be investigated further, and if there's value in looking at how those, I guess, hard barriers outside of exits might influence evacuation flows both in and out of the building.
Sorry, I mean the hard or
small bollards.
Small bollards.
I
like
think
900
I'll
mil.
share my view first, and then we go to Xiaolu. In my view, bollards being small, for as long as they are not being used to stop vehicle attacks against crowds and just put in front of the crowd for the hope of streamlining crowds, I don't think they will have any effect. They will either have adverse effect or none. It's just an unnecessary hassle people go through, and it obstructs the way for some people, especially if they are visually impaired or they need to use wheelchair. They would restrict the movement for them. They would restrict the movement of groups because then they have to fit the space between two adjacent bollards. They wouldn't have had to do such maneuver if there was no bollards in front of them. And I don't think being so small, theoretically, you wouldn't expect them to have any impact. So when I see them being used as a method of crowd management, I just think this is some resources misplaced and misallocated. That's my view on that. However, if they are being used to stop vehicles attacking or accidentally moving onto the crowds, yes, that's a different story. Yeah. Security measures and applications of it is a completely different thing for me.
But also, I actually saw the small pillars in Korean subway station at the escalator. So they place one before the escalator. Yep. If you go there.
They always do.
So I think that kind of works for like pre-deciding the position I should go before I go to the escalator. And also, I think there are some experiments saying that if we place like small pillars just in front of the exit, maybe pedestrians will take actions before, because they are more than an exit. They are some management. So maybe they can work as some guidance for pedestrians to take some actions. But it depends, totally depends on the condition.
They will take a form of more of a nudging effect rather than control. So their nudging is more of an application.
Yeah, it's not controlling.
Yep. And that, do you agree that could be done with some signage, or is it more useful with the actual bollard?
I'm not sure.
Maybe some smart floors. I'm a fan of smart floors. I think that these floors in major train stations, they're gold mines to be used for crowd management if investments are justified. I think that the combination of soft measures with technology, I think there are a lot of things that you can do with the smart floors. And this kind of stuff, I think, can be more flexibly done with the smart floors rather than putting hard infrastructure in place, which is then later on is difficult to. And they are time dependent, time flexible. You can change them in the morning peak, some adjustments, afternoon peak. You might want a different form of guidance to the crowd, so you can easily adjust them. That's fanciful thinking, I know, but I'm allowed to dream, right? Can I ask one more question from Sarah Abbasman online? It's to you, Xiaolu.
Okay.
She says, thank you for these amazing speeches. My question is for Xiaolu regarding the obstacles. Does making them transparent does making them transparent, considering their shape, as you just mentioned, affect congestion and pushing? Making them transparent.
Excuse me, like you cannot see them?
See through?
Ah.
Yes, I think that's along those lines.
Ah, you mean the visualization can be affected?
So how the obstacles that you have, the elevator, you cannot see behind it, right?
Yes, we cannot see behind.
The question is if they could see, not necessarily being an elevator, maybe another form of infrastructure or just an obstacle. Is it important that it be see-through?
I think it's kind of important factor, because if you can see through the obstacle, you can know like more information for you to predict.
To predict. And
yes, if you have better prediction, then maybe it works better. You see, you can directly see the merits of like taking a roundabout or like detour around the obstacle. So if it's transparent, it can be better, I think.
That's excellent.
To my view, yes.
Thank you. Thank you very much. Hope that answered your question, Sarah. Well, if there are no questions, that concludes our first panel discussion. We can head for a break and come back at 1 p.m. Seoul time. If you're joining us online, please get back to us at that time. Thank you very much. Thank you. Thank you very much.
Thank you for answering.
Okay. I hope you had a nice break. Welcome back. We are heading for our second session of the day with Professor Nishinari, and then it will be myself. You will see some discrepancy in the program. One of our speakers who originally was supposed to be here for a talk, not Codee. Codee is going to be presenting at 5 p.m. They couldn't make it to the event, so I'm going to be filling in for the second speaker of this session, and then it's going to be Anton. But for now, I'm very excited to have the opportunity of enjoying Professor Nishinari's speech. I'm very honored that you're here with us today, and really thankful that you accepted our invitation. Professor Nishinari is a professor of University of Tokyo. He received his PhD degree from the University of Tokyo in 1995. His research interests include mathematical physics, vehicular traffic, pedestrian dynamics, and logistics. He has published several books on traffic phenomena. He was a crowd manager in Tokyo Olympics in 2020 and won the Ig Nobel Prize in 2021. His resume is far longer than that, but he has been quite humble in sending us a short version. I'm very much looking forward to your speech, Nishinari, and please come to the stage, and floor is yours. Thank you very much.
Okay. Thank you for Milad and staffs and organizers who prepare this nice summit. And I think it's a good time for you to sleep after lunch, but I hope you enjoy my talk, okay? So I am now the cloud manager of Osaka Expo, which will start from this April. So I hope you come to this expo, and I guarantee that your safety in the expo, since I am in charge of that, so, okay. So briefly, I'd like to introduce myself. I'm studying so-called gemology. It's a kind of interdisciplinary research on all kinds of gems, including vehicle traffic and also pedestrian, of course. And also, recently, I'm also studying logistics and transportation. And sometimes the creatures like ants or other animals and so on. So I'm very interested in the common feature of these transportation phenomena. And I also collaborate with many other companies and facilities up to now, including Tokyo Olympics and many airport or companies, and a few of them are listed here. And I'm originally from mathematical physics. So I published mathematical books with Andres Schneider and Debas Chaudhry here. And recently with Claudio, Introduction to Cloud Management, we published. So today I'd like to show what we have done before for these 5 years or maybe 8 years. So this is the biggest national project in Japan on the cloud management. And I am the PI of this project. And you can see the overview of what we are doing here by this picture. So the cloud is here. So this pointer, okay. So cloud is here. And first, we have to measure the density or number of passing people at the section by using the cameras or other things like a smartphone or other ticketing data, ticket data, or also we need sometimes the information of weather, because weather affects the cloud motion significantly, whether it is hot or rain or something. So first we divide our project into 3 parts. First is sensing. So sensing is in a broad sense, we not only the camera, but also I said, using the ticketing data or something. And next, we should predict what will happen in the future. So we should predict the risk of the crowd by using computer simulations. And also sometimes we use simply the time series analysis by using AI or something, okay? And once we know the risk, then we should prevent the risk by using the control method. So this is the third part of what we are doing, is the control. The control means two ways. The first, we give the information to the crowd itself by using the smartphone or signage. And the other way is to give our information to the security office. And they use our method to navigate or guide the crowd according to our suggestions. So this is a kind of loop we are making. We have succeeded to make this loop in the reality. But I'd like to stress on this point that we'd like to focus on the normal situation, not the emergency or evacuation, because most of the time is normal, of course. So we concentrate on the normal situations in this project. Of course, if something happens, we collaborate with fire stations and police, and of course, but in the normal situations, there is no platform up to now in Japan. In the emergency situations, we have a lot of organization or researches on that, how we evacuate and so on. But in this case, we not only focus on safety of the crowd, but also their comfort or efficiency without make queuing or something. So this is a unique point that we are doing, is that we focus on the normal situation, especially. So I'd like to introduce these 3 points: sensing and simulations, or prediction, or control. So this is our team. So this is the biggest team in Japan, and university is our Tokyo University and Hokkaido University. This is there is a specialist on psychology there. So, and Osaka University, they are specialists on the crowd simulation or visualization. And there are a lot of companies who is related to the crowd dynamics, including the JR company. As in the previous talk, Xiaolu said about one of the collaboration with JR. And ANOA, or the second is the biggest security company in Japan. So we also collaborate with these companies. And big construction company here, Kajima, and biggest travel company, JTB, in Japan. These are all partners of this project. So first, the sensing. We'd like to discuss sensing. This is a very, very growing field in recent years because of the AI technology, So we have, of course, a camera, and also we mainly use a beacon to capture how many people are there, because the camera is sometimes very hard to install. But beacon or Bluetooth sensors is very easy and low cost. So we mainly usually beacons or LiDAR sensors, as Xiaolu Sensei said, or Wi-Fi, GPS, or other ticketing data, and so on. But I think that every technique has advantage and also disadvantages. So I think we need the sensor fusion of these things. Maybe there is advantage and disadvantages. So fusion is very, very important. So this is one of the results we have done. This picture is taken from our AI camera installed near the Tokyo Dome. This is the entrance of Tokyo Dome, and there is a big square in front of the gate. So there are a lot of people there. If we finish the game or events, or before the event, many people are gathering and queuing in this. So there is a risk of maybe the COVID-19 era, that there is a risk of transmission of virus. So what we have done is to show our, it's unstable, to show the density in a real-time way like this. This is by using the Voronoi diagram. And if you see the pink here, it means that there are so many people here. So this movie can be seen by the security office. So they see where is the density area. And they walk to the place and they advise to do not gather the people. So that's why they use this video in the security. Okay. And also, first we focus on the density, but we realize that density is not enough for security and comfort. This is the same topic as in the previous talk, that please imagine that if the density is high, but the people direction is almost the same, so there is no collision between the people. But if the density is low, but the people's direction is multi-directional, so there is a collision. It means that there is a stress to the pedestrians. So how we can measure such stress? So we are considering to measure by using the rotation vector, which comes from the fluid dynamics. Because I'm originally from the mathematics and fluid dynamics, so this is a rotation vector divided by the average velocity. So this is what we called congestion number or congestion level, as in the previous talk. So please imagine that if people move straight, then there is no so-called vortex in the vector field. So vortex means that people have to avoid the other person. If there is no vortex, then the rotation vector becomes 0, even though the density is high. But if the people have to avoid each other, then rotation vector becomes non-zero, but there is a big value sometimes. So we define the congestion level as from this formula and succeeded to capture where is the most uncomfortable place for pedestrians, because pedestrians have to avoid each other. So as in the previous talk, that the density is high in this corridor, which corresponds to this. This is a very busy line here. So after getting the train, they go to the exit and they go to their work. Here's an office street here. But the direction is almost the same from here to here. Oh, it's very hard to use that. But as in the previous talk, that we have a crossing here. But the density is not so high, as you see here. But in the congestion level, the most highest place is here. So the Shinjuku staff in the Shinjuku station has very pleased to see this result, because only the density they are capturing where is the dangerous place. But they know that the right bottom area is the most dangerous in the sense that people have to avoid each other. But density cannot capture the place, but the congestion level can do that. And after that, we did experiment, as she said, that we introduced a roundabout here. And next, we talk about the fusion of the simulation and the sensing result. As I said, that we have 3 parts. First is a sensing part, and the sensing data is transmitted to the cloud. And the cloud is called CMPaaS, Cloud Management Platform as a Service, CMPaaS. And there is a lot of sensing data, real-time data in the cloud. And the simulator, this is done by the Osaka University, and they can download the real-time way, the data from the cloud, to predict what happened in the future by using their computer simulations. So their simulation is very, very faster than the real. Maybe 10 times faster, so it takes 1 minute to predict the 10 minutes future. So we always having these simulations at hand. So the security office can see what will happen before it happens. So we think that early warning is very, very important for avoiding the crowd crash and also comfort for a crowd. So you can see the people are walking here. This is reality, okay? Oh, here, this is reality. Since we have a camera, and if the camera detects a person, then you can see immediately on the simulator that you have a pedestrian crossing this line. So we connect the sensing data with the real-time simulator like this. But of course, there are a lot of simulations up to now, including the commercial software, and also our researchers develop their own model. But in order to have some level, okay, accuracy level, we discuss a lot of time for more than 6 years, and finally we have succeeded to publish the verification manual of simulators. Unfortunately, this is in Japanese, but Japanese company have to follow this verification manual if we want to connect our system, okay? So our CMPass platform is an open platform. We can make everything open to those who have technologies like sensing or simulators or security measures. But for the simulations, they have to satisfy these 5 rules for the simulators. These are well-studied situations, and I know that there are a lot of accurate data in the world. Of course, in the German society, they have a list of correction of this kind of experiment. And we also have a lot of data for doing that. For example, you can see the L-shaped flow. And maybe you all know that where is the most high density place when you observe this flow. The answer is that just before the corner, here is the most usually crowded place in the experiment or observation. So if you don't reproduce this result in your simulations, then we refuse to connect your simulators. For example, the other example is obstacles. As in the previous talk, the people avoid obstacle before they collide. Of course, people are clever enough to make detour before the obstacles. But if your simulators move straight to the obstacle, okay, and when they collide, then he moves to the direction. It's not human beings. So we reject such simulators in our system. So this is a minimum requirement of the simulator that should satisfy in the reality. Okay. And next is the control. So we divide 5 stages of the control depending on the risk level. Okay? If the risk level is very low, then we just inform where is a toilet or where is the entrance and so on. This is an inform phase, okay? Like this. And if the risk level becomes high, risk level is determined by the usually density, okay? So density becomes very high. So we switch from the inform phase to the otherwise phase. This is more strong way to guide the people. And more strongly, we sometimes use the guide phase. This is the strongest phase that we do not touch the human beings. And from this line, the steer and enforce. This is the, for work for military or police and so on. We cannot do that. So up from inform to guide, we can do that. But beyond this line, this is not our control. Okay? So we collaborate with such military or police when we have to switch this from guide to steer and Air Force. So this is what we are considering. And the switching is sometimes automatically done by using the data or AI. And what is important thing is that we should avoid the counterflow. So the first principle for our crowd management is to avoid the counterflow of pedestrians. And this is a simulation I have made after the Itaewon disaster. And there are so many people are coming from the Itaewon stations. But at the same time, the people enjoying meals go to the stations, and there is a counterflow here. So tragedy occurs. So we should always think that the flow should be unidirectional, if possible. So this is a principle in the Olympics and also the Expo. I ask all the staffs to make the pathway one way, okay? And the criterion is already published by our colleagues, and Claudia and I published about 10 years ago when deadlock occurs in the counterflow. So this is not experiment. This is observation is in the Tokyo Metro station. So the number of flow from left to right is here, and this axis. The other side is this axis. And you can see that if there is no deadlock, you see the green circle here. And this, sometimes you have congestion or sometimes stops. And this is totally deadlock here. And we can draw the line which separates the free flow or safety flow to the dangerous flow by using this line, okay, this line, right. So you can see the number 1 and 1 here. Of course, this is symmetric, so we have a symmetric result according to this y equal x line. And we have found that 1 is the criterion. If the flow becomes below this 1, we don't have any deadlock. So we should control the bidirectional flow below 1 pedestrian per meter per second. So this is also used in the Tokyo Olympics and also Expo and so on. So this is the maximum flow that can be allowed in the bidirectional flow. Okay, finally, I'd like to show our result on the Tokyo Dome experiment. So after the game, Tokyo Dome is one of the biggest stadium in Tokyo, and there are 50,000 people coming from this event. And after the event, of course, the people use the shortest path from this venue to the station. And the shortest path is here, this line. And this is a Suidobashi JR station here, and we have a west and east entrance here, but west entrance is the shortest, you see. So we have 3 possibilities, west, east, and the other side is the Tokyo Metro station. But the main gate is here, so people always prefer to use this line. So many people are using this bridge. So this is a picture of the bridge, and there are a lot of people you can see after the game. So first, we'd like to focus on this bridge and to mitigate this congestion here by using our system or platform. So important thing is that when the people walking from this to the west gate, there is a very good point that can change their route from west to east here. So the picture here is given by this. You can see that many people are using this because this is to the west gate. And less people are using this way. This is for the east. So from the experiment of Shinjuku, as she said, we know that the staffs works more powerful than the signage or other things. So we decided to install stuffs here. And when the density becomes high, then he changed his advice from inform to guide. It means that strongly they guide the people to walk to this direction, okay? So that before that, we'd like to estimate how many people should make the tour to the east, from west to east. This is done by the simulations. So this is as is the case. So many people, about 60% people using the west. In that case, this is not easy, okay? In this case, there is a congestion on the bridge. And if we change the ratio like this, so we reduce the west ratio, then you can see that less congestion here. But if further we increase the rate from west to east, then next, the east part will be congested. So the medium guidance is the best we know from the simulations. So we did a lot of experiment, and also this is the information to the security office and also for crowd. They can check their smartphone whether there will be a congestion or not by using the smartphone. So we provide this in this case 5 minutes future by using our simulations. So crowd see by their smartphone what will happen in the 5 minutes later. So they sometimes avoid to use this west part here, okay, by using this smartphone information. And this is for the security. So they know that we will have a congestion here. So they start guiding people from west to east right here. And of course, there are a lot of other points, but I'd like to focus on this in this talk. So this is the result. So we have succeeded to reduce the congestion by using our platform. So this is very unique experiment, and we have done more than half a year for doing this experiment. So we did experiment, we learned something, and change the parameters and so on. So half a year, we have succeeded to do this experiment. So the estimated number of the people we guide is more than 400,000 people from this venues. So as you see that the congestion on the bridge becomes in the LOC level from D to C, or sometimes from E to C, by introducing our platform. The green line is the result of using our system, and the red one is without our system. So always we have a decrease of like this. And the final topic is that our activities we are doing right now. So we have analyzed crowd crash or crowd accident for more than 100 years, actually. And we have published our result on this book. And I realized that there are so many stakeholders related to the events. And there's sometimes less communication between the stakeholders. That's a problem we found. So that's why we like to introduce a crowd manager, which can see all the things. And sometimes crowd manager can check whether the manual of the transportation or manual of the police do not contradict each other. The global optimization is the most important things to avoid the crowd accident. So we have now succeeded to have the crowd manager occupation in Japan. So last year, I established a certificate of the crowd manager, and there is an online course in Japan. And if you finish the online course and take an exam, then you will be the crowd manager. So we succeeded to have this system in Japan. And next year, maybe this maybe becomes a national certificate in Japan. And if you want to have some event, then it is mandatory to have the crowd manager in the planning team. So I'd like to have such a system in Japan. So we are now negotiating with government of having such law in Japan. So this is our recent achievement. So finally, we'd like to conclude my talk by again show this slide. And this is not for safety, but comfort. And the CM Pass, this is a platform of everything. Observe the many real-time data in this crowd. And if you have a simulator, then you can access this data to predict something. So if you predict the result, then the signage company or security company can use that. So this is a new platform in Japan we have succeeded to open by using the government fund. And also the crowd manager has started. Up to now, 35 crowd manager has been done up to now. So I'm very happy that they will avoid some accident in the future. So finally, this is my team, and Claudio and Xiaolu and Murakami-san is also the team member. And thank you for your attentions. Okay.
Thank you very much, Katsuhiro. Truly state-of-the-art and quite fascinating. People were asking yesterday about real-time simulation. It came up, and I said something that we are pondering, but I didn't know that Nishinari's team is already doing it. So I take my comments back. It's already being done in Tokyo. There we go. That's why we are here to know the state of the practice. So it's already happening. And the wonderful work that you are doing in this space in Japan is really valuable. And if you guys haven't read the book that Professor Nishinari and my good colleague Claudio have written, I highly recommend it. It's the most comprehensive book in this space, and it's a good read. Definitely must read. Okay, thank you. Thank you very much. Well, next presenter is myself. I am going to split the topic that I had proposed, this topic, the theory of self-regulating crowds, into two parts. I'm going to present the first part of it in this session, and then in the next session, I'm going to continue that. The first one has more of a proof of concept, a demonstration of the concept in experimental setting, and the second part moves to the social science aspect of it, how we can implement the notion of self-optimizing crowds at a community level, how we can measure it, how we can enhance it, things like that. But they are part of the same story, basically. So what do I mean by the theory of self-regulating or self-optimizing crowds? Can crowds manage themselves from within? How does it work? Is it effective? Do we even need it? That's what I'm going to talk about. So in order to just give some context of where I am getting at, I'm going to make a differentiation, and that has already been done to some extent by the talk that Claudio gave earlier yesterday about traditional top-down approaches in crowd management and what I think is missing, the bottom-up approach in crowd management. And Katsuhiro, you are right. This pointer is not really easy to use. But I'll manage, as you did. So what do I mean by the traditional top-down approaches? Well, traditionally, if we go back 100 years ago, or to the time where that massacre in India happened, even further back, crowds have usually and traditionally been looked upon as troublemaking entities, things that we don't want to happen, and they can potentially pose risks, and they should be controlled. It used to be that crowds had to be controlled using draconian measures, quite hardcore enforcement measures, well, from the spectrum of shooting at them to the things that we have seen, the use of batons and things like that. But overall, we see crowds as entities that need to be controlled and managed by an external force. We monitor them. We deploy police force there. We use barriers and bollards and things like that to influence them. We want to manage them externally, okay? But if you look at the crowd from an entity, they should also be able to improve their own efficiency. If you look at it from the perspective of a system that is composed of many decision makers and actors, it is reasonable to assume that decisions and actions of those individual components would have an impact on the efficiency and safety of the system. So this is how I got into thinking of how can crowds make themselves efficient by the actions of the people within the crowds. This is not to replace the traditional top-down approaches. We do need real-time monitoring. We do need the presence of security forces. We do need barriers. We do need nudges and all sorts of external influence. But can also crowds make decisions that make themselves more safe and more efficient? That's the question. How can that be? Potentially, I think through education, through real-time information, through information in social media. In my view, the best way is school education, so that the crowds, so that the students can be exposed to certain actions, decision-making strategies that can make them safer during times of emergency or non-emergency when they are in crowds. This makes a generational difference, and we know that when kids learn something, they will go home and discuss that with their parents at the dinner table. Some of them do, and that would transfer the knowledge like a vector to the community at a broader scale. That's how I think of it. And it is consistent with the spirit of this model that was discussed and introduced at the previous Crowd Safety Summit. It is just a conceptual framework. It is nothing but saying that crowd safety is not only a matter of modeling, is not only a matter of sensing, it's not only a matter of legislation, it's a combination of all these things. In doing so, I likened crowds to a system that is subject to risk. And I said when we want to prevent risks from getting to our system, we put in place defensive layers, defensive mechanisms. But these defensive mechanisms are not perfect. They have flaws, they have holes in them. So if we have one layer of protection, when the risk comes and gets through the hole, it gets to our system and creates catastrophe. But if we have multiple layers, the likelihood of all these layers failing at the same time reduces. This is what we mean necessarily by the Swiss cheese model, meaning that if we have more layers of cheese, the likelihood that all the holes align in those layers significantly reduces. Therefore, the system becomes more resilient. Nothing too fancy about that. And I sometimes use this military example, but probably best to avoid. And I have seen examples of how communities' actions and responses in times of crisis, for example, I've been monitoring the space of where these kind of community preparedness, people showing the right action at the time of a crisis or almost near crisis has made a difference. And I have had examples of cases where the actions of communities in Australia at times of terror attacks, at times of public attacks against crowds have made an impactful difference. The idea goes back to nearly 2018 for me, when I had developed a simulation model, and I was trying to figure out the best way that I can use that simulation model to make crowds more efficient and safe. And I started basically playing with the behavior of people. I thought the model is fully parameterized, meaning that the tendencies, the behavior of people, the actions and decisions that they make can be modified by me changing the parameters associated with those aspects of their behavior. So I started running some optimizations on their behavioral aspects by introducing more tendencies, for example, for the crowd to be more imitative in their decision-making in certain areas, to be less imitative in certain areas, on a spectrum, changing those behavioral trends to see how that impacts on the system and whether or not that impact is significant. And I was amazed by how much impact the system can produce by changing certain aspects of people's behavior, by changing their tendency to show more imitation in their navigation and wayfinding, less imitation in their navigation and wayfinding, for example, by changing their attitude towards decision agility and their willingness to change the decisions that they have made previously. How much on the spectrum of very rigid decision maker to a flexible decision maker, changing this attitude, changing this behavioral tendency would impact on the system. In what direction, and is there an optimum that can be reached? Yes, there is some optimum that can be reached in some cases. How about the reaction time of people, in the attitude of people, in how quickly they react to an emergency announcement? Would that impact on the efficiency of system? And if so, in what direction, and what would be the best behavioral strategy that we can come up with? And then the question became, okay, let's say that there are certain tendencies that would make the crowd more efficient, but how do we make the entire crowd to follow the tendencies that we recommend them to follow? That is impossible. You cannot even get 100% of people to agree that it is daytime right now. There will be somebody who would say, no, it's nighttime. People would not agree on anything. People would not show full compliance to anything, not even to the recommendations on COVID-19 vaccinations. But the question was, do we need full compliance and full following those efficient strategies? And that's also what I tested. In my testing, in some areas, in many areas of behavioral tendencies, we did not need 100% of the crowd to follow the efficient strategy. In many of those cases, as soon as the efficient strategy reached the 50% of concentration within the crowd, when I had 50% of individuals in the system exhibiting the efficient strategy, the maximum benefit had already been reached. We did not need more people to follow the strategy. I mean, they could, but their impact on the system efficiency would be marginal. So this is, for example, one of the examples of me changing the concentration of people doing the strategy that I want in relation to how they make their decision making in choosing the exit, for example. And then looking at the impact on the system, showing that when you go from 0% of good strategy to 50%, there is a significant efficiency to gain. After that, it flatlines. It doesn't really matter. So all of that became a motivation for me to test these behavioral strategies in experimental conditions with three things in mind. First of all, does it work? Because it works in the simulation, but it doesn't guarantee that you can influence people's behavior. Would people be able to even follow what you give them as a strategy? And if they do, would that have an impact on the system? And would the impact that it has on the system follow the same pattern that I have seen in the simulation model, or reality is going to be vastly different? So I made a transition from doing experiments for the sake of observing crowds, observing patterns, gathering data, and developing models. I call that observational or descriptive experiments, to a new phase, which I call interventional or prescriptive experiments. 2.5 years ago, I did this series of experiments over 4 days. They only aim of these experiments is to manipulate people's behavior and observe the impact on the system. The aim is not to observe the natural tendencies of people in order to translate that into the models. That would be the green ones, the green experiments, the previous generation of experiments that I have done. So I'm going to explain some of the results from this generation of the experiments. The results have just recently been published about 4, 5, 6 months ago, so still fresh. So what is the general overall principle of the design of this experiment? Quite simple. I bring 150 people into a venue and I start an experiment. The purpose of that experiment is to focus on a specific aspect of people's behavior. What aspect of the behavior? Some of those aspects, one of those aspects that I pointed out earlier using simulation modeling, based on the hypotheses formed as a result of the simulation testing. So I focus on one aspect of behavior. And I start some system, evacuation system, something, and I ask that group of people to do the behavior requested, to perform the task requested when completely naive about any strategy. So they do it naively. That is what we call 100% of people being naive. Here, if I can just get the hold of this, and like that. 100% naive. Then I request 20% of those people to come out of the venue, and I have a 2-minute instruction with them. I say, when you go back to the venue, with respect to this aspect of behavior, this should be your strategy. And that strategy is short enough to be read within a line, within a sentence or two. And I read that out to them twice only. And I request that they go back and simply mix with the crowd and do not communicate this to other members of the crowd. And then they repeat the same task that they did, the crowd, the mixed crowd, 20% being informed. They repeat the same task. Could be an evacuation of a venue. Usually, the impact on the system is much easier to measure when you organize an evacuation. But it doesn't mean that it's necessarily related to a case of an evacuation. It's just easier to impact the efficiency of a system when it's about discharging a crowd from a space, which we typically call evacuation. And then I repeat that with another 20%. I add another 20%, and then I add another 20% until I get 100% concentration of good strategy within the crowd. And each experiment follows the same pattern. 20%, 20%, 20%, and a number of repetitions at each level. 4 repetitions or 3 repetitions at each level. So you add 20%, you see the system becoming a little more efficient. You add another 20%, you see the system becoming, again, more efficient. The next 20% that I add, sometimes the system does not really change that much. And the last 20%, it could be that the system does not change at all, meaning that I already had the benefit of adding good strategy somewhere around here at almost 50 or 60% of concentration. But also it varies. It depends on the type of action that you are talking about. So the first thing that you need to measure when you do interventional experiments is this. Before you test the efficiency change of the system, you need to measure whether the instruction that you gave people, the strategy that you gave people, was in fact implemented by the crowd. So that is what I call the measure of intervention success, meaning that intervention has in fact influenced people's behavior, those who were informed of that strategy, in the direction that you requested. Because sometimes those strategies are not quite 100% easy to follow. You might say, I'll disclose one of the strategies. For example, in relation to exit choice, the line of a strategy reads this. When you go back to the crowd, when you make the exit decision, follow the direction chosen by the minority of people. Follow the direction chosen by the by the least number of people, or something to that effect. Well, the person steps into the room, makes a decision. They want to be a good participant, but they are humans. They might make a mistake. They might not be able to necessarily choose the direction followed by the minority. So I have to measure whether or not that simple instruction has in fact had an impact on the person choosing the direction of the minority. And yes, it has had an impact. As you can see, in almost all cases, people have been able to implement, by and large, the strategy given to them. Yes, they make mistakes, but overall, by giving that simple strategy instruction, the behavior does shift to the direction that you requested. The person might not be able to find the least congested or the least, the direction chosen by the least number of people, but they might choose the second least by mistake, but still that has an impact on their behavior, on the direction that you requested. And in all cases, I found out that people were able to implement this strategy. So I can say the interventions were successfully implemented by people. Now, we need to look at, okay, the interventions were implemented, were they effective? So the measure of effectiveness of the system. So we need to look at the system. So this is how I measure intervention success, for example. If I may just, no, I'll stay here. For example, the person enters in the room. I assume that the strategy is to choose the direction chosen by the minority of people. Then I look at the moment this person has made a decision, I evaluate the situation, and I give a score of whether or not this person has made a decision consistent with the strategy that was given to them. Assuming that this is a person with a strategy based on the color of their beanie. This shows to me that this was a person that had a specific strategy and was not a naive participant, okay? And it might be that they score 100% by choosing, in fact, the least congested, the least chosen route. That's 100%. If they choose the second least, then they get the lower score, and then so on and so forth. But overall, calculations shown in the previous slide shows that people with the strategy scored significantly different on that criterion, and that criterion depends on the type of action and behavior and the strategy that I'm talking about. People score differently, and that guarantees intervention success. So basically, all of these images are showing how intervention success was measured. And these strategies given to people were in two different domains. Either I target a decision-making aspect of behavior, something just like I said, exit choice or reaction time, or exit choice adaptability, how adaptable they are, how much willing they are to change their decisions that they have made previously. These things, aspects of decision-making. They could also target aspects of physical movement, how they conduct themselves in a bottleneck, for example, how fast they move. So physical aspects of movement and decision-making aspects of their movement. In all those areas, the system became more efficient as I introduced good behavior. The system became more efficient as I introduced good behavior. You can only look at the bars and ignore the line charts. The system became more efficient as I introduced good behavior, incrementally, and in some cases, it flatlined after some point. This pattern is the case in relation to decision-making aspects. The first few 20 percentages, those are the most crucial ones. The last few 20 percentages are not that important. And I emphasize, this is only the case in relation to decision-making aspects. I also added bad behavior to the system just for fun, the opposite of good strategy. And what I found was that the influence of bad strategy introduced to the system is actually more pronounced than the good impact of good strategy. So you inject bad strategy, the impact is quite sharp. You introduce good strategy, the impact is there, but is mellow. So bad strategy has a more dramatic impact on the system than how good a strategy improves the system. So that was just for fun, just to see how misinformation or misconception about good behavior could impact on the system. Also looked at the physical aspect of the movement. how they conduct themselves in a bottleneck, things of that nature. You can ask me during the panel discussions. I'll be happy to elaborate further on every aspect. And then what I observed was that in relation to physical aspects of movement, one, people find it easier to follow compared to decision making. When you give something that is related to how they conduct themselves physically, the success rate of implementation is far better. That's one thing. Two, the impact on the system is much more tangible and much more significant, even though we had impact from the decision making as well. But the third and most important one is that the impact on the system is linear, meaning that it does not flatline usually. Even the last 20% matters. It does not necessarily flatline. Even the last 20% is as important as the second last 20% and as important as the first 20%. So it pays off to convince as many as people as we can to implement those strategies. So the system was more efficient with good strategies, etc. These are just demonstrations of it. And that was the case at any point in time. A system with 100% good strategy at any point in time was more efficient than a system with 80%. At any point in time was more efficient than a system with 60% good strategy, and so on and so forth. Let's just go through one of the experiments in more details, because that's experiments that I've done over 4 days, and that's almost 12 rounds of experiments. It's hard to explain detail in single experiments, but this one is more interesting in my view. So when we have a group of people, when we have a crowd of people, so we talked about social groups in the previous presentations by Nan, and you know that it's one of the most, I wouldn't say controversial, but one of the most, one of the areas that we ignored in the past. We are realizing that we need to pay more attention, that people do not necessarily go to the crowds by themselves. People usually show up by groups of families and friends. And a study after a study has shown that the presence of groups in crowds introduces inefficiency. So in this crowd, for example, it is not a crowd of social groups, except for one couple that we have in this room. They're already sitting separately, so I'm not worried about that either. If I ask people within this class, within this room, to evacuate, and then bring the same crowd, same size of the crowd, but with groups of friends and individuals who would not separate in the case of an evacuation. Same number of people, but some of these people know each other and are families, families of 3, families of 4, families of 5, and repeat the same process. Time and again, we have observed that the second crowd would be much more inefficient than the first crowd. And if you have groups of 5 rather than groups of 3, then the crowd is even further more inefficient. Okay? So can we compensate for that inefficiency using a simple behavioral modification, for example? That was one of the experiments. That was the last line of experimentation I did in this round of behavioral experiments. So, oh well. We brought single individuals, on the account of time, I'm skipping through. We brought single individuals, did experiments with single individuals, and then grouped them in groups of 3, and then repeated the experiments, and then grouped them in groups of 5, repeated the experiments. Obviously, the groups of 5 crowd was more inefficient than 3, and 3 was more inefficient than single individuals. However, we did 2 interventions. In one intervention, so this is a group of naive crowd, just doing the task. This is a group of people, this is where I introduced an intervention. I asked them to hold hands during the entire process of their movement. They held hands. And in this case, I introduced another intervention. I asked them to hold the back of each other's clothes. We talked about the movement of snakes within crowds. I think Ashish was talking about it. So I asked them to form a snake, and I measured system efficiency. So this is where the crowd is instructed to hold hands. This is where the crowd is instructed to form a line or a platoon or become a snake. Same thing for groups of 5. Hold hands, form a platoon. And obviously there is also another treatment where the crowd is just naive and can do whatever they want. So what you observe is this, that holding hands has no impact on the efficiency of the system. Holding hands is just similar to the crowd being naive. The crowd naturally moves as if they are holding hands, if you don't give them any instructions. That's what I am saying. So they already are moving, even though they are not physically holding each other's hands. They are already moving in a manner that resembles hand-holding. But when you instruct them to form a platoon or a snake, then the efficiency gain is significant, and the system becomes almost as efficient as a crowd of single individuals. So the whole inefficiency introduced by the presence of groups disappears by this simple intervention. And that's excuse me, the same in relation to groups of 5. When you introduce the platooning strategy, the inefficiency goes away. The reason that is the case, we measured. We found out that when groups are behaving naturally or when they are instructed to hold hands, these 2 treatments, the first 2 lines on top, green and blue, they occupy a significant amount of space between them that is not usable for other groups, because other groups would not violate the space that is trapped between them. And as such, the amount of space occupied or trapped in between the groups is significantly higher in these 2 treatments when they are instructed to form a platoon. At any point in time, that space reduces significantly, making a space for other people to use this space. Basically, the footprint of crowds reduces, the spatial footprint of the crowd reduces significantly by this simple strategy. That is what I mean by bottom-up approach, influencing crowd behavior, giving them some strategy that they can implement to make themselves safer at the time of a crisis. And I'm going to continue that in the next session on how that can be spread more broadly at the community level. Thank you very much. And on that note, I have the pleasure of introducing the last speaker of this session before we head to the panel discussion. My good friend and a seasoned crowd manager who has traveled to us from Belgium today to talk about his experiences and the new developments that have happened in his company. My good friend Anton is here. If I could just find... No, it does. I've read it for everybody. I'm just a little bit disoriented right now. Anton, where are you, Anton? Did I? What page? Page 4. Yes, here we go. He is the co-founder and COO of CrowdScan, a patented crowd monitoring technology. He has been Deputy Chief Special Arrest, Deputy Chief Public Order, and SAG member of the Antwerp local police force. He is a lecturer of Introduction to Crowd Management at the National School of Police Officers in Brussels and holds a postgraduate in disaster planning and loves to combine data with operations. Looking forward to your talk. Thank you.
The pointer. Is it? Okay, thank you for the invitation, Milat and Keist, for having me here. I would suggest you indicate when I have 1 minute left, because I didn't time anything up front. As you can see, I would like to talk about the topic you see here. Can data and technology enhance safety and efficiency at events? I think the answer is yes. We saw a lot of presentations, still work to do. And I was very gladly surprised with the presentation of Professor Nishinari before me, because I think we have a lot of resemblance on the topic we're going to decide. I think some of my academic colleagues should have a call with you as well, because you seem to be, I don't say ahead, but already have some beautiful insights on some of the same topics. So always nice to see. So I would like to divide my presentation into two pieces. First of all, I would like to introduce our new CrowdScan technology, because I think for a lot of people here in the room and also at home following online, our technology is still quite unknown, and I think it can add value to perhaps some of the research projects or real-time operations. And then in the second part, as Milat already explained, I would like to introduce two projects which are going on in the Netherlands at this moment, which try to address some of the challenges we met earlier on in some other presentations as well. And then, of course, some conclusions. First of all, CrowdScan. So CrowdScan, we developed, in fact, it was Professor the Vice Dean of the University of Antwerp, Maarten Wijn, and two of his PhD colleagues, Ben Belkes and Stan Dennis, who are co-founders of CrowdScan as well, together with me. They invented, in fact, a new wireless sensor technology, or they found at least that you could measure the number of people present in a certain area based on this wireless sensor technology, which has been patented meanwhile. Now, how does it work, in fact? I have one of the sensors here, and you can ask me afterwards as well. But what will we do, in fact, is we install sensors around the area you want to monitor. And this can be inside or outside. Size doesn't really matter in that sense. You stick them in between hip and shoulder height. And all these sensors, let's take this room, would emit an electromagnetic signal to each other at a frequency, a typical IoT frequency of 868 megahertz or 920 in other countries. And what we will do is we measure the signal strength in between all of these sensors when the environment is empty. And when people flow in between the sensors, they will just weaken the signals in between all of these sensors due to body mass. And that's what we use, because the patent or what we saw is there is always a correlation between the signal strength difference and the number of people present in that area. So the more people there are, the more the signals will be weakened. So what we do, in fact, is we will measure the signal strength difference that will be sent to a gateway, and this gateway will send the differences to the cloud. And it's in the cloud, in our servers, that we will convert this measured signal strength difference into a people count. Why is this a handy technology, or I believe it's an add-on on already existing technologies? But they work on batteries, so it's quite easy to install them around an area. They don't need line of sight, so they're not visually impaired, so in harsh conditions. And I know there are cultural differences, they're completely privacy friendly. So especially in Europe with GDPR, we don't connect to smartphones, we don't use cameras, which allows for a complete privacy friendly solution by design. Large areas can be subdivided, as you can see on the image as well, into smaller pieces if you expect different densities in certain areas. So for the moment, it's used in events, but also public transportation. Tram Barcelona uses it on the platforms, can be used in airports, of course, or all places where there are large number of crowds gathering. This is an example in the city of Breda during an event, and I will use this example also later in one of the academic projects that is currently running, where they installed the sensors around this square. And you will see, this is a graph we have in Grafana, what happens. So people are floating in, we install the sensors around, 12 sensors around this square, and when people start floating in, we measure a signal strength difference. You can do an exact people counting as well, but normally for one-day large-scale events, we use percentages, fill rates. Just saying like 4 persons square meter is 100% decided in a crowd management plan. We're just going to estimate, and it will start filling. So this allows real-time monitoring of an area, and you don't have to bother about, let's say, the podia you see, which sometimes would blur vision of CCTV or something else. At a certain moment, it will flatten out, and as it is an electromagnetic signal, you will see the fluctuations on top. So it's never a straight line we don't mean to have an exact head count. So saying this is 4,700 people or 4,680, it doesn't really matter in this case. So it's just to be sure that you know what is happening. Go slide by me. So to visualize that, that's one of the squares you see on CCTV. They have CCTV. Aside that, you see our platform offering real-time data of that area. So you have actionable data in real time about what is happening. So the second part of my presentation, presenting the two projects, I would like to start with the conclusions I had on the first Crowd Summit Milad organized in 2023. Why? Because a lot of them are still valid, and I will run through them very fast. Some might still remember them, and a lot of the conclusions I already saw before. You can read also on your own, of course, but basics always stays like everything starts with a good crowd management plan. Without a plan, you cannot do a lot. Technology can support, but will not replace a crowd professional. That remains as well. Every limitation, every technology has its limitations. So be aware of that and know them. Ideal solution will also be a combination of technologies, as we saw before in the presentation as well. And what is sometimes a problem is it's considered an investment technology. So I think we still have to struggle with this one. Consider it as an investment. Like we say, you know what it costs, but you know what a disaster can cost you as well. Not only on reputation, but financially, and also, of course, for the families. And then concerning the data, know what you are measuring. What do you want to see, and what is the type of data you need? Know how to interpret the data as well. If you measure smartphones and you have like an event where only children arrive, you're not going to measure a lot. You can laugh with that, but it happens. And I saw it myself. People are measuring something. They think they see something, but you know it's just wrong because they use the wrong kind of technology or the data. And combine everything in one single platform, also often a challenge. Now, the two projects I would like to present, they try to address quite some of these challenges. So that was stems me hopeful, let's say, for the future as well, that we are taking steps into these things. The first one is a project done by the University of Breda, together with the city of Breda, which runs over you can see a period of 2 years, and you have the contact details as well. It's also with Sanne Kuipers and others. It's a whole team, of course. They're running a minor on crowd safety as well, so they did the job, and I thank them and also TU Delft afterwards for the next presentation for allowing me to use the slides to present this to you. So if you want to have more insight on these projects, feel free to contact them or to reach out. To give you an overview, city of Breda, mid-sized city in the Netherlands, small compared to, let's say, Seoul, but it's around 160,000 people. Narrow streets in the city center, older city center, and as you can see on Google Maps, they organize a lot of events where they use some of the squares to organize specific events. Place podia, people gather there. You have Havenmarkt, you see Kerkplan, and then the large market. And when they organize events, it's often over the 50,000 people that arrive in this inner city, which spread out over these different areas. And as you can see here, you get this kind of image. So quite a lot of people, quite dense, vibrant community, let's say. And they like to party, the people in the Netherlands, so they have a lot of these kind of events in the city. But what they had in 2022, you see the connecting street in between Haven and Havenmarkt, and suddenly they had like an image of this. And that's something you don't want to see. Everything went fine, but as we had unfortunately here in Itaewon as well, things like this can go wrong quite quickly. So this was the reason why the city of Breda asked the University of Breda, okay, we want to organize safer events in the future. We have to adapt our crowd management planning to organize them in another way, do better risk analysis, be better prepared for these kind of simulations. So they came up with a scope of the project with 3 different steps. I'll show them already. And this is what they decided. So the first step, and we saw it already with the modeling yesterday as well, we need reliable insights, good data to be able to monitor, or to do simulations, to do risk assessment. They didn't have that. So that was the critical first step. The second step was indeed by modeling, and not into the detail you already described, Professor Nishinari, or some of the models, but let's say quite basic, if I can say so. Just model to get an estimation of what is the max safe capacity of every area in that city. How are the crowd dynamics, to get a better understanding, to do, first of all, simulations, but also during, or be able to evaluate afterwards. So that was the second, or that is the second step they have foreseen. And the final result should be a blueprint, a framework to organize these events. So based on 12 scenarios, if they have an event in the city and they know it's this type of event, these areas will be used again. We expect that number of people. How should it be organized so that there is a blueprint, a standardized approach to do so? That's the final goal. So for that reason, they took a 2-year span, like I said, and they selected, because they have a lot of them, so that's easy, 5 projects in which they would treat these 3 different steps accordingly. So let's start with the first one, reliable insights into data. So what they did, they defined, in fact, on a map for the first events, they mapped out the event, they defined which areas would be of interest, and then decided also on what would be, based on the data they need, the good positions to monitor, to place technology, to gather the data they would need for the simulations, as I explained. This is nicely said, but I was very pleased to see that the first step they decided, apart from the 5 projects, was to determine, like, okay, we want to install technology and measure, but we don't really know the capabilities and the limitations of all the technologies. And that was a nice, like one of my conclusions back in 2023. You have to learn that. So they admit, like, okay, we're not quite sure what's best to use, so let's first find out that. So they used some smaller project, like you can see, celebration of a football game. They became champion, and they installed CrowdScan and also the dynamic crowd measurements, so from Professor Tatrai, the cameras to measure. They started with those 2 technology as well. And as you can see, quite a dense crowd with some specifics, football. It's a lot of smoke, as you can see. So the cameras they gave, and I heard there are a lot of cameras and AI used here, which works quite fine. Very good density approach. So we measure the amount of people per square meter, which is fine. But then, of course, if you get a smoke, you just must be aware that at that moment, harsh visual conditions, you can have a problem. But every technology has one. I now take one of cameras. We have our limitations as well with the sensors. Wi-Fi has them, telecom, they all have them. So you have to know them. But they gathered all the data they needed, so that was good. So they could start with the modeling, the safe capacities. We all know these kind of graphs also from Professor Keith Steele back then, and Froon, like at a certain point of density, flows will start to diminish, become less fluid, and where do we have problems? So with manual countings, because they have some students, they could do manual countings, installations of the technology and the data they gathered in the first 2 events, they start modeling. So they wanted to understand, first of all, can we build a model that simulates the data? And we had evaluation data to see also what the models produced. Did it correspond to the real situation that was observed before? So it was a 2-directional way of measuring. And they wanted to use this to indeed measure the crowd dynamics in all these different types of areas, establish the critical thresholds for every kind of environment to get a better understanding. So you see also LiDAR, visual, footfall, AI cameras, radio waves. So they used everything to gather data in some other events afterwards as well. And to get a better understanding, as you can see, you recognize the squares. How does the inner city look like? And when they had that, they said, like, okay, now the goal is to go to a blueprint for this optimal design. The problem is it's always the same city they have to use, but not all the events are as big. Some are a bit smaller, some are a bit larger. So that's why they want to develop 12 scenarios, which describes the dynamics of every event, the critical densities, and which technologies should be implemented where, dependent on the type of data you want. And if you start simply, people who sometimes do a ramp analysis or they just draw the event, it's not as fancy as a digital twin, but sometimes you just start with an easy drawing. These are some of the events they draw, and as you can see from this one, they got a kind of generalization of how an event in the city looks like. And they came up with 4 distinct, let's say, different areas. You always have the boundary, the outer area, the black line. You have then, let's say, the entrance, the egress, exit, entrance on the outer area, defining what they call the border areas around to really arrive at the center of your event. So these are these orange core areas, and then in between, as you can see, you have what they call connecting areas. So that's how a bit their framework, how they worked to describe the inner city. And as you can see, for every of those areas they described or they found out, you always have in the model, first of all, the physical environment, the building, the houses as such as it is. Second one, temporal installations, podia you put in place. People start to move due to these temporal installations in a certain way, and you have to manage that. I'm quickly going through this. So what I defined is, okay, we have these areas, what is the data needed, and what is the best tech to install to measure all these things. That's in fact the aim. And this is the final slide for this one. Final goal of City of Breda and University is, in fact, now we have the data, we have reliable data, go to better analysis, risk analysis, doing simulations before the event. They want to be able to really support, monitor using tech what is happening during the event and to be able to analyze what is the impact of operational decisions on the crowd dynamics, because they know the critical thresholds, they have the data. And then finally, have a permanent evaluation loop also afterwards, doing simulations again to improve the framework they have. And that's the way they want to organize the big events in the city of Breda as from now. Always start with this same loop and improve. Quickly, the AI Compass. You have an AI model, Professor. That's it just started in November, also with the Dutch Research Council. It's the AI Compass. What they want to do here is get an improved AI model. And you see the word prediction, so be careful with that. But it's a data-driven model, so not generative AI, a data-driven model where they want to be able to have real-time monitoring, but to do some kind of predictions as well. And it has to meet 4 criteria. So it has to be in line with the AI Act. So that's the fact that it should be explainable and also accountable. So that's why they have to build in an evaluation tool to see that these 2 criteria are met. So it cannot be a black box. So that's one of the criteria they have to meet. It has to help to support the decision-making tool, meaning that the data should be contextual. You must understand what you see. Like if you see a sudden movement of crowds can be due to meteor, artist programming, whatever. So you must understand what you see, or the system, the model should understand it. It should be able to provide role-based data. Depending on what you do or what your function is, you should get the adapted data. You don't want an overflow of data. And it should be actionable. So it should be essential data, it should be accurate, and it should be easy to understand what you get. So that's one of the challenges. Collaboration, that's a challenge for them as well, between humans and AI. Trustful relation, meaning why is something decided by the AI? Where does it come from? What data did it pull? Because that's something they think might be a challenge. It should avoid de-skilling as well. You don't want people using your AI model to lose the skills they have. Like an autopilot in an aircraft, your pilot should always be able to land. The auto land function can do it for you, but you must do it yourself if needed as well. So don't. And accountability and control. A question arises as well, like if the AI model suggests an action, who is accountable if things go wrong, perhaps? So who is in the lead, who takes control, who's accountable? And then co-creation, that's something they're gonna, or I don't say they worry about, but is of importance. It's like what data should be included, who are the stakeholders we have to talk to give us the data. It's not only the crowd professional or the police, but also the inhabitants of the city, economical data, whatever. So everybody is involved. So define the input of the model so everybody knows all the data needed is effectively included in the model. Gonna watch my time. Okay, 5 minutes, perfect. So that's the AI model. I see there were a lot of steps taken by a lot of participants here. So I think there can be some collaboration so we don't have to start from zero. And I don't think they started from zero, the people from TU Delft, but again, it's quite an extensive project. I had the conclusions before. I just added some new or I adapted them. So first one, what we see is there is growing interest in data fusion, sensor data, data fusion. Back when we started with CrowdScan, I have to try to sell it, let's say, why do we need data? And there were no platforms, whatever. So now there is a growing interest, it's going better, but this gives new challenges. We need better developed digital twins as well, and event control centers where all the data comes in and you understand what you get. So that's the challenge. Interoperability of all these data, what we see now is they require a lot of, let's say, data standards as well, or exchange protocols. A lot of suppliers offer data, but they're just not able to combine the data in one platform. We need standards for that. Faster adoption, we talked about it yesterday. I didn't add it yesterday. It's faster adoption of academic research by crowd professional. The exchange of today, of yesterday, we discussed it already. I think that's key to help everyone. AI can offer actionable data, so I think there is going to be a nice progress in how AI can help us in predicting everything, but it's not like we discussed also already, the magic solution, like social behavior. Not everything is going to be solved by putting AI on a model. So let's keep training ourselves to become or to stay a crowd manager and trust sometimes gut feeling as well. Don't steer blind on what AI tells you. And also, we have to focus more, I think, on the return on investment of data, let's say for event organizers. Before I said, it's not a cost, it's an investment in safety. Now I go one step further, and you can really gain money if you use the data for other things than safety. Like if your VIP area is 60% full all of the time, next year you can invite 40% more VIP in your area. And your system is sold. And that's what we don't do enough right now, is safety, but the data is not used by potential other stakeholders that can use your data as well. And the impact, depending of privacy, it remains, let's say in Europe, we keep getting questions on cybersecurity, the risk of all this tech. Is there a risk for cybersecurity if there is a breach? And also on privacy. That's why CrowdScan is often used, because they don't like to place cameras everywhere in most European countries. Voilà, thanks for your attention. And if there are any questions, glad to hear.
Thank you, Anton. It's always great to get your perspectives as a professional, and really appreciate you sharing the insight with us. This also shows how much taller you are than I am, so here we go. You're ready for the next panel discussion. Let's do it. I'm sure there are going to be many questions. And to the people who are watching online, feel free to ask your questions. I'm monitoring the chat. No, I don't have a preference. You don't have to turn your head. Okay, let's see if there is any question online. Not yet. So we have to start from the room. Who is going to go first? Meghna.
Thank you so much for a wonderful combination of presentations in this session. And the first presenter, like when you talk about the holistic approach from various stakeholders, means a lot. And then Professor Milad, when you talk about the whole experiment that you did. So when you put up your interventions, my question is to you, what kind of participants were there? Were the same language speaking people? Second, was their education level same with the experiment you have done? Why I'm asking you this question is because in a real-time events like the Kumbh Mela, which is the largest one, we have multiple challenges. People speak multiple languages, right? So at the time of evacuation or any other problem, how much you can take care. Not just the foreigners are there, we have local among various languages. So these are basic challenges. So just wanted to know how you do this experiment and how it can be there in other settings.
I completely get the sentiment of the question. To answer it first and then I'll expand on it. They were almost 50% university students, 50 other percent came from just the community. I would say they were all educated and they all spoke English, but not necessarily as native language. However, the instructions that I gave were so simply worded that would not challenge the person who speaks English as a second language. To me, these experiments were just proof of concept of how intervention from within the crowd could impact on the system, just so that I don't have to show simulation results to convince people that certain modifications to the behavior of people can have major, major impact on the efficiency of system. And that is part of a broader area which I will talk about in the next section of the talk. And that is, well, now there is motivation to get out there to not just necessarily talk about these specific strategies that I showed in the experiments, but also educate at a broader level a crowd of safety measures, improve attitudes. I will talk about the areas where improvements can be made under an overarching concept, which I will introduce. I don't want to spoil it right now. And the whole purpose of doing that is to measure the areas of vulnerabilities of specific communities. Some communities, for example, might have a negative attitude or a poor attitude to crowd safety, for example. If that is the case, what I'm advocating is developing tailored and evidence-based behavioral interventions that are specific to the needs of a community. There is not going to be a prescription of, if you follow these things anywhere in the world, this is going to be good for you. It has to be done in relation to the community. And in doing so, you have to be able to measure the preparedness of the community, vulnerabilities of the community first, and then develop an intervention program tailored to that. So the next phase is actually going to be specifically concerning the very thing that you just, the very issue that you just brought up. So very, very relevant question. Yes?
So
Maybe
just
I can add something.
Please.
Okay. And as a cloud manager of the Tokyo Olympics and Expo, we welcome the many people from all over the world who do not speak, of course, Japanese. And so we focus on two things. First is a pictogram. It's not depend on the language, but maybe if you want to find the exit, so if you see the sign like this, then maybe they all understand this is exit. And two things is that color. If you see the red or blue, which do you think is safe? So that's a point that we are discussing inside the committee. Okay.
Yeah. So when I was listening the presentation since yesterday, so when it is a specific event, when I talk about like whether it is the sports event or visiting one religious temple site or any place of worship, I think most of the solutions are very much applicable. The complexity comes only when there's a mix things like really extra large events like the Kumbh Mela, where the complexity comes because like in your 5 steps flowchart, the first is information. Now in a country like India which is heterogeneous in multiple aspects, not just it is multilinguistic, but education, lifestyle, people will not even maybe bothered about the signages. So how would you disseminate information also in the first stage? Government tries and there are availability because of the technology, but it is not so much feasible. And that's the reason the small elements of the unsafe, unpleasant incidents still occurs. So in order to make it 100% safe in the future, all the technologies coming together definitely helps. And that's where I was trying to visualize, like when you talk about AI sensors with the football match and the smoke is coming. So we have a festival called as Holi, and that's a festival of color. Now, millions of people come together. Now, what would we do? Because that's again a place where people are hyper energetic. They put colors, and the cloud of the colors comes. So there are interesting things, and I think all kind of applications which has been discussed in a country like India, the number of events are so many that everything is applied at one or the other point every month. So that's the demand of such safe measurements and the crowd safety certificate programs. That is what was quite interesting to know. Probably needed much more in our country as well. Thank you.
If I can add to your comment. When it comes to community preparedness, my view on that is that you go from any front possible, okay? When it comes to informing communities, you have Kumbh Mela, okay? On the train to the event, you send messages, you broadcast messages, verbally.
WhatsApp is used a lot.
Yes, things like that. But, so any avenue possible. You run TV ads, that's expensive, depends on how much you want to invest. However, the most serious grassroots intervention that you can do is one that takes time, and that's through school education. Yeah. I think that's the most effective one. That takes time, 5-10 years. But imagine if there is a country where motorcycle safety is an issue, is a prevalent issue, and entrenched in a community. I can name countries where they have the issue. You cannot overnight eliminate it using any draconian measures of you're getting out there, we're putting these helmets on top of everybody's heads. That takes quite some time and effort and investment. The same thing, if areas of vulnerabilities are detected, the fixing, the improvement, the best way, in my view, is through a school education, give a generation, and things will change, I believe.
Completely agree on that.
I have two questions. The first question is about the education and training. The second question is textbook or guideline book. The first question is, as Professor Nishinari commented earlier, you have a plan to provide education to the officials, and you have a plan to the education should be mandatory for before any crowd event. But that kind of education program will be some acceptable for Japanese. I don't know the program. We want some general international applicable program. So how is the plan, not for Professor Nishinari, everyone, to applicable to any nations which have a plan to get us some community crowd event or something? This is first question.
Okay, first I'll answer. It's a good question. Before I start this program in Japan, I collect all the information from all over the world. And I found that in the United States or Germany or other countries have the similar education programs, but not totally the similar, because some are, they say that cloud manager, but I found that this is a fire protector or something. It's a very similar but different. So that's why I created our own, based on our book. That's a text of our program, and I created based on our books. But I think it is applicable to all over the world, because it's only the basics I check by the test. So in the advanced course we are now preparing is more special to the countries or regions. But in the basic things is almost common, I believe, then maybe we can discuss about our program. Unfortunately, it is in Japanese, but we can make it open to all over the world. So, yes, that's my point.
Anton, would you like to add to that?
Well, it's the same. You have to distinguish also the levels. I think it's important to know what degree of professionalism you want. You can do the master in crowd management, let's say, the kids still university courses. You have these one-day introduction courses. I think the most important is someone doing the job or involved in crowd management already has had some training and you know your limitations, but should every crowd manager be able to model or do risk analysis? I'm not a professional in do simulations, but I know I need someone. So it's a difference between how much effort you're gonna ask from someone. Is there a standardization in a country? If you want to do crowd management, you need at least this certificate. In Belgium or Netherlands, for the moment, it's not the case. I can call myself a crowd manager without doing any course, let's say. So I think that's important that these official levels will arrive and we don't have them in the Netherlands. So I think that should be worldwide, would be a nice thing so everybody agrees on which level has who.
And my take is that countries can borrow from each other. If Katsuhiro is developing a course and it's easily translatable, I think in the absence of another program, that could be used as a foundation and the best available training for any country. So that's the first thing. However, other countries can modify it, can tailor it towards their needs. And also you need to pay attention that no single course is going to guarantee it. Learning is all about having some foundation and also getting out there and improving yourself at an individual level at the same time as well. I'll just make an example. In university courses, what is a very classic thing that is taught? I don't know, fluid mechanics. I used to teach at my undergrads some fluid mechanics. If you look at fluid mechanics curriculum across different universities, you look at the course at this university and the course at the other university, they have the same title. The content is completely different. Depends on the perspective of the person who is teaching it, the background, what they think is more important. Yes, by and large, they talk about the same thing, but the coverage of the course is completely different. So the course that I teach, the guideline that I would think is most comprehensive would be different from that of another individual. However, you need a foundation. Once you have a foundation in fluid mechanics, then you can access any other material in fluid mechanics and expand your learning. That's the same thing. When you have a manual as a foundation, as a training basis, then you can use that and also go to other trainings and improve. And that goes, probably consistent with what you say, Anton, that there are different levels of training and education. You have foundational. Any foundational training would be better than no training at all. But then you can have different levels of mastery and somebody who has done all the courses and somebody who is in a position to now write a different course into the future. That can happen. So quite random thoughts I'm throwing, but it's complicated.
Yeah. And a small add-on, what I miss sometimes in the courses is also like the state of mind of people. You can follow a course, but decision-making during an event in stress is something else, and that's often not included in these type of courses. So you used to be a police officer, but you can now have to shut down the street, but if you don't dare to make the decision, or there is a discussion, there should be some leadership also there to do so. So the psychological or the social skills are as important as well, I think. So, and are underestimated sometimes.
People undergo the same training. One of them becomes the master, not all of them. It depends on your individual capabilities as well. We definitely agree with you on that. So, yeah.
Yes, I totally agree with your comments. And any educational program provided by some foundation will be better than no education about crowd management. But I'm worrying about too diverse content will be in the future, there will be some confusion. So how about our committee, our summit, our community provide some recommendation, basic recommendation of crowd management education program?
Yep. That's quite a commitment for me to make on the spot. I'm open to it. I'm open to it because if I say 100% yes, then I have to follow up with an action plan of how we do it. Do you guys agree that we consider that as something that we pursue into the future? Tentatively?
Yeah, of course. I think there need be some standard to each countries to protect our lives, and so it's a good chance to meet from all over the world. We gather here, so it's a kind of topic we should consider in the future, I think.
Well, I think Claudia already mentioned it once on LinkedIn as well. There are already, we don't have to invent the wheel neither. We have the Global Crowd Alliance. There are actions in the UK. There are a lot of crowd event specialists over there and courses. But indeed, the mentioning back then, you remarked like Asian countries are not really included, Global Crowd Alliance. I think it could be a good start to get all the already existing information training courses and then indeed have a critical look on what is already there, and then indeed in this kind of summits or organizations see if adaptations are needed. But starting from zero is going to be a waste of time, I think.
Yes, and my second question was about the book. And Professor Nishinari showed some basic, maybe textbook about the introduction to crowd management. And this is similar to first question. We have some basic guideline. It should be included in the textbook or something authorized by this experts committee. So how we should introduce some good books to the officers and responders and other experts, to good books. But we cannot find many related books about crowd management, especially crowd crash accidents. Just crowd safety is many books. Yeah. So
I'll start and then I let Nishinari to respond. I have read the book. Anybody, any manager, any practitioner, any academic who reads the book that Nishinari and Claudia have written, they would come out of that process much better informed. So when you say, how do we do it, it's just simple. The book is out there, accessible, and I think as a starting point, it should be widespread reading material for anybody who is out there dealing with crowds. It gives you the foundation, it gives you the principles, gives you the terminology, makes you familiar with all the sensing technologies, makes you familiar with the language and systems of simulation. It's quite comprehensive. So you would believe me once you start flicking through it, either through the file or in a hard copy. That's, I think, what practitioners and managers need. A foundational material to get them up to speed about what is out there. Because the whole notion is quite diverse. But when a textbook emerges that captures all of the diversity, that's the benefit of textbook as opposed to a vast academic literature that is all over the place. When a field is privileged to have a textbook, then I think that means that the field has reached a level of maturity. Unfortunately, thanks to these guys, our field has reached that level. So I think the benefit should be taken advantage of.
Thank you very much. And actually, we have a Japanese version of the textbook, which is more thin and easy to read instead of the English thick book. And for practitioners or not researchers, I recommend the Japanese book. And Actually, Japanese book is a text of our course, crowd management course, which is more readable. So the book mainly Claudio write, but it's a collection of all the researches. So some part maybe it's hard to read from the practitioners, and so maybe we can edit some part to make more readable or executive summary for that in order to promote our achievement. Yeah.
And if anybody who has come to my course in the past, they know that the first slide, no, not the first slide is my name in the course. The second slide is the cover of the book. I always say, you've come to this course, you could have just read this book instead. But they already have paid, they are there, so they cannot go back, so it's too late. But they go and read the book as well. So that's my recommendation to everybody. Please, Ashish.
Yeah, thanks for the wonderful presentations and the panel discussion. Just a few quick points. It was wonderful to see a lot of real experiments that you have done, Milad, and also good to see the snakes, serpentine groups. The context in which we have observed the serpentine groups actually results in extremely high physical and psychological forces, which we have tried, measured, and reported in one of the papers in Physica to an extent that it can cause body harm. So it's a very distinct characteristic and implication of serpentine group or snake-like group that we observed. It would be interesting for you to see and understand. You rightly mentioned that, in response to our question, that real experiments are good to show compared to simulations. But there are both pros and cons of each one of them. For example, in real experiments, it could be challenging, especially when you're doing evacuation experiments. It could be challenging to inculcate that sense of urgency. Even if you try to explain them, for example, you just explain everybody that there is a fire in this room and we need to evacuate. You really can't inculcate the sense of urgency. And accordingly, what behavior, the evacuation behavior that would translate into. So that's one challenge, which probably you can do better in a simulation with right parameterization of the agents, where maybe a simulation experiment could be better in trying to bring a more near accurate behavior into the system. Likewise, have you tried inculcating the impact of weather? For example, heat or some kind of other extreme weather like rain, etc., while trying to do this evacuation experiment. Sometimes, when fire happens, you also have these sprinklers coming out, so it's like a situation where people are wet and so on. So how much we are able to, so I think there are both pros and cons, your reflections on that.
Thank you for your thoughts, Ashish. I'll try to answer all of them. On the topic of simulation, first of all, I don't think these are replacement of each other. Okay, first of all, many of my experiments would have or could have failed had I not tested them in the simulation environment first, to have formulated a robust hypothesis to do this kind of experiments. Because when you do intervention-based experiments, there is some form of hypothesis underlying the experiment. Experiments do not necessarily have to have hypotheses, they could be exploratory, but interventional experiments by nature, you have some form of hypothesis that this intervention is going to work in a certain direction. And as such, it is really useful to have seen it in some form of platform that does not cost you by minute by paying the participants, meaning the simulation. So the reason that the experiments are successful, very successful, was that I tested the hell out of them in simulation environments. So that's one thing, they go hand in hand. And once you have established that these work, but there was still skepticism. Now you can say, well, maybe in the future, for more hypothesis testing, we can probably try. Milad showed that this series of 12 experiments matched 12 simulation set of experiments of equivalent nature. Maybe in the future, when we test interventions in a simulation environment, we have a better trust for them. Somebody had to test it, though. So it's similar to what Nan probably has done in replicating my experiments in the VR to establish the level of trust and validity for the future when he wants to just do a VR experiment that is not a replication of any other person's physical experiment. So we can say that, look, this platform, these experiments have been tested, validity has been established. Now we can trust the observations of this new experiment that has no counterpart in the real world experiments. That's one thing. Look, by the time I answered that part, I forgot. Oh, the fidelity, the level of stress. Of course, any experiment you have to always try to make it as contextually realistic as possible. That's for sure. However, when it comes to interventional experiments, contextual fidelity is the least of my concern, and the reason is that you are looking at the impact of an intervention on the system. So long as the level of urgency that you exercise is consistent across all the treatments, the level of urgency is consistent, it doesn't matter if the contextual urgency was very high or the contextual urgency was not so high. That is why in these red carpet experiments, I did not really push too hard for making the situation super duper stressful. I just tried one thing, to keep the level of urgency at a constant level, just to make sure that all different treatments are happening under the same contextual level, and that the only variable that is changing is the intervention being introduced to the system, because that's the variable of interest.
I mean, I get your point, but I mean, it's a good topic of debate, but I still feel the response in a stress situation of the behavior could still be different if you don't inculcate that. But I think that's something that we can discuss.
No, I have. I agree with you. And I have tested for that in a previous experiment in 2018. I specifically controlled for the level of stress. And the way I created that was that one treatment was without siren, no additional financial reward was involved. In another treatment, there was loud siren and financially motivated individuals to have smaller evacuation times. And I compared the behavior, and individual differences were observed, system differences were observed, and that is established. I'm not denying that. So when you increase the level of urgency, you get a different system. I just wanted to say why in the red carpet experiments, I did not push too hard to make experiments super stressful, because that was not the main factor of investigation.
Okay. With respect to your presentations, it's interesting to see your book. I haven't got hold of it, but I'll definitely read your book on the crowd management. On the certification of crowd management that you have started, I feel it should really be customized to empirical context of different countries and crowd that you expect. For example, German crowds and their behavior could be different than Indian crowd or Korean crowd. Say more deeper understanding that you give to crowd managers in the context of the kind of crowd that they are expected to manage, I think would be good. So we really need to customize this certificate. It's a good idea to do that. As Milad said, the fundamentals are all core, but at the same time, bringing contextual difference of crowd behavior of crowds of different regions and ethnicity and places, etc., I think would make the certification much more useful and impactful.
Yeah, I totally agree with that, yes.
I think a good manager, a perfect manager, would know the nuances of cultural differences of behavior of the crowd when she travels from country to country to manage crowds. She or he knows that crowds in India would have certain type of behavior compared to Germany, but that is quite an ask, and that takes a superhuman person to have discovered.
I know, so it's good to have collaborations with crowd experts in those respective countries who probably have better understanding of crowd context in those countries, and likewise customize these certification programs for those countries.
That's also why for big events it's always wise if you have an international team of crowd managers. So you have these different opinions, different languages, the way you talk, like Germany versus Spain, the way you talk to someone socially already is completely different. So yeah, you should do that.
This last point that I wanted to make was that, from crowd safety point of view, as we were discussing yesterday also, that preventing a situation where crowd spurge or crowd crush happens would be a better way to deal with crowd safety rather than trying to monitor the crowds real time, where the window of response or window of being able to do something is very small. Just a reflection from.
I think I agree. Yes. I think that's something we could all agree on. Wonderful. Thank you. Thank you very much. Last question.
Okay, I have a quick question. Actually, I have a question for the future congestion maps. Okay, I think that if the people knows the future congestion state, I think that, do you think there is no feedback effect? I think that maybe if someone knows the congestions already, they can choose some other ways, and it cannot be sometimes it can be a kind of some worse way. So I just wondering that.
Yeah, it's a good question. We did many experiments on that. The first we try to give their congestion map as it is, not the future. And next we give them the 10 minutes ahead from the time, and many things. And it works when we provide 10 minutes predictions, because the people are moving to the stations, and at that time they want to know the congestion situation, not right now.
So because of that, you choose the 10 minutes.
That's right. Yeah.
Yeah, meanwhile, we have the same with the CrowdScan. I didn't show the slide of fill rate prediction. If you know how much time it takes, you have the max capacity of a square. And then we did in real time, okay, we see how the density is rising, and then take the data from 10 minutes ago, 30 minutes ago, and 5 minutes ago, like how long would it take to reach 100% if it remains the same. So that is something for the future we want to do in real time as well.
My 10 cents quickly. If you have a reliable information, I think the crowd deserves to know it. It is consistent with the modern thinking about the crowd, is that the crowd is not the problem. The crowd is your ally, and you can use the information that you have to share with them to ask for their coordination and cooperation. Seeing them as an ally and not an entity that needs to be controlled, and not withholding information. If you have reliable information, I think it shouldn't be withheld. That's, I think, my view on this.
Since you said the last question, so I'm not asking now a question, just a comment.
No.
Katz?
That's it.
Okay, yeah. Just a
comment.
Comment. Katz wrote a very good handbook with Claudio Sensei, but I think 10 years before he wrote another very good handbook, which is, I think, worth noticing. It's complex transportation in complex systems.
Thank you so much for that.
With Andreas and
Yes.
Xiaolu. So very nice 2 books, so please have a look.
Many thanks to you, though.
Wonderful. Wonderful. And of course, please go if you want.
No, the basic crowd science book from Keith Still, Professor Keith still holds as well. So I think it's important.
Also,
it was updated as well. So if you read those 2 books, you already get quite far.
That was remiss of me to not mention that. Yeah, just because there is a new book in town, you do not throw out the old book. Every book has its own perspective, different views, and these 2 books have been written from rather different perspectives, both complementary. Wonderful. Very beautiful discussion. I'm really grateful to you guys. Thank you. Thank you very much. click here? Okay. We are off to the last session of the summit. I hope you've been enjoying it so far. We have 4 more speeches and 1 panel discussion. And after the panel discussion, we are going to announce the next destination of Crowd Safety Summit, and that will conclude the 2025 summit, the official part, but we are also looking forward to delivering the training workshop with Claudio and Mohsen. So if you have registered for that, we are looking forward to seeing you during those workshops as well, which is going to be, thanks to my colleagues, quite instructive and good. Thanks to you. No, thank you very much. Anyway, so as I said, I split this talk into 2 parts. And Mohsen, just because you weren't here, I thought I'd just flick through the slides that I showed. I'm talking about the notion of self-managing crowds, self-optimizing crowds, how crowds can manage themselves from within, how can they mitigate risk from within by the actions that individuals involved within a crowd take. And I made a differentiation between top-down approaches in crowd dynamics and bottom-up approaches, and I highlighted this thing as the specific layer of Swiss cheese model of crowd safety, and that's where we are focused on, community level preparedness, how we can make that layer of Swiss cheese model more robust with less holes and vulnerabilities so that it becomes quite a strong layer of defense against crowd safety risks. And I discussed that the idea came from a range of simulations where I manipulated the behavior of individuals in a simulation model, and then I realized that there are certain modifications to the behavior of people that would impact on the system. Therefore, I decided to test them in a controlled experiment and test the effectiveness, change the decision-making aspect of behavior, and change the physical aspect of people behavior, change the physical aspect of social groups behavior, and see the impact on the system. The overall message was that behavioral modification works. You can influence the efficiency of system with simple messaging and influencing the behavior of individuals within a crowd. So that was the whole lot of that was discussed during the first part of the talk. Now I'm going to talk about something broader. Where is the... Am I missing something? Might be. Anyway, turns out I'm missing something. That's fine. But the second part of the talk is generally more of social science nature. It's more social science. It doesn't have much of visual. It doesn't have aesthetics. Social science is not quite visual, is it? However, I'm taking that notion of community preparedness now to a broader level of community. Where did that idea come from? It came from my personal observations. I made a mention of an example of observing a crowd at a venue in a significant event in Australia, where I observed a head-on deadlock of 2 counterflows getting involved in a bottleneck, which had characteristics of a crowd crush, but it was prevented through the actions of crowd managers getting people in. As I was observing that event and that particular moment during that event, I was looking at the crowd from an elevated perspective in the corridors, in the stairways. And I could see other families, other people were coming and they were looking through the window where I was filming and gathering data and observing that situation. Some of them quite verbally go, no, we are not doing that. We are not going down there right now. They would wait in the corridor. They would wait in the staircases. They would make all sorts of decisions to avoid that situation by assessing that scenario that they could see there as a risk. And at that time, I was thinking to myself, well, that's a life-saving decision, silently made without anybody getting any reward for it. These decisions, collectively made by enough number of individuals, could have probably been contributing to saving that moment and preventing that potential incident from becoming a catastrophe. So these silent decisions that are made within the crowd, by members of the crowd, by family members, by an informed person, by a person that is crowd safety savvy, by somebody who can observe a situation and assess risk and then decide this is a situation where I should not be involved in, could be life-saving for them, could be life-saving for other people who are involved in that near-miss incident. Okay? And that made me question, would a different cohort of people, that was a crowd that was attending a concert. I was thinking, would a crowd leaving a football stadium, would they behave in the same way, for example? Would a crowd in a different city or country, would they behave in the same way? Or would they just go, let's wing it, let's just go, let's make it happen, let's go and join the crowd. We don't have time to waste, we are not going to stay in the stairways, or just ignore the situation down there, despite observing it, ignore it, and not recognizing it as a risk, and keep going and joining the crowd and building the density of the crowd further and further. So, would a different crowd behave differently? Yes, possibly. So, these collective aspects of individuals within crowds, making decisions that are more inclined towards safety compared to decisions that are less inclined towards safety, individual decisions, individual assessments. I thought that should be something that I should be able to measure. That is something I want to measure. How do I measure it? If I want to know whether a community is capable of making decisions that protect itself in a crowded environment, is crowd safety savvy, in other words, is there an instrument that can measure that level of savviness of a community? And you can see where this is headed. This is quite important when you're talking about cross-cultural differences. If you want to know where the areas of vulnerabilities are, you need to have an instrument that can objectively measure areas of vulnerability. So I thought I would describe this as an overarching term. And I had a slide for it, it's not here, that's okay. I call it the community level crowd safety culture. Community level crowd safety culture. The collection, the combination of the knowledge of people about crowd safety risk, the type of decisions that they make that can save lives. In the cases of emergency, in the cases of near emergency, the attitude that they have in crowded environments. And a combination of all these things, I compiled that under an umbrella term, crowd safety culture, and I decided that there should be an instrument for it to measure it. How do we measure such an abstract concept? How do we measure such an abstract concept? Well, I'm not the first person to measure an abstract concept. The psychologists have been in this business forever. They measure abstract concepts. They measure how you, as a person, they measure your personality. Your personality is an abstract concept. But then they score you that, oh, this person scores this much on the trait extroversion. This person scores this much on the trait agreeableness, on each of the key important personality traits, and then they give a picture of who this person is in terms of a person. That is an abstract concept, but then they operationalize that abstract concept, and then they develop something to measure it. And you obviously know how they measure it. They develop a questionnaire. They develop a standardized questionnaire that can measure whether my friend Mohsen is more extrovert than Claudio or the other way around. And if their instrument is valid, that would have some bearing on their behavior. That, for example, Mohsen would not be able to handle sessions back to back because he's an, I'm just making an example, introvert. After a number of sessions, he has to go and take a break. That would probably me, myself, but you don't see me doing it because I can't afford to do it today. Whereas, for example, Claudio, being an extrovert, enjoys being in the social environment and keeps doing it without blinking an eye. Just a hypothetical example, just knowing that these two would not take it against me. So, these things. And if that is the same thing applicable to crowd, I'm going to measure it. If a crowd is better able to handle safety stuff, I want to know how that can be measured. Crowd safety culture instrument, it is called. And I operationalize it in 5 different dimensions. I had the dimensions. I don't remember exactly what the dimensions are. Obviously, based on the questionnaire, you can see that attitude is one of the dimensions. Vigilance and situational awareness is one of the dimensions. Knowledge of risk is one of the dimensions. Knowledge of appropriate actions is one of the dimensions in 5 different dimensions. So the first step in capturing an abstract concept as abstract as crowd safety culture is to break it down into some less tangible dimensions. The notion of attitude is a little, some more tangible dimensions. The notion of attitude is more tangible than crowd safety culture, okay? So you can formulate a number of questions that would measure the attitude of a community towards crowd safety stuff. And overall, you would present it to them. They would say, agree to disagree on a scale of 1 to 5, 1 to 6, 1 to 7. Depends on the person who develops the questionnaire originally. And based on a number of questions, you measure attitude. Based on a number of questions, you measure crowd safety vigilance, crowd safety knowledge, action readiness, etc., all dimensions. So in my definition, crowd safety culture is a combination of all these sub-traits that would make a community inherently more crowd safety savvy compared to another community that scores lower. Okay, the development of these kind of questionnaires, it's similar to development of personality trait questionnaires. You come up with a list of, after you come up with your dimensions, your key dimensions, you come up with a list of questions, with a big list of questions, not just for attitude, with a long list. And then you do a stakeholder engagement. You ask people whether or not they think this measures attitude. This is tricky in this context because it's a very specialty subject. So there are not many people around the world that you can reach out to. Well, there is always a Claudio. I reached out to Claudio and some of my colleagues, and he commented on some of the questions. So any shortcomings in the questions, it's Claudio's fault. And they comment on the validity of the questions. That's the first stage. And but there is so much you can do at that level. You administer that long questionnaire that has so many additional questions that you do not need. If your final instrument is going to be 30 questions, you probably present 50 questions to people. And then you do a factor analysis. You remove the ones that do not correlate with the other questions very well, or they correlate too much, meaning that they are just replicate of other questions, factor analysis stuff, you know what I'm talking about. And then you remove some of the questions, you end up with a well-calibrated questionnaire. So basically the challenge is you have an abstract construct. How can you present a limited number of questions to people, 20, 25, 30 questions, in a way that measures that abstract in a reliable and valid manner? So that's the challenge. And we have gone through all these stages. The paper is under review by Safety Science. We had one reviewer. That review has been completed. I don't know, the editor has not sent it back to me. I hope it's positive. So if it doesn't end up being published in Safety Science, you know it's been rejected in Safety Science already. I had the name of, these are my co-authors. I was going to mention their name in the slide that is missing for some reason, so I had their name. So, some of the questions, do you want to see some of the questions? For example, and people score differently. On a scale of 0 to 5, people score differently. People showed in the Australian population that we examined, 1,200 people, the sample was. We realized that people score quite high on attitude. people score relatively okay on situational awareness. People score relatively low on knowledge. And when it comes to social norms, people score the lowest. What does it mean? It means that while people hold a positive attitude towards crowd safety, and they think they are crowd safety savvy, they do not think that the society regards crowd safety necessarily as an important thing. So they do not think the social norm of their community is strong towards crowd safety. They have a positive attitude individually, but they do not think the community of their peers have the same type of attitude, which is some interesting observation based on my experience. You see the variation in the scores. Some of the highest scoring questions were the questions of attitude. And in doing so, I also developed a sub-trait. Usually you have a trait that you develop, but you have a sub-trait of similar nature that is related to it in more specific terms. So I developed a sub-trait. It's called the Scale for Terrorism Preparedness. That, yes, crowd safety culture aside, it looks at the very specific aspect of crowd safety culture. And that is the level of preparedness of a community in the event of a terror attack, or in the event of a potential terror attack. So similar procedure was followed. This one is captured in only 3 dimensions. Originally, I envisioned 4 dimensions. One of the dimensions collapsed in the calibration process. We ended up with 3 dimensions: attitude, risk identification and awareness, and knowledge. So this is easier to capture. I was able to capture that in only 15 questions, whereas crowd safety culture being a broader concept and having more dimensions, I had to ask, I ended up with 25 questions. So that questionnaire is longer at the end after calibration of factor analysis. This questionnaire is fairly shorter. Depends on the specific application that you're pursuing. And it was quite interesting that, again, in the knowledge area was where people scored the lowest, knowledge area. People had positive attitude towards preparedness for terrorism, but they didn't think that they have enough knowledge of how to react to an actual case of terrorism or to a potential case of terrorism. For example, one of the lowest scores that we got was on this very simple question that I did not think people would score so low on. I have heard of the run, hide, fight advice in case of a terror attack, and I know what that means. In my view, I thought that, well, Codee being in that business, he's shaking his head. He agrees that people don't know about it. I didn't know until I investigated. People don't know about the most famous motto or messaging campaign that runs very broadly in the US, but also across the world in relation to how to react in the event of a terrorism. Most people said, no, we haven't heard about it. And that's probably one of the lowest scoring questions that we had. And across the board also, on knowledge questions, people scored very low, which to me, it was very surprising. And that is the whole point of developing the instrument. It tells me something about the community that I did not know previously. I know that people want to know about actions that they can take to keep themselves and their families safe in the event of a terrorism. They have a very positive attitude towards it. They are okay in terms of risk identification and awareness. They are really bad in terms of knowledge. And that's actually a very fitting combination. If they have a positive attitude, but they don't know much about it, there has to be some form of appetite to educate the community about actions that they can take to first spot the threat of a terrorism, to react early, to identify the threat of a terrorism when it is emerging or at the very onset that it's emerging, and how to react to it when they find themselves in a situation like that. The reason I'm making these examples and I'm lingering more on the terrorism scale is that terrorism preparedness is more tangible, less abstract than the safety culture. The questions are more tangible, I can more easily explain based on individual questions. Whereas the same notion, the same principle applies to the crowd safety culture instrument that is the mother or father of this instrument. Validation. If you're measuring, if what you're measuring here is measuring a real construct, there has to be some signals. The first and foremost measure that you could be looking at is the correlation between people's score on crowd safety culture and people's score on terrorism preparedness instrument. There's a very positive correlation. People who score low on crowd safety culture also scored low on terrorism preparedness, and vice versa. To me, that's a sign of validity. An invalid questionnaire, either of them, would not have produced this pattern. This is a very clear message of some sort of validity. Obviously, it's not the ultimate way of measuring validity, and there will be no ultimate way of measuring validity because it's an abstract construct in the first place. So there is so much you can do in the form of validation. However, things have been done. Trust me. Then I thought to myself, well, if the crowd safety culture thing is measuring something real, it has to have some manifestation in terms of people's behavior. It has to show in people's behavior. Well, I could not capture people in actual behavior when they were answering that questionnaire, but I could give them some hypothetical behavior. So what I did was that I collected images from some of the crowded events that have proven objectively risky, meaning, for example, the Love Parade disaster that has been proven in 2010 to have been an objectively risky scenario. It has been proven an objectively risky scenario. Or the Travis Scott concert on the night that it turned deadly, for example. Objectively risky. A near crowd crush situation in a station in Melbourne. An event that got cancelled due to poor weather condition in New Zealand. And I thought, let's see if people score correlates with their attitude towards being in these crowds. Would the score of a person in crowd safety culture instrument correlate somehow with how much they are willing or they are likely to join such an event or be in that kind of an event? And yes, the answer was yes. So we had people who were above average risk takers, meaning people who were quite okay being in those crowds. People who were above average risk takers. They were the ones that scored lower on the trait crowd safety culture. The above average risk taker, they score lower on crowd safety culture. The below average risk taker, they score higher on the trait crowd safety culture. Meaning that those 25 questions, potentially, their signal, have some bearing on the actual behavior of people, would probably manifest in the actual behavior of people. So that was another form of validation. As part of that survey, also I wanted to know what people think of the strategies that I showed you tested in the experimental condition. That's kind of independent from the notion of validation. It was just a side show that I ran on the side of, on the back of this survey. I just put these questions on top of it, okay? Because it was an opportunity for me to see what do people think about this efficient strategies that I prove in the experimental setting would improve the efficiency of the system in relation to exit choice decision-making, in relation to anything that was tested during those experiments. So I first asked them, what is the efficient strategy in terms of your reaction time? What is the efficient strategy in terms of your exit choice making, in terms of your social group behavior, okay? Almost none, very few people would come up with that efficient strategy as an answer, okay? Almost few people, very few people would give you directly the correct strategy, the correct answer. However, when presented as a binary option, do you think this strategy is better or that strategy is better? Quite a few of them actually choose the correct answer. So that shows to me, without the education, people would probably not choose these strategies that I am recommending in the actual event of crowd movement. Okay, this is not their first instinct. The very fact that they are not answering the right way means that that would not be their first instinct. However, when you prime their mind and you put that thing as a binary question to them, it is kind of intuitive to them to answer, yes, I think if I form a snake with my family in the event of a crowd discharge, the movement of myself and other people will be more efficient. So 77% come up with that answer when presented as a binary option of how about holding hands or forming a line when you are in a crowd. However, they would not come up with that answer on their own. So that's very important. And that gives me a signal that educating communities about these things is not going to be that hard. It's more of a matter of priming people's mind and bringing to the forefront of their attention and just influencing their instinct as a result of some level of very basic, superficial education that does not take too much to convey or to convince. People find it intuitive. People get convinced. So that's what I'm saying. Going back to the crowd safety culture stuff, it reveals demographical differences in terms of crowd safety savviness. For example, one observation based on Australian population is that female respondents scored significantly higher on the trait crowd safety culture. However, they scored systematically lower on the trait terrorism preparedness, which was an interesting observation to me. And older people overall scored higher on the trait crowd safety culture than younger people. In terms of the terrorism preparedness, however, I did not observe, based on that sample, any significant differences across old or young people. So that reveals individual demographical differences. But then you would say, okay, female respondents, they are scoring higher on crowd safety culture score. So in what dimensions are they scoring better? They're in 3 specific dimensions. In attitude, they score better. In situational awareness and vigilance, they score better. In risk aversion, they score better. Now you see the 5 dimensions. Thank God there's some trace of it here. Attitude, situational awareness, and risk aversion. Whereas in terms of social norms and knowledge, there is no differences across individuals. In terms of terrorism preparedness, why is it that male respondents score higher? It's only because of one thing. The self-claimed knowledge of males gives a higher score than females. Maybe they are more embarrassed to say that they haven't heard about run, hide, fight advice. Or maybe it's a genuine thing that they have heard more often than females. Maybe they have watched more, I don't know, Americanized movies about terrorism, et cetera, et cetera. I don't know. I have to tap into that. However, based on the self-reported responses, male respondents claim to have more knowledge of the right actions in the event of terrorism compared to females. And what is the ultimate test of this instrument? And what is the ultimate goal as to why I have developed it in the first place? The ultimate goal is to standardize this instrument, calibrate it. This is the phase that I have shown you, already done. And then later on, take the standardized version, which is the one that is going to be published, if any. Hopefully, if the reviewers of safety science are kind to me. And then translate that into as many languages as possible and administer the survey globally, measure crowd safety culture score across 20, 30 different countries, and then correlate that with the crowd safety outcomes of different countries, which we know about thanks to the efforts of Katsuhiro and my colleague Claudio. So we have this data. Manifested crowd safety events across the world. We know where actual adverse events have happened. Would it be nice to see whether or not score on crowd safety culture also correlates with this? And if that is the case, then I rest my case and I would say this instrument has been validated now. That would be the ultimate test of validation. But it's still a long way from here. I have to translate, I have to administer internationally, and then test against manifested risks across the world and see if crowd safety culture could be a predictor of crowd crushes, for example, where the people score lower. Is it the case that more crowd crushes happen? And if that is the case, in what dimensions are those communities scoring low? And what does that tell us? And how can we use that information to develop behavioral interventions and educational and training campaigns that are tailored to the need of specific communities and specific nationalities where areas of vulnerabilities are, targeting that. A crowd safety campaign that is suitable for a population in England may not necessarily be the same suitable educational campaign for people in Indonesia. It has to be tailored to where areas of vulnerabilities are, and I'm hopeful that the instrument would manifest those areas of vulnerabilities across communities and would facilitate development of such educational campaigns, ultimately improving crowd safety culture and adding a layer of defense to the communities when all external levels of safety fail, and it comes down to their actions so that they can protect themselves by taking very silent actions that would usually save their lives, such as not joining a crowd that is about to experience a crowd crush, or removing themselves from a crowd that is about to experience a crowd crush early, so they have more knowledge, more awareness, and have a better understanding of the right actions they can do. Thank you. Happy to take questions at the Q&A time and a panel discussion. Moving on to the next speaker. It's going to be my good colleague Meghna Verma. Also traveled from India, and she is an associate professor and the head of Center for Excellence Sustainability at Ramia Institute of Management, Bangalore, India. Her research mainly focuses on consumer behavior in tourism, applications of AR and VR, marketing of sustainable transport services, women's safety, and crowd behavior in mass religious events. I could not wait to hear about the insights that you're about to share with us. Thank you for accepting our invitation, and please come to the podium. Thank you.
Thank you so much, Professor Milad. I'm the second last speaker, and since yesterday, everybody has been hearing a lot of interesting insights from various engineering aspects of crowd and how to manage it and various dynamics of the crowd. I'm grateful that this session is based on the social science. Very good afternoon once again. And since I'm from India, as I've been introduced, so welcome and namaste to everybody. Before I start, because I've been seeing, and you might have been realizing, that my questions were very specific. Because most of the time, the research is in context with the Western countries, where the entire behavior and the system is very different. So before I present my work so that you can have a contextual understanding, I would like to ask you a few questions, if that's fine. Otherwise, I myself will answer. So first question is, assume a situation that you have to go to watch the World Cup football finals, or if it is Asia, it is the final match in the cricket, whether it is World Cup or IPL. Would you stand in a queue in the middle of the night, let us say 1 a.m., for a match to start at morning 9 a.m. or 8 a.m.? Will you do that? Please raise your hand if you will do that. Yeah, okay. Can I have the voice voting? Will you stand in a queue, yes or no, in the middle of the night? No, I'm glad you said that. Okay, a second situation. Okay, you have to stand just for 2 hours in the morning for your favorite game to start, but it is encroaching heat, let us say 40 degrees centigrade, or Celsius, sorry, or it is 38 degree temperature and you are sweating. Will you stand in that situation? 2 hours, minimum. Yes or no? No, right? This is exactly the contrast when we talk about religious gatherings. So the situation is entirely different when we talk about mass religious gatherings like Kumbh Mela. So it is very interesting to know why people in the middle of the night go there just to take a dip or a bathing in the river at a particular time when there is a sunrise about to happen. So it's a faith. Second thing is, during the daytime, like my case study is from Ujjain, the temperature was somewhere between, as what Professor Ashish said yesterday, 38 degree to 42 degree, 45 degree. Still, in the afternoons, people walk. So why do they walk? Nobody is compelling them, but they walk and walk and walk. So after my presentation, if it sounds interesting, I request all of you to go to the details of the current Kumbh Mela, which just finished in Prayagraj. You will be surprised to know people walked for hours altogether, on an average 3 to 4 hours, right? So what makes it? So the first thing, so when we were doing this Indo-Dutch project, which was funded by Ministry of IT and NWO, we were multi-country partners, multiple people. Fortunately, the scientist gave weightage to the behavioral scientist as well. And that, okay, in order to understand the crowd dynamics, it is important to understand the behavior of people. So the resilience is the most important element. And the entire behavior when you go to such mass religious gathering, it is that parameter which ensures your entire way, the way you look into an event. So it is a very relative term when we talk about a satisfaction to a particular event and going there and what do you do? It's really very, very relative, very hard to measure. It is only to be experienced when we are there. And that's the challenge we had, but we tried to capture it. So it is, I'll take you to a small journey, how we did that. So this is the flow of presentation. I'll try to present 3 of the published papers with different context. The first one is what motivates individuals to go to such mass religious gatherings. Second is, once they go, how happy, satisfied are they with respect to all the facilities, amenities available there? And would they like to revisit such events, not necessarily at the same place, but it could be some other place, but the similar event. The third is more from the organizer's point of view. When we talk about organizing the event, how the facilities should be provided in a particular event. So fortunately, in the team, when we were having the book on crowd management, I noticed 2 stakeholders. One is the organizer, and the second one is the visitor or the participants. So my entire presentation should be focused on those 2 aspects. So when we talk about the event Kumbh Mela, it holds mostly in 4 places in India. And if you see, it's very interesting in terms of a geographical part of it. The north, then we have Prayagraj recently happened. I'm also having the equal challenge managing it. So it's the recent one in 2025. And then we have Ujjain. This is the case study which I'll be presenting. It is in the central part of the country. And then we have it in Nasik. It is near to Mumbai, if just for the contextual understanding. In every 12 years, this event happened in one of these cities based on the various celestial combinations. In 2 places, Haridwar and Allahabad, it also happens in 6 years. That is called as Ardh Kumbh. Ardh means half, and the rest of the places 12 years time duration, and we call it as a Kumbh Mela. So you can understand the frequency of these events are pretty high. So if the scientist, the researcher sitting in this room decides to take this as a study, as an applied research, it will have a lot of direct implications on the crowd safety, crowd culture, education at the institutions, etc. So moving to the next one. This is a quick reminder because some of you were already present yesterday. It's a very heterogeneous crowd that goes. So one is the people who are into the religious practices. We call them as sadhus or the holy men. Then the rural India, the urban India, everybody goes there. Some are literate, some are not, including the foreign nations who goes there for various perspectives there and purpose there. So it is again an event which has multiple activities to be done. It is not like a football, or it is not like a cricket, or it is not like visiting one religious place. It's multiple activities to be done. The second thing to be remembered is it's a 45 days event in general. So some very few, let us say 10 to 20% of the population may stay there for 45 days. Rest is a floating population. There are volunteers, there are visitors. Some are just one-day person. They decide on 1 or 2 activities to finish it and come back. Some are 2 to 3 days. So it's a floating population as well. A very high is the floating population. So again, I can take a hop and hop off bus if I have one day, which is Saturday, to move in Seoul, right? So if I want to do that, I have the itinerary, I'll pick up my time, and then the whatever hop and hop off visits I have to do, I can do that. But in this kind of events, one has to remember that these are pop-up cities. These are not permanent setups. That's a classic difference. It is meant only for that duration, and huge preparation is required. So for a temporary city, again, to schedule your events is challenging, despite of lots of technology availability, which is already there. If you go to the internet, you'll find lots of information there. Otherwise, it's not that easy. So how would you do in an event and decide on your activities is a big challenge. So how would you measure their satisfaction in that case? I might have decided 10 events to be covered in 2 days, or activities to be done in 2 days, but I am ending up with 1, and still I'm very happy. So these are very interesting insights that we had. So sometimes, so you said that herd tendency, right? Imitation tendency. So many a times, you'll find in such places people goes and they says that, no, that place is overcrowded, so let us drop this, we will go there. And people go there. No. Despite that it is crowded, but you must do that activity. And then you follow it. So there are lots of permutation combinations goes. It's a very agile kind of a situation to manage. And the most important element, we talk about lots of preparation. So bottom-up approach is what is the only solution. You cannot have top-to-bottom approach because of the religious sentiments. So despite of the fact that the crowd may not be listening to you, you cannot be harsh on them. That's the basic rule in such management spaces. And that becomes a big challenge to the organizers. So it is very interesting to note that this city for which I am presenting the data, the 2016 time when we had it, it's a very small space, and a city is just 10 lakhs of the population, but I'll tell you the number. So this is the number I already had, if you could see, right? A city of 10 lakhs, that's population, actually had 75 millions in 1 month, and on a particular day, which was the last day, it was 12.5 millions who visited in 24 hours. Thus, we were there, as Professor Ashish mentioned last time, for 45 days. And we were also stuck up, we were not able to go to our camp. The vehicles were jammed, people were jammed, the city was not moving. Even despite of lots of presentation, it is just on the last day, because everybody wanted to witness. And imagine this number, which is only 75 million, and the current Kumbh Mela, which happened in 2025, just finished last month. Any guesses? If guesses or a general knowledge, which the number has been told in the previous session by Professor Ashish. Anybody remembers the number who visited the recent Kumbh Mela? No, it is 600 plus million. So the city, the pop-up city in Prayagraj was set up with a target of 40. Yes. That was yes. But the end up is 600 plus million people visiting there. So you can imagine the scale that we are talking about and how much experiments can be done. We can be prepared, but when we go in the real time, that's quite a challenging task. So this is, again, a couple of the videos of the similar type has been shown yesterday. Just a sense here. This is one of the major activity to be done is the bathing in the river. And that's how people are. So you might have heard about the recent stampede. So it happens at that small space. This is not the one. Here didn't happen. This is 2016. But this is the kind of the crowd. So when we talk about the presence of people and how do they becomes empathetic to each other is again a big challenge. And the religious faiths are so strong. I don't know how we can characterize. You talked about persona of the people and how can we do cluster analysis, how can we have different strategies there, but it's a mixed crowd. You will be surprised if you go and search more. You may find a 45 or 40-year-old son taking 80-year-old mother who could barely walk in this crowd and ensuring a dip in the water. So these are the activities performed. That's why when you asked about the water drones, they were meant for this, and no unpleasant incident had been heard, despite that hundreds and millions took the holy dip. So let us see. So these were the actual pictures. You never know as a researcher what kind of challenges you may face while collecting the data. We face these challenges because the weather prediction, I don't know whom to talk about, but we didn't have the kind of a weather prediction that it will rain very heavily. And the temporary city was on a farming land. So it was a temporary structure, everything collapsed, and still you keep working. People still keep coming. And these are the challenges you may face in between the data collection, and we faced it. So we collected the data from 22nd April to 21st May in Ujjain Kumbh, and the data size was 3,844. We plan to collect data both in terms of app and questionnaire. A 0 success rate with complete data through app, because it's not that internet was not available. It is because people were too busy. Either they can be in the part of that crowd in that temperature or fill your data. So nobody was interested. So we have to hire enumerators, which are mostly the college students who actually walked through with the crowd and ensured to collect the data. So we had that kind of challenge as well, out of which 2,326 we could utilize it for this kind of a study. So first is the motivation. I'll take you to the questions which we used the ordered logitic model there. So we asked various questions. What is the purpose if you to visit a place? Because every individual has a different purpose. We try to, through our experience, through our understanding of the place, we listed out a certain number of motivational things. And these were the 18 reasons, purpose or motives why people visit. So we ranked them. And this is what we found. So looking for new experience, understanding the historical and cultural background of the city, exchange of intellectual ideas, to take a holy dip, to see to this once in the lifetime, to give exposures to to children, otherwise they may forget it, to be just away from home. So we listed out all possibilities of visiting this place. And this is how we ranked them. Then what we found, so when we did the modeling here, we found these things. So we try to categorize who does what. So we found that old age people definitely are more spiritually inclined, so it's exchange of ideas, listening to sense, and looking into those activities. Young ones, fun, lots of other things. They want to do, males want to meet saints, while the females want to be together to the family and be there. Something very interesting like to take a holy dip. Low-income group wants a meaning in life, to meet the people with similar interest. Private employees to see this once in a lifetime. So there's a lot of combinations which came into picture. But trust me, if we try to do again the persona, it's very difficult because there are overlapping situations. We cannot categorize people in a very simple manner. So in the second study, we tried to measure how did they feel about the service quality, the facilities, the amenities available there. And so these are the kind of, as the picture already says. So it's mostly the pedestrian area. So basically, you have to walk. Some kind of electric vehicle might be there. Otherwise, this is something very interesting you may see. So these are carts. Hand carts. They are basically for keeping, for the vendors use it. But they know that people get tired, so sometimes it is also used to let people go from one place to another. But this was not a part of our questionnaire. But yes, the other facilities were there, so it is a restricted place for vehicles. But the bus goes to a certain place, and likewise. So we did the factor analysis, and this was our model that service quality, because I come from the marketing background, so we talked about service quality. Does it leads to satisfaction? was I being, how satisfied I was being at that place. And then event loyalty means revisiting the Kumbh, not necessarily Ujjain, but to others as well. We had multiple hypotheses here. So we first ran the EFA, exploratory factor analysis, and we divided them into the factors like service quality itself has 3 factors. Services available at Kumbh, like public transport to protection from the direct sunlight, and then various informations regarding this. Something very interesting regarding personal belongings. When you visit a temple, which is one of the major activities, we take off our footwears, and the bags and other things are not allowed when you are in the queue. So that is another challenge. So, how do you build up a system which is more time efficient and safe and secure? It's not just that. So imagine I'm going to 3 temples, and each time I'm taking out of my footwear and I have to keep my belongings into the locker. So the amount of management and the practices required is huge, humongous. May sound simple, but do remember the numbers. So satisfaction, overall experience, like spiritual experience, cultural experience, educational experience. Then discontent also, because not everybody feels so spiritually motivated that they will take a dip in the water. Some people look into the hygiene part of it and they feel that, no, I felt disgust like that. So we were unbiased when we asked these questions, and that's the factor came out. Sense of social economic equality, because everybody comes and they take the dip in the same water. And revisit recommendations, we had 2 questions there. And so we ran the model, and except the discontent there, rest of the things definitely had a positive impact, and people say that they do revisit despite of all the narratives that I have given to you. And that's what is proven fact, because with every year, every passing by year, the numbers are increasing. The last one is on activity. So can we sequence the activity, which in transportation, it is used the word trip chaining. Do we have set of defined trips so that the facilities and arrangements can be done accordingly? So again, this is very dynamic. Everybody does a different job, but we try to look into it. There were 5 categories that we decided to take as a researcher. Religious activities, the list is here. Personal care activities, sleeping, eating, likewise. Then eating activities, we kept it separate because multiple times you do that. Then recreation activities, it's not just visiting the places. There are a lot of recreational elements also with respect to culture, which has been set up in this temporary city. And then civic activities as well. So we classified them because people, different type of people and different type of needs. So we had a questionnaire based on it. And we tried to see which activities are done at which point of a time and which activity follow which activity, so that you can sequence it properly. So, here again, we ran the binary logic model, and we try to see who does what with respect to demographic profile. And pilgrims with lower education are more likely to participate in holy dip as compared to the people with higher education. Age group, higher education people are less likely to participate in personal and eating activities as compared to the lower age group. For the obvious reasons, their priority is something, and here, so if you see the motivation and this results, they are quite matching with each other. Because of the time limit, I'm not going to the detail of it, but this is something interesting which I would like to show you. Now, what we did was, which time of the day, which activities performed maximum? The idea behind is, can you deploy more resources at a particular time to a particular place for a better management? So this is what we found. And like, let us say, for an example, if you have a holy dip, so it is like, if you see it here, I mean, it's difficult. Okay, so what was there in this was, with each, if I click it properly, it shows me the activity graph. Okay, so just to explain you this, so if the activity graph is there, and we know, so if it is early morning, as I said, things start from the middle of the night, people start screwing up, right? And then you take a holy dip, so there might be a peak here in this 8 to 10 because of, again, a sequential importance there. Then you have a peak for some other activity, which is resting in the afternoon because it's a peak summer time, and then likewise. So once we know these peak, probably resource deployment can happen better for the later events. So that is what we did with respect to time. And then We also made a transition metrics. Which activities are done in which sequence? So multiple times you do multiple things. For us as a researcher, what we did was, then we classify them into these categories. Primary activity, the religious like visiting a temple and taking a holy dip, and likewise. The secondary activities, which is civic activities, then we put up something called as an anchor point to start and the ending points there, and the episodes, the frequency there. And we tried to look into the trip chaining. Now, if you see, there is no simple trip, very less. Only 4% follow a simple trip, probably because they visited the event only for a day. So they may just go for a holy dip. They'll think that that's more important than any other thing. But if you see 36.14% here, it's very complex trip. Primary activity, secondary activity, anchor point. So how would you do that? It says that you need to be well prepared for every single element and every single path, because there is a mixed things happening here. We also try to look into which mode of transport is used. As you can see, more than 80% time it's walking. So the pedestrians, because the temporary city is restricted to the vehicle. So walk is more, the area might be relatively smaller, but the time duration required from one point to another point is very high because of the sheer number of crowd. So summary is like this, which I've already said to you. It's a trip thing. It's a complexity, agile management is required. The one thing which I wanted you to draw your attention is we also looked upon how much a person is able to walk comfortably in such temperature and in such places. So surprisingly, as I said in the beginning, the resilience is high. So if you see the walking kilometer, acceptable average walking kilometer is much lower than 1.75 kilometer in the previously published papers. But here people are ready to walk 1.75 because of their resilience of the religious faith, due to religious faith. We also looked upon how the facilities should be available, at how many distance each of these facilities should be made available. So we also had, this is also a published paper, like food stall should be in every 450 meters, drinking water in every 655 meters. However, it is a religious gathering, so there are a lot of volunteers. So these are the set things by the government. In between, you'll find many volunteers. So based on the things required, they come forward and they support the event. So that is how these large events are done. As you said, the crowd need to be looked upon more as an ally and not as an entity. So these larger events are successful for the main reason that it becomes an ally. And that's probably is one of the reasons that over the years, this has been largely quite successful events. For the planners, it is, as I already mentioned, there are different dimensions given to social sciences studies. There are 7 papers published, and each has its own meaning. I have narrated most of them here. And so coming to this, the Kumbh Mela Prayagraj, I just would like you to draw your attention here. We already talked about it. So 500 to 650 millions already attended. It is recorded attendance. And on a particular day, which is 29th January, 57.1 million took holy dip. Now, in order to manage crowd, it was a 12-kilometer stretch of the bathing part. So where the crowd was dispersed out, but that's a number. A stampede happened at one place. I was showing you one of the videos, which was basically a Ujjain video, but if you see this one, it was more complex. It was a very small area where probably a balance was lost. It is still under investigation why this happened, but unfortunately it is said that 30 people were lost their lives. But if you see overall management, it was quite high, and we don't know why it happened. Now, in this size of an event, it is not just that pop-up city which matters. It is the nearby areas as well. Like Delhi is the main point, whether it is your airport or it is the train station. Another stampede happened there. This definitely we can call it as an element of mismanagement because of an announcement that happened in the various platforms that the train going to Prayagraj, the Kumbh Mela, is coming on a different platform. So it is like mix and match happened, and because of that pressure of boarding the train, this unfortunate incident happened. Otherwise, in the Kumbh Mela area, it was mostly managed good. So this particular element should have been taken better. There is tremendous role of AI and all kind of technology deployed this time, and it is ever growing participation, so I'm sure more technologies will be used. It is still, there are lots of researchers who are there this time as well who will report how their technology would be beneficial, and that's what we can also look at because it's a never-ending challenge. So this is again the size of the Prayagraj Kumbh, and the next Kumbh are already in pipeline, which will see more crowd and lots of challenge to everybody. But I'm sure with the help of technology, things could be much, much more safer, which has already been experimented in the current Kumbh. So with this, thank you so much for your time. These are the publications already. Thank you.
Thank you, Meghna. That was truly enlightening. And I didn't know that unknowingly I had created a final session with a social science being the dominant theme of the session. Thank you very much. I have questions, and I'm sure there are going to be many questions in the panel discussion. I'm looking forward to that one. Our next presenter is my good colleague, Hisashi Murakami, assistant professor at Kyoto Institute of Technology, Japan. He earned his PhD from Kobe University, Japan. His research interests include collective animal behavior, such as fish schooling, crab swarming, and human crowd dynamics, as well as their simulation and modeling. I'm very much looking forward to your talk, Hisashi. Please come here. Thank you very much. Thank you.
Okay, thank you very much for the introduction, and thank you for the organizers. So again, my name is Hisashi Murakami from Kyoto Institute of Technology. So now let's scale down a bit. Today I'll talk about collective behavior of pedestrian crowd in a crossing situation. And I would like to emphasize the importance of tracking multiple body parts movement. This is important, I think. Yeah, this sounds a bit specific again, but I think understanding the link between microscopic individual movement and macroscopic crowd movement is important for understanding collective behavior of the human crowd and for the crowd management. So before starting my talk, I would like to introduce our laboratory. So yeah, we are trying to understand collective dynamics in the living systems. So we are studying about the various collective animal behavior, like swarming crabs and schooling fish, and we conduct some experiment in the wild and conduct experiment in the laboratory. And from the observation, we construct some computation models. And by the way, I completely agree with the discussion by Mila-san yesterday that using computation models of collective behavior to understand and to predict pedestrian behavior is inappropriate, of course. But I believe that comparing collective behavior between a human and a non-human animals is, yeah, at least sometimes inspiring. So yeah, actually today's topic is also partly inspired from our previous collective animal behavior research. So we are recently focusing on the human crowd behavior, and again we conduct some experiment and making computation models, and one of our research was awarded by the Ig Nobel Prize with Claudio and Nishinari sensei and Nishiyama-san. So again, we are trying to understand collective dynamics. So our question is how collective behavior emerges through self-organization. And this sounds fundamental, but there can be various applications like crowd management and swarm robotics. So today I'll talk about our recent findings on the human behavior. So this is the background of our research, and as you know, human crowd shows various types of corrective patterns. You like this the video and the pictures. In this this shows the extremely dense crowd, and each dot represents each person. So there are several thousand of people gathering at one place. And as you can see, if people gather like this densely, they suddenly transition to turbulent flow or orbital oscillation, according to recent research, particularly when they were closely packed by the borders. So if this happens, these can trigger the deadly trampling of people. So this is very dangerous. But there can be other corrective behavior that can provide functional benefit to the work group. So, so this video shows pedestrian behavior in a crossing of Osaka, Japan. And as you can see, and of course you maybe you will know, but two groups of pedestrians walking toward each other spontaneously separate several lanes. This is called lane formation, and this can improve the traffic efficiency of pedestrian flows. And of course, there are no conductors and readers, and there are no planning to form this kind of structure. So instead, individuals locally interact with each other and finally achieve this kind of global pattern formation. So this is nothing but self-organization in pedestrian crowd. So corrective behavior of pedestrian crowd can provide functional benefit to the group. So that's why understanding interaction or underlying the mechanism of the interaction is crucial for understanding pedestrian behavior and for crowd management. So many presenters pointed out computation models improved our understanding of human crowd, and at first computation models started with the inspired from physical particle systems using like repulsive interaction, simply repulsive interaction. But recently, researchers introducing like cognitive aspect of humans, like anticipation of the future position of neighbors or some kind of decision-making process. However, most models, in most models, individual pedestrians are treated as point or like oval shapes, ignoring their physical bodies. So, but yeah, of course, human locomotion is achieved through body parts movement, like footstep movement. So this is very important to understand the relation between body parts movement and the corrective behavior. And recently, many experimental studies have suggested that how body part movement influence corrective behavior. For example, this 2021 paper clearly showed footstep synchronization occur in single file situation. Single file is like this. Okay. Single files is like that. Pedestrian form circular lane and moving in the same direction. And in this situation, footstep synchronization occur in a jammed density, and this can be deemed as optimization strategy in limited space because two consecutive pedestrians move the same side leg simultaneously can efficiently use the limited space. And also some research suggested, some experimental research suggested that listening or following to some auditory cue can improve pedestrian traffic flow. So this is very interesting. However, actually, pedestrian behavior is not always limited to one-dimensional, of course. We can move more freely and like two-dimensional. However, two-dimensional studies on the footstep behavior, footstep movement are rare. So there are many open questions like do footstep synchronization occur under the two-dimensional condition? And also in the case of single file, the structure of single file is guaranteed by the border condition. However, as I said before, pedestrians under two-dimensional condition spontaneously form the structure by themselves, like lane formation. Then, how these collective footsteps are related to the self-organization, like the lane formation. So our purpose is to address these kind of questions. Like we try to investigate whether footstep synchronization can occur even under two-dimensional condition, and we try to investigate the relationship between body parts like hood and shoulder movement and collective pattern formation, that is lane formation in this case. So now let's move on to the experimental setting. We conducted a bi-directional flow experiment under the crossing situation. And we constructed the experimental crossing like this figure, and the size was 10 by 3 meters. And this crossing was sandwiched between two waiting areas like this figure. So at the start signal, two groups of pedestrians walk toward each other, like when the traffic light turned green in the common crossing. And we recruited 48 participants, student participants, and we divided them into two groups of 24 each. And we set two experimental conditions. First one is a queue condition. In this condition, pedestrians walked during listening to the external auditory cue. This has a constant tempo of 2 Hz. That was normal step frequency according to our research. And so in this condition, I tried to experimentally generate footstep synchronization in two-dimensional crowds. And the next condition was no cue condition. In this condition, there are no external auditory cues, no auditory stimulus, so pedestrian participant walked as usual. So in this condition, we tried to check if the pedestrians spontaneously synchronize their steps. And of course, we tried to compare these, try to understand, try to compare the pedestrian behavior between these two conditions. And we used 3 kinds of measurements of body parts movement. The first one is the walking trajectory. We tracked pedestrian head trajectory. This is very common and usual way to study pedestrian behavior experimentally. And we also used inertial measurement unit, that is IMU for short, and we attached 2 IMU devices to the pedestrian both leg, and we obtained time series data of foot movement. And from this data, we identified the timing of heel strike of each pedestrian. And we used this for investigating the synchronization. And also, we tracked the both shoulder positions of pedestrians. And using this position, we calculated the body rotation of the pedestrians. As I mentioned later, we use this as an indicator of collision risk. So this is the video showing the typical trial of under each. Yeah, this is the queue condition, and like this sound. Yeah, we use this sound, and as you can see, they form the lane formation, and yeah, we observe that their footsteps is synchronized very well as instructed, and this video is the no queue conditions. There are no auditory cues, and yeah, they also showed very nice lane formation. And according to our observation, their footsteps are not synchronized spontaneously. And also, yeah, we also observed that the generated lane under queue condition was narrower than that in no queue condition. And also, yeah, body rotation under queue condition was larger than that under the no queue condition. And also, we observed pedestrian lateral movement under queue conditions were limited a bit. So from this observation, we investigated their behavior more quantitatively. So first, we start with footstep data, IMU data. Then to investigate if synchronization occurs, we first identified pairs of two pedestrians in the using the following behavior. I mean, like this picture, if one pedestrian follows the other pedestrian in front of him or her, then we identified these two pedestrians are making a pair. And we calculated phase difference between two pedestrians in pairs. That is difference of the heel strike timing between two pedestrians. So if this difference was small, yeah, footstep synchronization is occurring. So this is a result of phase difference between steps of pairs. And this left figure shows the result of under queue condition. And the horizontal axis is the phase difference, and the vertical is its distribution. As you can see, we observed the peak at 0. This indicates in-phase synchronization. That is synchronization of the same side leg of the two consecutive pedestrians, like right and right or left and left. And we also two peaks at minus pi and plus pi. This indicates anti-phase synchronization. This is right and left or left and right synchronization. So anyway, under queue condition, we observed clear footstep synchronization. This is just as expected because I instructed to do so. And on the other hand, under no queue condition, the phase difference was distributed uniformly. This indicates there are no footstep synchronization, or in other words, their footsteps are asynchronized. So we can say that pedestrians synchronize their footsteps only with auditory cues, but they do not spontaneously synchronize their footsteps. So we show another characteristics of footsteps. So even if footstep synchronization do not occur, the footstep duration can match between two pedestrians. So we calculate duration difference between steps of pairs. And I skip the details, but we observe that, like this figure, the under queue condition, the difference duration difference between two pedestrians are very small. This indicates their footstep durations were fixed. That means the participant followed our instruction very well. On the other hand, under no-queue condition, two pedestrians spontaneously coordinated their durations more than by chance. That is somewhat surprising. So far, I observed that under queue condition with auditory queue, pedestrians synchronize their footsteps and their durations were fixed as instructed. And under no queue condition, pedestrians do not spontaneously synchronize, but their footstep durations were spontaneously coordinated. Then how these corrective footsteps can influence to the lane formation. So as I said before, we observed the number of lanes under queue conditions are larger than that under no queue conditions. So I mean the generated lane under queue condition were narrower than that under no queue condition. So we quantified this using some clustering method. And as you can see, we observed, clearly the number of lanes under queue conditions is significantly larger than that under no queue condition. Then what does this mean? According to theoretical research, the width of lane directly influence the instability of structure of lane formation. Because if there are many lanes, many narrower lanes, the number of individuals at the interface between lanes moving in the opposite directions increase. At that time, if even small fluctuation like small swing can influence on the structure, like maybe destroy the structure. So according to that perspective, this result suggests that under the queue condition, pedestrians made unstable structure, and pedestrian without auditory queue create more robust structure. And we further explored the instability of a generated lane from the perspective of body part movement. And it is very well known that if pedestrians are walking toward each other, pedestrians sometimes rotate their body to avoid imminent collisions. So this is signaling the imminent collision. So the body rotation can be a suitable indicator of the collision risk from the body parts movement. So as I said, we tracked we calculated body rotation during lane development, and we wanted to know when the risk of collision increased during lane development. So we divided our data into 5 time stages like this. And this right figure shows the mean body rotation across the 5 time stages. And please focus the middle 3 stages. As you, red is no queue condition, and blue is queue condition. And as you can see, during these 3 conditions correspond to the development of lane formation and maintenance of lanes and dissolution of the lane formation. And during these time stages, body rotation and the queue conditions are always larger than the no queue conditions. So again, we confirm that no queue condition pedestrians create more robust structures than queue condition. Under the pedestrian and the queue condition have to make large body rotation. So we finally try to explore what caused that difference of the structure. And according to our previous research, lateral movement of pedestrians is important to form lane formation. So we calculated this, and lateral movement is like deviation from desired direction, and this can be easily calculated by the curvature of individual trajectories. And this light figure shows the mean curvature of trajectories of the each time stage. And please focus on the first 2 time stages. These stages are just development of the information. And as you can see, flexibility of the curvature of the trajectory under no Q condition is larger than that under Q condition. So this indicate pedestrians without auditory cue move more freely, and that can contribute to the robust structure. On the other hand, if pedestrian follows the auditory cue, their lateral movement are limited. So in this way, we observe that with auditory cues, pedestrians' footstep timings are synchronized and the durations are fixed as instructed, and they formed narrower lanes with high collision risk, and their lateral movement are constrained. On the other hand, without auditory cue, pedestrians do not spontaneously synchronize their footsteps. It was asynchronized, but they spontaneously coordinate their duration, and they form wider lanes with low collision risk, and they showed more freely exploratory behavior, lateral movement. So we can say that asynchronous footsteps or moving in their own timing can allows pedestrians to move more freely and can contribute to robust recognition in pedestrian crowds. So we can conclude this from the perspective of the body parts movement. That is, movements of one body part, foot, influence the group level structure, line formation, which in turn influences movements of another body part, shoulder. Okay. Okay. So as a next step, this year we conducted new experiment. The experiment I just mentioned was like a crossing situation. And we are now trying to understand the more continuous situation like shopping street bidirectional flow. And actually, a previous experiment was used single density and single tempo. So we used various density and tempo in this experiment. And we also tracked multiple body parts. And we expect that our experiment encourage the computation models accounting for the physical body of pedestrian. And as you can see, if we can obtain the better computation models, we can obtain the more reliable predictions. And finally, I would like to mention something. So synchronization in 2 dimensions are impossible. Of course not. And many papers evidence that 2 individuals walking side by side synchronize their steps. So there are many papers, many countries. So this is likely. However, there are little knowledge about more larger groups. So we also recently conducted some kind of human experiment, human group experiment, let's say a human swarm experiment. And we also, we instructed participants to stay together while walking, but they can decide freely their direction. And we also track the head movement and the foot movement. And this is very preliminary result, but we observed that in this case the footsteps are synchronized more than by chance, and also likely the extent of synchronization increase with time. And likely, footstep synchronization is related to the collective turn as a group. So this is a bit contradictory from our previous experiment. So this is our temporal hypothesis. Of course, we need some further data, but now we consider that during formatting groups, pedestrians do not synchronize their footsteps. But after making groups, particularly when making collective turn as a wall, they may synchronize their footsteps. So maybe asynchronous footsteps may be default mode, and they, make footstep synchronization particular time. Okay, this is the end of my slide. Thank you very much.
Hisashi, thank you so much. That was very insightful, and I think the incorporation of body movement in computational models, body rotation, this is a level of nuance we really need to incorporate into simulation models, and I very much learned about it, and I think use of auditory cues, influencing pedestrian movement using auditory cues, it is still an underexplored area in crowd dynamics. It was very interesting to see these findings of your research. I appreciate it. Thank you. Our last keynote speaker is also from University of Technology, Sydney. It is my pleasure to invite Codee Ludbey to give you a speech. I think we are going to finish on terrorism stuff again. Is that right? Okay, I'm looking forward to it. Codee is from University of Sydney, Technology, Sydney, a seasoned security management professional and academic known for his expertise in merging security placemaking and urban design principles to create secure built environments. Codee has a particular expertise in crowded places design with a focus on protective security and counterterrorism planning. I'm looking forward to your talk. Please welcome.
Hello, everyone. Thank you for sticking around for the last session of the day. I would like to thank the sponsors of this event for hosting such a great couple of days, and very happy to be finishing today for everybody. Today, I want to talk to you about the security of public places, principles and practices for integrated security in the built environment. I'm going to start with a bit of my professional background, specifically in the transport sector, to contextualise this conversation within transit-oriented development and railway stations. And then the second half of this presentation will dive into some of the preliminary findings of my PhD, which I'm close to finishing. So don't judge the findings too hard yet. I still need to finalise them. But I wanted to start with this quote from Mike Davis, Fortress Los Angeles, published in 1992. This was in a very difficult time in Los Angeles. Crime was skyrocketing, homelessness was skyrocketing, and we were seeing in the US this march towards more and more physical security protection and gated communities. And what he says is that the universal consequence of the crusade to secure the city is the destruction of any truly democratic space. This is before 9/11. After 9/11, we saw this supercharged even further. Public places have become very heavily protected, particularly in the West, and this is disrupting community bonds and making people feel paradoxically quite unsafe. As mentioned, I want to contextualise this just to give you an idea of some real-world examples of this within the context of transit-oriented development. So, as we continue to urbanise and more people live in cities, we see more rail precincts being delivered, brand new, and as part of those new railway stations, typically we find significant public realm attached to it. We want to turn railway stations into public places where people gather, can live, play and connect. It's not just a transitory area. Unfortunately, because train stations are typically quite crowded places, they also attract significant interest from malicious actors such as terrorists. To give you an idea of the scale of the investment in rail transport, just in the last 10 years, we've spent over $3.7 trillion on new railway assets. That's stations, that is rail, that is electrification and substations, that's maintenance facilities, and so on. Typically, when these assets are designed and delivered, we're thinking on at least a 100-year timescale. You don't build a train station to demolish it in 10 years. You want it to be around for the foreseeable future. But 100 years is a very long time to think about something like security and terrorism. And in fact, we find since 2000, there have been over 152 terrorist attacks on railway stations and rail infrastructure. This has led to over 200 deaths, over 1,500 people seriously injured, and over $2 billion in losses if you just consider the loss of the human life. This doesn't include impacts to infrastructure and repair cost. It doesn't include operational impacts. It doesn't include long-term tourism and GDP loss that you see after major terrorism incidents globally. So you can see for a small number of incidents globally, quite a significant impact, which means that security planners for critical infrastructure and public precincts have had to respond to this risk, sometimes in ways that may be slightly too risk adverse based on the true likelihood. If we look at some figures, it's very hard to estimate this. So we've gathered from a few industry reports that global security investment since 2015 is about $80 billion, which is significant in the context of station design, precinct design, and so on. So what does this investment actually look like on the ground? Rail transport is government, and government typically is quite risk adverse. So we end up with quite significant security infrastructure. This station, Crow's Nest Station, recently opened last year. It's part of a brand new fully autonomous metro network in Sydney. And Crow's Nest is in the outskirts or outer areas of the CBD. It's more of a suburban station. You can see on the street here the significant amount of security bollards. And three of these will run you about $150,000. So you can see where that $80 billion can get spent quite quickly. Some would argue that this is out of scale for where this train station is. And in fact, this bollard line extends the entire way around this building to the building across the road and the building behind it as well, because there are multiple entrances. Because we have significant underground infrastructure, the idea is to protect against a variety of threats, not just vehicles driving into crowds, but also standing off potential vehicle-borne blast events. So if we look even further at other stations on this line, a Barangaroo station, for example, which is much closer to the city, a significant amount of security infrastructure yet again. This is meant to and is in the centre of quite a community-orientated outdoor area. So you can start to see how security infrastructure spending can sometimes be out of step with the local community and the local area that it is within. Further examples, this is in the CBD. You can see the fixed assets next to the palm tree type elements, and then these blue blobs. These are concrete barriers that have been covered, and in fact, they're temporary, but they've temporarily been there for over 5 years. Circular Quay, if you think about Sydney, Australia, you're thinking about this area. Just to the left, you can kind of see it under the infrastructure here is the Harbour Bridge, and just out to the right is the Sydney Opera House. This is the preeminent destination in Sydney and arguably Australia. These temporary white hostile vehicle mitigation measures have been there for at least 5 years. So you can see how security decisions made in response to these terrorism risks can have long-lasting impacts on the city and urban life. So what we find is that security protection is driven by engineers, like myself, a recovering engineer, and by standards and international standards, which by nature, standards are designed to make decision-making relatively easy for professionals, but it does not always capture the local context by nature. They're international. They're meant to be good practice. What we find is security interventions that follow this standards practice is disrupting place. And by place, I mean the connections that we as humans make to public places. Think about your favourite park, your favourite walk. You know, you have this emotional connection to it. You have happy memories. You've shared moments with people there. This is place. It is how you respond to your local environment. Some great examples from the literature, for example, one in Federation Square, which is in Melbourne in Australia. The researcher Dali went out and spoke to people that came to this community and cultural hub that was recently delivered. It has significant amount of security there. And the quote is, "It's a bit scary when you see security coming to you all the time, being around all the time. I don't know if I feel safer or if I feel less safe. People always feel like they need to behave. It stops the space from being livelier." And then another quote from the UK around some of the legacy security infrastructure from the Olympic Games. "See all this security and all that? Does this mean this is going to be a high-risk place for a terrorist attack or something?" So we see, even from the community view, this paradoxical view of, I see the security, therefore I should be safe, but I feel unsafe. It's actually stopping me from wanting to enjoy this place. I'm thinking about security, and I think that shouldn't be the case. So why am I talking to you about this? Well, I've worked on a lot of public transport projects, over 300 kilometres of transit network, over 50 kilometres of tunnels, over 85 transit stops, ferries, light rail, heavy rail, metro rail. I've been responsible as the physical security subject matter expert for an $80 billion portfolio. I've been the author of the first multimodal physical security standard in Australia, and I was never told to think about this. No one had ever asked me to think about this. I had never been taught to think about this until I was challenged over and over again. I finally decided someone needed to think about this a bit further, and I started my PhD on this topic. So as we heard from Penella in her presentation yesterday, the traditional security design approach follows the Royal Institute of British Architects project delivery cycle. You start with strategic definition and preparation of the brief. This is the project feasible? What does it look like? We move into concept design, and the general spatial configuration of the project gets developed. From a railway perspective, how many entrances, is there an overstation development, where the lifts go, these types of things. We then move into develop design and technical design. This is where the engineers really get into the detail of where all the power outlets are going to go, where the cameras are going to sit, those types of things. We then move into construction. We build it, we hand it over, and then it goes into operations. Typically, security practitioners get involved in stage 3 and 4. All the big ticket configuration items have already been decided by the architects and the client before real security advice is brought into the project. And this, I believe, leads to some of these perverse outcomes in public places in particular. So I was following that approach, and as I said, there was a challenging moment that made me think about this a bit more deeply. And following that traditional planning approach of coming in later in the design, I was pulled aside by an urban planner, someone that I really appreciate. She's very, very good at what she does. And she was asking me, why do we need all these bollards? Like, it's just going to ruin the place quality and the place outcome. And we're sitting in the lunchroom, and I went through the usual spiel. As a security practitioner, you get sick of talking about bollards, so you just kind of automate the response. We need the bollards because we have a duty of care to our customers. We have regulations that we need to comply with. These are international standards. Everyone does it. I've spoken to the police and intelligence agencies. This is a credible threat. The usual process. She responded with, I understand all of that, but what's the point of protecting a place if there's not going to be anyone there to protect? Right. And after thinking about that for a minute, I asked her, what did she mean? And she pointed to a few other project examples where there was overt security and people weren't sitting on the benches that were provided. They were just transiting straight through. They were quite sterile places. So this spurned my desire to understand how we can better address security and urban design outcomes for the users of public places. And I stress the users, because generally this is an expert-led process with little interaction with the actual users who will be using the public place. So if we look at the literature, there's not a lot, but from what we can get out of the literature, we see this balancing act between these overt physical security controls, like bollards and lighting and screening and guards and police patrols and so on. This is to deter crime and terrorism. In the security literature, this is very important, this concept of deterrence. But what we see on the urban design literature is as that goes up, we start to see disruption of place quality, of connection, of liveliness, of accessibility, and so on. So we need to thread this balancing act between protecting people from foreseeable harm, but not disrupting the actual point of the public place that's being designed and delivered in the first place. So to understand this better, I'm a professional, but as any good academic, you need to step out of your own experience and actually ask others and make sure that you're on the right track. So I brought together 20 experts, 10 designers, so people from urban design, planning backgrounds and the like, and then 10 security practitioners, security managers of public places, security consultants who work on these projects. And I asked them what made public places safe from crime and terrorism. And I got them to brainstorm this. They came up with 73 unique design items that make public places safe. I then asked them to group and rate these so that I could run multi-dimensional scaling and hierarchical cluster analysis to come up with a slightly more rigorous concept map of how experts see public place security. I'm not sure why the image isn't coming up well here, but we have essentially 5 clusters of security intervention. So these outlines grouping the individual measures. And we have protective governance, which is the one on the left. This is things like response procedures, investigations, inspections, and so on. Towards the top, we have essentially preventative measures and deterrence. This is things like regulations and fines, visible patrols, security screening like metal detectors and the like. To the right of that, we have physical security. This is your typical CCTVs, bollards, other physical security measures like fences and so on. Below that, we have urban design and passive security. This is things like clear sight lines, having multiple exit points, green canopy, heat management, these more underlying design decisions that can influence people's behaviour. And then the last item we have is social and community factors. So these are more intangibles, things like social support networks, having coordinated neighbours in a precinct, eliciting user feedback about how a place is being managed and responding to that feedback. So this is how the experts view security in public places. But they disagree on the design approach, and that's a very useful image. I'll send some around if anyone's interested to see the full resolution. But essentially, if you can just make out the purple line towards the top, that's the urban design and the passive security measures there. So both groups, the left is the security practitioners and the right is the designers. They agree largely that those urban design measures are quite effective. Where we start to see the disagreements is the blue line, which is the social and community factors, those intangible elements. So the security group thinks they're still important for safe outcomes, but they're less for it, I suppose, than the design group. And I think this is because security practitioners like to be able to feel and touch and see the things that they're recommending to protect people. And then the other 3 items, which we also see a bit of difference in, is those physical measures, those overt physical security controls and deterrence, and so on. So when we talk about those different groups and how they look at public place security, I think we find that the design groups think more holistically about public places. We see they have a strong focus on those urban design and passive security measures. They use place quality and design as a key focus, and social cohesion and community factors are critical for their decision-making process. They see security, based on this data at least, as a subset of quality places, and I think they believe quality places are safe. And this is something I need to take into interviews to finalise, but this initial data is really starting to suggest to me that the security components of places is really just one element of place. Whereas if you look at the security practitioners, they see security more as an overlay of a place that's already been designed. And if you think back to that process of design, security comes in later, that would be a natural way of approaching that profession. The place decisions have already been made, you overlay your security controls over the top. It's not an integrated delivery. So we find that overt physical security measures tend to be more preferred by the physical security practitioners, which is not surprising. But what this leads to, both in the literature but also in practice, is this critical tension, which is again coming back to that balancing act we talked about. So we have these softer interventions, things like social and community orientated controls that is more focused on the users and how the place is used. And on the other side is more of that regulatory asset protection driver, which is those harder physical security controls that you can actually touch. And what's challenging is the capital investment to build a place gets pulled in both directions. You want to build a place that brings people and they spend money in your food and beverage and your retail outlets and so on, but you also want to protect your investment. And this is a push-pull that happens in the delivery process as well. So for me, the missing element, we see in the literature, the urban design, architecture, group tend to just talk amongst themselves and don't necessarily engage the security practitioners. Security practitioners also talk amongst themselves in the literature and they don't really engage with the other side. And part of this research is to bring those groups together, but really it's a tie-break situation. Like we have this tension between two competing objectives in some respects. So what hasn't really been done in the literature, other than those few more interview style quotes that I gave you earlier, is to actually ask the community what they want and what they expect and what actually makes them feel safe. So to address this professional disagreement, I asked 72 members of the community to rate those 73 design items on a Likert scale about how safe they felt or how unsafe they would feel if they saw them in public places. And what this leads to, this is just a sample of some of the items, but these are the overt security controls or part of them. Overwhelmingly, generally we see that these things make people feel safe, but there's a lot of people that also feel unsafe. So these are quite mixed perceptions on things like CCTV, physical security, signage, weapons screening, patrols, and so on. Passive interventions, those more urban design orientated elements, are overwhelmingly supported. So we still have a bit of this, a few people saying they don't feel safe for some elements like rules and behaviour signage, but much more stronger response on the positive side for these passive interventions. And if we use the Levain method to sort of turn this into a network graph, so each item or each measure is its own node, and the edges are sort of the correlation between them. We see that the community doesn't think about security as sophisticated as you would expect the experts to. They really just see it into two groups: hard physical measures and soft measures that are more underlying in the environment. So this is important, I think, because when we're making decisions as experts, we need to think about how the community is going to understand and respond to these, and having this clear model of essentially soft measures as hard measures helps us achieve this balancing act in the design process. Applying sort of a male-female perspective on some of the data and looking at some of the, I guess, more general or semantic type approach to the data, we see that men typically are preferring more physical, authoritarian, technical controls. They like to see visible security, and they like to have something that's a little bit more response-orientated. Women in the data, and again, this is in the Western Australian context as well, tend to see more community-led social controls as more positive. And I think this reflects on how men and women navigate through public places, knowing that the community is there and active and responsive, and everyone is a bit more proactive. I think make women feel a bit safer. Men, I think, don't think about that as much, and they like to see that, yes, there's a camera, yes, there's a bollard. So this is something that needs a bit more investigation, but it's just interesting to see the spread along these axes. And the other thing that is interesting about this is the security industry, the profession, is primarily male-dominated. So I think this is where we might start to see this preference towards overt physical security controls, because if men inherently like that and think that makes them feel safe, they're naturally going to make those design decisions from a professional perspective as well. So when we talk about what the community likes overwhelmingly, we see good lighting, well-maintained spaces, connective and cohesive community, clear sightlines, and having response procedures in place, but importantly knowing that it will be obvious that someone will actually respond as well. So these 5 elements really closely relate to something called crime prevention through environmental design. So we see that that is still a gold standard for how public places should be designed. Interestingly, the most controversial measures that had the least agreement were things like place inspections, so actively having people go and looking under in bins and the like for explosive devices and so on, so obvious inspections. Obvious security patrols or police patrols, so very heavy uniform presence. Obvious weapon screening points, so think about when you're going into a stadium or an airport, having these types of measures make people feel anxious. And probably only relevant to Western style communities, but video analytics was very, very contentious. So having the smarts behind the camera to do facial recognition, gait monitoring and the like, the Australian group really did not like that. But surprisingly, in the cohort, this was very consistent against age, cultural background, and living location, as well as education. So these positive measures are pretty broadly supported across the community data set. No. So talking about how to go forward from here and start to think about how we can embed this, talking about Penella's presentation yesterday, the need to bring security earlier into the design process, I think, extends beyond just you'll save some money, developer. It's also you'll get a better place quality outcome. You'll have more people coming and staying, which means they're going to spend more money, which means you're going to have a better return on investment. So it's not just saving money on security by getting us in earlier, it's also making it a better place. So what I think we need to start looking at is how can we reduce overt protection as much as possible? And that's not the same as removing protection, it's just finding new ways of delivering that protection in a way that's less obvious. So we need to balance this overt deterrence-based approach of trying to turn criminals away towards making it a better place for people to stay and live and work and play in, because that naturally will bring that safety and that security. It's harder to measure, and I think that's something that the research needs to start looking at, is how we can measure that more effectively. Importantly as well, we need to position security as a component of place quality as opposed to a separate overlay or a management planning process. So consider that safe places appear to be strongly related to community acceptance, and therefore community engagement in the security design process is crucial for fit-for-purpose interventions. Currently, the process of security planning is a very siloed, expert-led activity. We have risk management workshops with other experts and police and so on, and we never ever speak to the community. I think a lot of the industry is still hiding behind this is sensitive, secret, terrorism shouldn't be spoken about openly, particularly security planning decisions that are made. And yes, that does hold true in some cases, but bringing in this community viewpoint can mean that the security that we do deliver is actually fit for purpose. And this proportionality conversation about not wanting to spend too much or too little, not wanting to overinvest and be too risk adverse versus not, I think we can get a better read on that level of protection through community consultation and engagement. So counterterrorism, protective security and crime prevention strategies need to evolve beyond these hard lines of protection, these hard barriers, and find ways to build a broader resilience approach in the cityscape. So we can't expect security to be successful without that community involvement. And community ownership and acceptance of place provides this ongoing guardianship. So we find that if a place is well cared for and accepted by a community, the community will clean up after themselves, they'll report suspicious behaviour, they'll self-police each other in ways that are acceptable to that community group, which means you actually get better security outcomes over time. So going back to that 100-year challenge of transport precincts, yes, there will be active maintenance because it is a government-owned asset or privately operated asset. They need to clean the graffiti and the like, but if the community actually loves that precinct, they love that place, you naturally enhance the security of that place as well, beyond just the security guards that you're paying to walk around. So integrating security into the city fabric can increase resilience, and I think security practitioners need more understanding and more training into how to embrace place quality as a concept in their decision-making process. And just as much, the designers, the urban designers and the planners need to understand the security decision-making process better, as opposed to fighting it every step of the way. And I think this challenge of security wanting strong protection and planners and urban designers wanting none because it doesn't look great, it has all these other impacts. I think we need to find common ground and try and actively understand each other's point of view. And I think that will make a significant difference into delivering integrated security. We're seeing some steps towards this already. On the right here, we see the National Protective Security Authority in the UK. This is a quite recent publication looking at how to protect against vehicle attacks in the public place. Previous versions of this guide were a bit more overt in how you go about putting in bollards and the like. And now they're really starting to present this information in ways that designers can understand. It's more about principles as opposed to hard engineering requirements. So you can see things like chicanes and topography and having restricted and controlled spaces, using street furniture or level changes. This is more design language orientated as opposed to put bollards in that are rated to this type of crash rating. So that's it for me. I think I'm really looking forward to hearing from you in the crowd and having some great conversations afterwards. Please feel free to reach out to me on LinkedIn. This QR code will take you there, or send me an email if you have any follow-up questions. But thank you very much.
Thank you very much, Codee. I'm really glad we got a chance to finish on a high note of research, and what a wonderful research that you have crafted. This is a really well thought, well crafted PhD research. Kudos to you for making this really challenging topic. It's hard to navigate. You have navigated it beautifully, so credit to you. Thank you, and thank you for sharing it with us. We have the last panel discussion. We can make it shorter, maybe 20 minutes, because I have some announcements to make at the end about the next summit. Let's do it. Let's just have our presenters of this session, Meghna, Hisashi, and Codee, please join us in this panel discussion. I'm sure there are going to be many questions based on your speeches. So let's do that. And as usual, it's the last session. If you have questions from our panel members, it's open to the online audience as well. You've been bearing with us for 2 full days. I'm more than happy to take your questions. But to start with, any questions from the audience? I think Anton wants to go first, but he's no, okay. I put you on the spotlight. I don't know why. I don't know. Oh, well, now you have to ask a question.
Yeah, concerning the religious, the mass gathering, I was again triggered by the religious motivation, and then the presentation, Milad, of you concerning the crowd safety, let's say, the level, how they were educated or looking at it or averse. When I saw the ranking of the reasons to go there, I thought religious motivation must have been something like, you have to do it. But when I saw the rankings now, it was like also pleasure and nice to be there, and holy dip was only 0.6. So then I was wondering, like, okay, although you have a high level of, let's say, crowd management, security insights, and whether I would take the risk or not, I thought, okay, religious goes perhaps above your knowledge, but then it seems like, okay, you don't have to do it. So what are the thoughts about the two points, let's say, religious motivation versus the insights of Milad?
Yeah, so 2 pointers here. One, when I said that the whole management need agility in its management itself. So likewise, the number of samples which I had was just 2,000 plus, and the people who participates are in millions, right? Priority keep changing. I myself can contradict my study by saying that, you remember this January dip, which I said the maximum number took a holy dip, right? Look at the number. Everybody just flew there only to take a dip. I have my colleagues from Bangalore who just flew for that one particular day. So with time, with the kind of the population, things keep changing. So holy dip is still a top priority when you have so many things to do in a particular place. Now, again, with respect to 4 places where Kumbh Mela happens, the mass religious gathering, if I talk about 2016 COM for which the data I have presented, there are two main activities. That's what we call that as a primary activity. So if you see the activity pattern, you'll find everywhere the primary activity was listed. It means they have gone to the temple, which is Mahakaleshwar temple, that's a Shiva temple, and for taking the holy dip. So that's what I always say is in social science, we can always debate, and hence the observational data and the core knowledge from the place is equally important than just the results, which may have its own limitations because of the kind of people we might have taken as a survey respondent. Because not everybody who is available to give us the kind of the data. So it is still the topmost priority, but yes, there are a huge number of people who are going there, and trust me, this time it was more of a FOMO, like fear of missing out. It was happening as a Mahakumbh, and 144 years once it comes. So most of the youngsters, even my students, have been there. Mom, I have to go despite of the classes, because they don't want to miss out on this. So it is still at the top priority. Thank you.
And you want to know how I think of it from the perspective of safety culture. In my view, I think two types of crowd, Hajj and Kumbh Mela crowd, they need their own manual, their own study. If they are recurring events, they are happening at mass scales, they deserve their own to be studied on their own rights, as opposed to borrowing notions from crowd studies in general. They have very specific characteristics. They deserve their own manual. That's my view. In terms of crowd safety culture also, I think it's a notion that is not 100% necessarily. If you think of it as a personality trait, because I use the analogy to personality traits, it's a context-dependent personality trait too sometimes. It's fluid. Whereas actual personality traits are not as fluid, in the sense that in specific contextual crowds, in a specific elements, your behavior as a person, your risk-taking tendency, all of a sudden could change. Your risk tolerance can go up, your risk aversion can go down. A person that would have behaved differently in a train station in a crowd, all of a sudden during a religious festival could have a higher tolerance of risk for some reason. A person who would behave differently in a shopping center, in a crowded market, for example, in the crowd of a football stadium after the finals, during the evacuations, during the discharge of a crowd, they might behave a little bit differently. So when we talk about crowd safety culture, I think some crowds have to be studied contextually within that particular context. It's not necessarily countries that would define crowd safety culture. You can have crowd safety culture of Kumbh Mela crowd. You can have crowd safety culture of football goers in the Netherlands overall. There could not be a specific crowd safety culture attributable to the entire country, even though you can measure it. You can say that I approximate across the country, but the better way of doing it would be specifically measuring it within the contexts of interest, depending on the resources that you have to conduct that kind of study. So I know my answer was tangentially related to your question, but I thought it was an angle that was valid to share with you. Please.
I have two questions to Professor Murakami. About collision and rotation. First, about collision. Your research results, and based on your research results, there is more possibility to collide in the situation of Q. Without Q, the possibility of collision decrease. I think this is very meaningful to the public, especially public education. So should we educate the public based on without Q, and be cautious if you heard some queue. This is first question.
Yes. Of course, it depends on the situation or density. So in my case, I showed like a crossing situation. So if it's like a more mass event, the story would be changed. But yes, queue can influence the behavior of pedestrians. And what I'd like to say is that pedestrians have nature to generate organization spontaneously. So we have to avoid the how to say, yeah, we have to facilitate that kind of nature, right? So yeah, sometimes some kind of queue can how to say, block that kind of nature. So we have to consider carefully what kind of queues are effective or not. Yeah.
And the second question is about rotation, pedestrian or rotation of human, each human. Your research is in the situation of pedestrian walking freely, so no damage, no injury to body. But I found some experiments in the crowd packing or nearly crowd crush situation. Crowd rotation occurred. What's the difference and what is the mechanism of the rotation?
I'm not sure, but yeah, I think they are different. Yeah, in the case of crossing, rotation is like actively or intentionally, maybe, or maybe unconsciously, but yeah, kind of actively. But in the case of packed, densely crowd, it is definitely passive, of course. It is kind of differences there.
Thank you. Any further question? Okay. Motion. Yes, thank you.
I have two questions, one for Codee and one for Meghna. So maybe which one do you prefer? Okay.
We prefer Codee. I don't know.
So it's really, I never thought about this. Normally police or safety operators, they look down at a crowd and they say, we know what we are doing, we just do it and then cope with it. And you say, that's not right and we need some holistic approach or where the pedestrians or the crowd is in the center of the design. So in other branches, they do this also, like integrative design, where they want to develop, for example, a phone, and then before they develop the phone, they just don't do it, but they ask people what they want, and then they think backwards, you know. Do you think that in some cases, in some like event like Christmas, for example, in Europe, lately we saw that, you know, a lot of things happen. And now in Christmas, before you enter the Christmas area, you see there are barricades. And I think people, I don't know, they didn't ask, but I just have the feeling people accept those measures because they understand, they read the news. Do you think that there are some events that are just temporary? It's okay to look down at the crowd and just do it? And in other events, maybe we have to think over.
You know, you make a very good point, and I completely agree. I think the community acceptance and tolerance of risk changes throughout the year, and for major events like around Christmas time in Australia, Anzac Day, when we celebrate, you know, historic veterans and war-related events, where we see, I suppose, a heightened threat environment, and I think the community naturally knows that these are heightened risk times, so they are more acceptable of these harder protection measures. But the challenge is we generally know where, you know, New Year's Eve events are going to be held, So the security engineer desire is to provide permanent protection in that place so that you don't need to manage it operationally. But then you have a legacy of this infrastructure being there for the whole year when it's only needed for 1 or 2 days a year. So I think it can be more expensive and more cumbersome to manage it operationally, but in terms of the long-term impact to the community and the place itself, the desire to have fixed infrastructure should be looked at carefully.
For example, in terms of referring to the picture that you showed from Circular Quay, which is a prime location in Sydney. People frequent that, tourists. There are major events such as Vivid Festival. You said the bollards or the concrete barriers have been there permanently for 5 years. They haven't been moved. Am I right in assuming that during the Vivid Festival, they were still there? So can you imagine how much capacity reduction would they cause when a really big crowd going to watch a light show, trying to go back home, that's near a train station? How much capacity reduction the presence of those bollard or those concrete barriers would cause, and how that can spill back into the crowd and cause another risk? In the hope of saving some form of risk, we are creating another one, because the amount of them was quite heavy. The capacity reduction, I think 2/3 of the capacity of that laneway had been taken, and we have had near-miss crowd crushes in that very spot. And I've been looking at those things from time to time and thinking that this will be harmful for heavy crowds.
Yeah, and it's not to criticise the decision to put them there, because it's through an informed process of risk management. But I think we need to, as security practitioners, think, as I mentioned a bit more broadly, about the other place factors that we're disrupting or influencing through these decisions. We tend to be quite narrow-minded on just managing threat and managing human risk, and not necessarily thinking about the on-flow consequences of those decisions.
Yes, and I think in putting those barriers, you are trading off between two different types of risk, and you should consider, well, one is a risk that is kind of recurring. We have crowds in that area on a regular basis. Should measures be taken to at least use protective measures that do not occupy that much space? That would be a reasonable thing to ask, because the lesser space you take from the crowds during normal operations, you will still achieve that security outcome, but with less impact on normal operations.
So my second question, from your talk now, I know that from the last slide, that we have to pay attention when we read Verna in some publication. It's not always Ashish.
No.
Yeah, I was always assuming Ashish writes a lot of papers, but that's not true.
Thank you for discovering this today. So it's only in the behavioral studies that I am a partner. Yes.
Okay. So my question is, excuse my ignorance, I don't know really, but are there some institution that is, can we call like central crowd manager of Colombia that says how many people are registered, how many are allowed to come to where, and when it's closed, it opens? So is there some institution that does this year for year?
Yes. However, I'm not the right person how it has been decided. But if I give you the example of the current Kumbh Mela, which is Mahakumbh, which just got over, it was already expected by the government, which is Uttar Pradesh government, the state, that they were expecting 40 million. No, that's 400 million. I was talking in terms of crores. So that's the shift there. So they were expecting that, and it was quite publicized. I'm from marketing background, so the information with respect to ads, welcoming people across the country from all over the world was already there. So 40 crores were already expected, that 400 million. And it ends up with 600 plus already the visitors. And they had a count on this. So they were prepared that those many will come. And the preparedness was quite high, because the major activity, which is the primary activity of bathing in the river, because that's a very unique place. 3 rivers meet there. So it has its own healing, meditative, spiritual significance. So they knew that those many will come, and they know that the crowd will be difficult to manage. So there were lots of temporary bridges were made for emergency services. There were paths which were created, and the path was increased to 12 kilometers, which historically is just few kilometer within, which has the highest significance. But they needed to expand that. So yes, they knew it in advance. They understand the number of visitors, and likewise to different cities also, there's a method to estimate the numbers.
Sorry. Yeah, I think I understand it's every year. So, yes?
No, it is once in 12 years in a particular place.
Okay.
However, so there are 4 places, once in 12 years.
Okay.
2 places, Nasik and the current one, Prayagraj, they held it once in 6 years also, which they call it as Ardha Kumbh. So that is half of the 12 years. So yes, so 6 times you can say.
From organizational point of view, so 1 year before the event starts.
Well, no, many years before the event starts. It's
no.
like,
I just want to say, so how can I imagine this? Like, for example, just to give an example. For example, in Saudi Arabia, they have like a ministry of Hajj.
Oh, yes.
This is a ministry with people. They do nothing the whole year. Just that. That's their job. And what I wanted to say is, like, maybe 1 year before, they will come up with a group of a team and say, now it's your job to do this now for this year. Or how does it work?
yes, so there is a separate Mela authority, which we have also experienced. So from central government to state government to the local administration, there's specific team which work. And I think Professor Ashish is the right person to give you the answer there, because he has dealt very closely with all that team. So if because it starts, I think, at least 4 years prior to the time. Because
actually, typically 4 years before the start of the event, a full-fledged Mela authority is formed by the state government. So there are 4 places. Each place is in different state within India. And that state government will form a full-fledged Mela authorities 4 years before to start the planning process with a full-fledged, full-time deputation of government officers, including the administrative officers who are the cream of our system of government, to start planning the event. So they take 4 years to do every aspect of planning. So that's how it is done. So there is no central ministry for all the 4, but there are authorities being set up typically 4 years before the start by the concerned state government.
Thank you, Michael.
Since I've got the mic, so can I ask questions?
Of course you can.
Yeah. So quite interesting session we had. So one question is for Professor Hisashi. Quite interesting experiments you did with the queue scenario and no queue scenario. And I was wondering if you have done some more experiments on related things. For example, in some of our experiments with Komela data and experimental data that we have done is how single file movement actually has a bearing on the crowd dynamics parameters, especially in terms of flow and speed. What we observed in some of our experiments was that if the administration creates hard barriers, and which is like movement of single files, and the presence of those hard barriers and ability to hold them and move quickly actually has a good effect on increasing the flow and speed, but also the safety, because you are able to reduce the physical forces within that single file. Likewise, even software measures, for example, having arrows on the floor to basically guide people in which direction and which lane they can move, also has a good impact. We have actually tried it in some of the occasions in our institute event as well, where we saw some nice results. So have you tried these kind of experiments? If not, it would be interesting to do.
Actually, haven't tried, but Claudio or Nishinari Sensei already tried. And as Nishinari Sensei said, probably if you use some kind of barrier or boundary, so you use this completely, like, yeah, completely different movement. Yeah, actually, previous experiment by Claudio showed that, for example, if there are many big group moving in the same direction, but there are very small kind of people are coming toward from the opposite direction, that situation is more like, how to say, higher risk of the collision, or more chaotic behavior can so found. So yeah, as I said, yeah, if we use the boundary or something, we use this completely.
Yeah. The other related question was that if your experiment has groups, for example, if you create groups,
so you mean human swarm experiment? No?
Sorry?
Human swarm experiment. Last one?
No, the queue and no queue.
Okay.
So within that, if you have people who are in groups, and you give them instruction to remain in group or be along with your group members, maybe the kind of queuing and without queuing, you might get some interesting insights if you have not tried. Presence of groups within this whole. Yeah.
Actually, this kind of experiment is all again done by Claudio.
Okay. So I'll talk to him later on. Okay, just a question for Codee. I mean, interesting insights about the presence of security and how people perceive it and so on. Sometimes invisible security might have some bearing, for example, more extensive use of technology, AI, etc., but not being visible in terms of presence of security personnel. Is that an angle that you have tried studying?
It's a very good point. In the security industry, we have the term techno-fix. So using technology to try and solve all of the security problems. I think technology has a very important role to play in terms of alerting for suspicious behavior and administering a response, but you still need someone to actually do the responding. So I haven't yet dived into the details of technology, and I think, as we've seen in some of the preliminary data, that in the Australian context at least, some of those smarter decision-making tools around CCTV and facial recognition is actually very controversial. I think that's a very cultural question as well about what is acceptable and what can actually support those security operations without...
What I was saying was the perception of people, whether they feel safer with invisible security versus, actual presence of security persons.
Yes. So those passive measures that were very well supported, they made people feel very safe if they could see what was around them, for example, with those natural sight lines and the like. So yes, we're definitely seeing that in the data.
Thank you.
Maybe a last question, if any. If not...
Mine was just kind of in the same vein as that, but I was interested in, Kofi talks about stealthy security measures, which is sort of an in-between, between the invisible and the overt that you've looked at a lot. My question is related to the male and the female, which you talked a lot about the sort of hardening effect of the male preference and then the softer measures in the female. Where do you think, and do you think there's a place for stealthy security to sort of be that in-between Goldilocks effect, if you will?
Yeah, definitely. And when I'm saying we need to integrate, I guess, security into the streetscape, that's essentially what I'm referencing, is how can we use more landscape elements to still provide that overt protection, but it just looks different. It doesn't look like a bollard. It looks like some other intervention, for example.
Thank you very much. I think that's it. Wonderful. Round of applause. Thank you. Thank you very much. Thank you.
Thank you so much to the scientific.
Thank you. Thank you. Wonderful. I am still left. First of all, I'm going to thank all of you for being here with us during today and yesterday, making this event happen.